camera.
Okay.
Go ahead and give us your name.
Okay. Yeah, I'm Matthias Ram. I'm Matthias Ram. I'm originally from Germany. You spell the name Matthias, and the H is silent. In Germany, just Matthias. But for you guys, to make it easier, I just go by Matt Ram. I live here the last 10 years in the States and used to live quite a long time at the East Coast. And 2.5 years I got relocated to Chicago. That's where I have an apartment right now and support you guys here in pretty much in the Midwest, wherever you need me.
What is your title?
That is a good question.
You are Lenses Development for Kamau, dedicated for Kamau.
I am right now the Field Application Development Engineer. You probably, I can introduce myself with that. Yes, I don't know if that really makes sense because one of our commercial guys came up with that, but
we are going to be having the VFD software training. As you can see, we're going to be videotaping this. The intent is that you guys ask a lot of questions so we can use this as a reference in the future for our teams as a training tool and also a reference for you guys if you didn't take all the notes that you wanted to take. So what I'd like to do before we start is just do an introductory so everybody knows who everybody is. In case you haven't been here before, actually, has everybody been here before? You guys know where all the restrooms are and so forth? Okay, excellent. There is a sign-in sheet. We will have lunch at about noon today. I have no idea what it is. The admins are going to take care of it. And we are going to be having this as an informal training. I don't have a break scheduled, so it really depends on where we're at on the discussion. When somebody needs a break, let me know. Or if you just want to get up and go do your business, that's great. I don't know if there's smokers here that need a formal break, right? Yep. Okay, so we'll just let us know when you guys need a full 10-minute break, 10-15 minutes, and we'll schedule that.
So break truck still come at 9?
What's that?
Break truck still comes at 9 here.
Yeah, you gotta get after a couple minutes.
So we're gonna break at 9:15?
no, that's too late.
That's too late?
We have to break at 8:55.
Yeah.
If you want, yes, sharp.
He comes
All right.
early and leaves.
Okay, so we will, Matt, you want me to let you know? When
Yes,
we're-
please.
all right, Okay, so I will be on time patrol, and that's about it, okay? When you guys introduce yourself, please give us your name, your company, and what you do for the company, and then if there's anything specific that you're looking for in this training. That last part is critical to make sure that we cover what you're looking for. Okay? I'm Daisy. I think everybody knows me. We'll start with Matt.
Okay, yeah. My name is Matthias Ram. I'm originally from Germany. You spell the name Matthias. The H is silent, so therefore I just go normally by the name of Matt Ram. I work for Lenze, that is your supplier, since 2000. I started there in Germany, and then in 2003 I got relocated here to the States. Lived quite a lot on the East Coast, and almost 3 years ago I got relocated to Chicago. That's where I have an apartment right now, and since, or maybe the last 2 years, I'm supporting you guys here on this project. Yes, my title is Field Application Development Engineer. That basically means I do field service work and I develop the new applications, and yes.
I'm Bill Fong, and I work for Lenze also, and my role is project manager.
I'm Brian Klein. I work for Triva. I am a controls detailer.
I'm Stephen Hilton. I also work for Triva. I'm a controls engineer, looking to learn as much as I can about the software and the hardware side of things. I just started, so as much as I can learn.
I'm Richard Rutledge. I work for Kamau. I work in GSD. I work with standard product testing.
Mike Lukard, work for Triva. Looking to get out of this basic startup of all the drives systems that we need, including setting IPs and some of the diagnostic tests that we used to do on some of the other drives as far as checking direction and some of those basic diagnostic functions.
I'm Jonathan Hindley. I work with Lateral Solutions, Chris Emmerich, and I'm a software engineer. And basically, I'm just looking to get out of just a generic overview of the information and more about the programming.
Sean Gutierrez, I work for Triva. Anything I can get from Matt.
Edward Chambers, I work for Kamal GSD Group in mainly field support. And any additional knowledge I could get from Matt about the Lenza products would be helpful.
Tim Featherston, I work for Kamal After Sales Training and Documentation Specialist, and really any background information to help make our manuals better.
Jim Letelier, aftermarket for Kamal. Basically the same thing as Tim. Just here for mostly overview stuff and anything that can help us better our documentation for our customers.
All right, okay. Then I start with the agenda. The Lenza company overview. Normally I would give you now a PowerPoint presentation, but since I've been in the field for the last 3 years, I really have just an old one. Lenza, the headquarter is in the northern part of Germany. You maybe know the small city of Hamelin. If you don't know it, you probably had heard that you have to pay the piper, and this story plays in Hamelin. So everybody worldwide knows that story, so you kind of know a little bit Hamelin, and you know where Lenza comes from. Lenza bought maybe 15 years ago a company out of the East Coast, AC Technology. That's where we have our headquarter here in the States. There we have local manufacturing and employ like 200 plus people. They do a lot of manual labor, do the boards for VFD drives, and yes, that is on the East Coast, like an hour and 15 minutes from Boston. And we also have a mechanical facility in Glendale Heights that is in Chicago, in Illinois. That's where you get all your gearboxes from. In addition to that, we have the manufacturing in Germany. We have the gearbox plant, the electronic plant. We have another electronic plant in France. And then we have a couple of other smaller plants worldwide. As I said, 2 here in the States, some in China, like everybody else. All right, the supports and the names. Basically almost everybody here in the group knows me. So if you have a service-related request, that would be normally Jim Reinwald, the service manager. Then I work for the service department, so he's my boss. Then there is, that's me, my cell phone number. A colleague, Elmar Prihoda, he lives here in Detroit. That is his cell phone number. He's probably even working today at Shep. We have to move that up a little bit. Yep. Then the program manager or the key account manager is Bill Fong. That is the guy here to my right. And the Lenza rep, you probably know him all. That is Chris Somerek. He also lives here, and he knows the drives pretty good. If you have a programming question and nobody else is available, he probably can also help you out.
Can you move that down a little bit, please?
Down.
So I can see Jim. Up a little more. Okay. So what I need you guys to understand is, first of all, the location of where our components are made is going to be critical, because if you guys have any question at all, or in case somebody asks you, the VFDs are made in Germany. The motors are in Italy, I believe.
Yes.
They're assembled, the motor and gearbox in Glendale Heights.
Yes. Mhm.
The VFD is also assembled with the motor gearbox in Glendale, and they are tested specifically for us at Glendale Heights. Jim Reinwald is the service manager, and he is in charge of all our application support in the field. Elmar works for Jim Reinwald. There is a difference between Elmar and Matt. Matt is dedicated to Kamau for development. Elmar is an application support. So when you are in the field, Elmar would be your first choice to call. If there is a development question, this is more for Sean and the Triva guys because they are part of our development for the PLC, Matt would be your go-to person. Okay, so that is the difference between the two support teams that we have currently from Lenza. If you have questions with regards to availability of the part, our Kamau folks would be the go-to people. They in turn would either get a hold of me or our after-sales folks. In the event that they can't, Bill Fong would be a go-to person. Is that clear?
Mhm.
Excellent.
All right. Right. So, yeah, we have here a couple of presentations I can give you also later on a memory stick. This one got created, I think, by Jonathan. And maybe a little bit of background. I mean, the application overall, the power roll bed, that's nothing new for you guys. You did it the last 10 years with different suppliers, Allen Bradley, Emerson. And in 2006, Lenze came out with a decentralized drive. Here, a pretty big one, the contactors. And we tried there the application. It was working, but the drive by itself was just too big. So we had to wait a little bit. And then in 2009, we got a new series of drives out in the field, the 8400 series. That is this drive here. That is the 8400 series. That is kind of quite powerful with all the built-in functionality. And yes, in 2009, I came here the first time. Maybe it's hard to see, but this one is me here sitting next to a power roll bed and making the application work with a normal panel-mounted drive. And the main reason why we did it with that drive was we knew that a year later we will get this drive, the IP65 decentralized version, the ProTech, and the software, the internal software between the panel mounted and the ProTech is more or less the same. So we knew if we can make it work with this one, we just have to transfer the program to here, and then we are basically where we want to be. And the whole idea of this project was also to get rid of the panel. Right now, or in the past, you had a panel with a drive, and you had to wire it up and so on and so on. And now the solution is you have the drive sitting right on the motor, and yeah, you got rid of the panel and have way less problems with miswiring during the startup. That makes the whole system way slicker during the startup. Oops. Yep, here, that's a general overview of the ProTech. That is one of the first pictures. That is a standard ProTech. You will see a few modified ProTechs. I will mention it. Basically, on the left side, here you have the control board. Here's basically all the brain. On the right side, there is a power board. On the button, you have the communication. Oh, it's in its way. Okay. Yep. Here in this area, you have the communication and I/O settings or connections. That is Profinet or Ethernet IP, digital inputs for encoder feedback and maybe for limit switches. Then we have, in this case, Harting connectors for the power. For the new installations, we use here Molex connectors. We have 2 connectors now. We have a connector for 24 volts, and we have another one for 480. Then we have on the right side, where the power part is, we have a connector for the brake resistor, and we also have a special connector for the motor. This one is a standard connector, and what you guys got is here. Maybe you can see it here, this nicely designed connector, the right angle connector that's bent backwards. Because again, the idea is that the drive sits right on the motor and then it disappears. The motor connection just runs into the terminal box, who is like 5 inches away. All right. Yes. On the top of the drive, you have a disconnect switch. Inside the drive, there's a circuit breaker. So if there's an overcurrent, a short circuit, and the circuit breaker will trip, then you will see that the disconnect goes from the on position to the off position. You have here, in the I/O area, you have an 8-segment or 7-segment with display with a couple of LEDs. I can show you a couple of pictures. And below this cover, you will also see that later on, that is another key feature of the drive. You have a removable memory chip. That means if in the case of replacing an already commissioned drive, you can do that all without having any software or any kind of special tools. You just have to take the drive, open here the cover, oops, bend it up, and then in this section here, there's a memory module. Normally when you have a small screwdriver, I don't want to break my nails, you just pop it out, have the memory module, replace the drive, put the old memory module in the new drive, and then you're almost good to go. Depends a little bit on the style of drive. If you have safety parameters, you have to confirm it, but we will see that later on. But I think you all get the idea that it's intended to have a really quick turnaround time. Yep, that was one of our first prototypes here in the Blue Room. As you can see, it's mounted right on the motor. That was one of our first designs. Again, here the hooks for the drive are a little bit different. Now they look more like a hook on the mounting plate. Also, the mounting plate is a little bit bigger. It goes like this. And then on the right side of the mounting plate, you have the brake resistor built in. In this case, the brake resistor was remotely mounted somewhere on the power roll bed. You can see here the cable disappears somewhere. On the new one, it's really one compact unit, everything on that mounting plate, and that mounting plate is mounted to the motor. Maybe what's nice to know, also what we use, that motor is mounted to the gearbox, but you also can get the motor what we call as a foot mount design. So sometimes you want to mount, for example, you want to drive a big fan with your motor. So instead of mounting the motor right into the gearbox, you would have maybe a pulley from the motor, and you would have on the motor, you would have foot mounts that goes right into the concrete. Okay, and so what we did, we were using the same foot mounts, and now mounting here the mounting plate to the motor. So that's the intention, or what I want to say is this whole mechanical solution is pretty stable. I mean, it's, yep.
I have a quick question.
Yes?
When you make that plate bigger, do they like turn where the brake is on the motor up to the top or something so you can still use the brake, or?
That's a good question, and we came up in, I think in the past what we did, the problem is if you would turn it up to the top, then you probably will have a lot of weld slugs falling in, and we were thinking about to maybe put a magnetic cover in it, but then if you put it on a power roll, on a Versa roll line, it is really hard to access this. So I think for right now, it is on the other side, on the back side. Oh no, sorry, it's down. Right now it's down. That kind of works for a Versa roll line.
Yeah, that way slide doesn't.
Yep, but on a power roll bed line, it's a little bit tougher to handle because now it's kind of close to the ground.
Plus, wasn't there an issue of if they left the rod in when a repro? There's a clearance issue.
There are differences, as Matt mentioned. The Siemens version, which we have for Toledo and Shaft, is similar to this. The improvements that Matt was talking about, where the brake resistor is directly mounted on that plate, is for the Ford Ethernet IP version. So as we have grown with the product and the improvements have been integrated, you'll see the differences in the field, and this is for the after-sales folks. Okay, so the Toledo and the Shaft programs, you're going to see something similar to this. But for the P552 program, you're going to see where the brake resistor is directly mounted on the plate. I'm telling you that because of the fact that when you see those differences, you'll also see the differences in the connector style.
Okay.
Okay? On the Siemens version, we still have the big Harding connections, and you'll see the Molex to Harding adapter on the bottom, whereas for the Ethernet IP, that's all been cleaned up. You won't have that adapter anymore.
Okay.
Okay? That's one of the bigger clues that you'll have when you look at it first off the bat as to what you have. Keep in mind the differences if you're looking at the drive only. That network communication is the same thing. It's an Ethernet. So it's not going to be clear when you're just looking at the drive as to what you're looking for. When you're looking at the spare part and you're only looking at that component, it's not tied to the equipment, that's your biggest clue.
Okay.
Okay?
Yep. Oh, here we have, maybe put this together that you maybe can see it. I hope it's not in its way. If not, let me know. Yep. As Maisie mentioned before, through the process, Toledo, Sterling Heights, 552, we did some improvements, and you can see them pretty much in those two pictures. I mean, in the picture and here in this drive. This drive is something similar that we use in Toledo with the Harding connectors, with the push-pull connectors for the Profinet. Yep, that would be what we use in Toledo and in Sterling Heights. And then for 552, the main difference is there that now those connectors for the power, the 24 volt, is now on the left side, and it's a Molex connector. The 480, it's on the right side. It's a Molex connector, and the brake resistor 2 is a Molex connector instead of here's the Harding connectors. And also we changed the I/O connection from Ethernet standard to M12 connectors. Yes. the other main difference between the Chrysler project and the Ford project is this communication card at Chrysler is a Profinet card. The one for 552 is an Ethernet IP card. And we do there the drive-based safety a little bit different. But I guess we will do that a little bit later. Okay, then we try to, the bigger drives, 7.5 kW for the VersaLift, 11 kW for the elevators, and 15 kW for the elevators that we could not do in Sterling Heights and in Toledo with the Protec. We had to do with a panel-mounted drive. That is this one here. Yes, we basically use overall, I think, 4 different power sizes. We use a 4 kW in some applications in Toledo. Then we use 7.5 mainly on the VersaLift. We use 11 kW on the 2 and 4 column elevators. And for the 552 project, we changed it a little bit. For 552, we were able to get this drive also as a 7.5 kW version. And the main difference is it has a big heatsink. Sorry, it has a big fan on the heatsink. So then it's rated for 7.5 kW. So for all the Versa lifts, now we also use a decentralized drive. And the only, or one of the few places where we have to use panel-mounted drives are now the elevators, the 2 and the 4 column elevators. And there I think they designed the elevator, and now we go with a 15 kW drive. Again, the nice thing between those drives, even if the package looks different, internally the processor is pretty much the same. The programming, the touch and the feel is more or less exactly the same. Also, this drive offers you that memory chip. I got it out pretty quick. So here, this tiny part, I don't know if you can see it. Here, this tiny part, that is a memory chip. There's a whole program, all the communication addresses stored on. And once the drive is commissioned, and you need to, or somebody needs to replace it, maybe in 2 years or so, they just have to put in a new drive, pull out the memory chip from the old one, put it into the new one, and then they're good to go. Here in this area on the drive, you see the communication card. On the panel-mounted drive, it's detachable version, so you can pull this off. And if you want, you can put in, for example, an Ethernet IP card. In this case, it's a Profinet card. So also, Lenze manufactures this panel-mounted drive in 3 different flavors. In the normal configuration E, that means like built into the panel. What you guys normally use is a push-through variant. That means that the heatsink is on the outside of the drive. So in your cabinet, you normally have a cutout hole, and the heatsink is on the outside, and that will roughly separate or 65 to 70% of the created heat to the outside. And then there's another version that you also use, that is the cold plate version, because, I totally forgot that, on the tool tray application where we use a 37 kW drive, that is a really big one. Lenze does not offer a push-through variant, therefore we use the cold plate version. That is basically a drive who looks exactly the same like this, but it just has no heatsink and it has a total flat back. And what we do is we take this total flat back, put there some thermal paste on it to have a better conduction, and then just put it on the back of the panel. And we did some testing with the duty cycle and the amount of energy that gets generated by the drive. It is still enough cooling capabilities there, so we don't see there a problem.
Is that an air conditioned panel?
No, that's not an air conditioning. I don't know what they want to use now. I haven't seen the 552 panel. I mean, we have the one here on the brick, but I think that was just a test panel.
More or less a supply.
Matt,
Yes?
when these gentlemen ask a question,
Okay.
you incorporate
Oh,
that
okay, yes.
question in your answer.
It's a good point, yes. Yeah, the question was for the tool tray, is panel air conditioned? And the answer is, at least the way I know it, is no, because you guys or GSD try to get away from or having air conditioning. That was one of the big goals. So there was, you know what, let me just think about it. I think in the tool tray you guys have like a small, like a heat pump built in, but that kind of sucks out the heat from the, from the panel to the ambient. But it's not a typical air conditioning like you know. It's more something that you maybe have on your, let's say you have a normal computer and your graphic card has one of those thermal heat pipes. I think that's the right way, a heat pipe. So you have something like built into the panel. I mean, it's one unit, but the idea is to suck out some heat from the panel and transfer it to the outside. But it's kind of all passive. It's not an active air conditioning unit where you have the water, the fans, and all that stuff.
Thank you.
Yep, you're welcome.
I wanted to clarify or maybe emphasize a few things for our after-sales folks. We kind of went over it fairly quickly, but I want to make sure you understood that the VersaLift on the Siemens side for Toledo and Shaft is an in-panel version. We're talking this VFD. For Ford, on the Ethernet IP, we improved the product by having that ProTech. Okay? So we do not have a panel for the VersaLift in the Ford project. So as Matt mentioned, it's only the elevators and the tool tray that have panels now. Okay?
Yep. All right.
I got a question. Is that, not really a question, but more, safety is external to that drive where it's internal on the ProTech, correct? I mean, safety.
Yes.
operation.
Yeah, there are two different ways to do when you do an e-stop, there are two different options. With the ProTech and with Siemens, here's the ProTech, we have the option to do basically the e-stop over the Profinet. It's done through ProfiSafe. So you don't need any additional wiring. If somebody presses an e-stop, it is all in your PLC. In the safety part of the PLC, it sends a special telegram, a special bit to the drive. The drive goes into, it gets the signal safe stop emergency. That means at first it does a safe stop 1 and it stops the drive in a special amount of time. And then after that time expired, it goes into a safe talk off. That basically, it's similar than you would have a contactor in the motor cable and you would open that contactor. Safe talk off just means even if something goes wrong inside the drive, it's still possible that, something is wrong, maybe broken, and you have power to one of the motor phases, but the motor will not create additional torque. That means additional motion. So it is safe for the operator to go in and, I don't know, do something, but it's not safe to touch it. So it means it is not like a lockout, but it is just safe talk off. And to achieve that, again, there are two different ways to do it. One way is through ProfiSafe, through the Ethernet bus, okay? And the other way would be through discrete inputs. And then that is something that Rich mentioned. On this drive here, we have only the option to do it through discrete inputs. You can see here this yellow card, this one here. This indicates this drive comes with a safe talk off option. You can get the drive with or without the safe talk off option. Comau always uses this with safe talk off. And then you have here, in this case, it is already gone. Here you have an additional input. And you have two safety inputs that basically deactivate the output power to the motor. The nice thing drive-wise is that now the drive has no safety parameters, has nothing anymore. When you replace one of those drives, you just have to swap the drive, put in or swap the memory card, and then you're good to go. With the ProfiSafe variant of the ProTech, it's a little bit different because there we have also safety parameters on that small memory module. And now if you replace the drive, we will see that later on, then at the end you have to confirm that now the new drive will get the safety parameters from your old memory chip. And to confirm that, you can see here those two T1 and T2 buttons. Probably not from the video, but here is a push button, there's a push button, and you have to push them in a special sequence. We will go through that later on and basically confirm that you replace the drive and now want to take some safety parameters from your memory card and load it into the safety card. That is necessary for the ProfiSafe at Toledo and at Shep. And then the third option, what we use now in for the Ford project for 552, is kind of a mix between both. We use a ProTech, but on Allen Bradley Ethernet IP, we cannot do the safety through the bus. So therefore, we have to do it through discrete inputs, the same way as we do it here. And therefore, we will use one of those inputs on the side. We call here it the safety input X61, and that is now our safe talk off input. So maybe that's something new for you guys, for Rich, and maybe even for Everett. You guys knew from Toledo, you did all that stuff here through the Ethernet, and here you did it discrete. Now in Ford, we do it basically discrete on both drives because there is no safety over the Ethernet at Allen Bradley for us available. Right. Any more questions or? Okay, the keypad. Yep. On this drive, you can plug on a keypad. On this, that's here in this area, you can plug on a keypad like this. I think in Toledo, in Sterling Heights, every panel has at least one keypad. If you want, you can get the keypad in a handheld, and then it comes with an extension cord. And you also can plug in the same keypad with the extension cord into this interface. It looks like an Ethernet interface, but it's not. It has 10 pins instead of 8, so it's something Lenze specific. And I think one of the nice applications, for example, for 552 would be to assign the Ethernet IP address on an already pre-programmed drive through the keypad. Typically I would use a computer because I have all my stuff there. But if you don't have it, you could use the keypad with a remote terminal. You can stick it here. You can stick it in this port, and you can assign the Ethernet IP address from there. That would be one option.
Matt, question. Is Kamau providing a version number of the drive software that's loaded into there, and is that accessible through an HIM for a module?
The question was, is there like an internal or is there a version number of the loaded software version? And yes, there are two different software versions. One always gets sent through the PLC on Word 16, and right now we are there at version 1.2, and we haven't revved it up. It is normally it should be 1.2. The other thing is we have an internal software version, and I just changed it last week to version 19 with a couple of improvements we had to do for Toledo, and probably what you guys will get for 552 will be version 20, because we want to do a little bit more improvements, but we don't want to put them in Toledo. So yes, and you could also see those that revision number also through the keypad. I will show it to you later. Yep. And right now it's still, maybe later on I can explain it a little bit more. It's still, or in Toledo there was still some development necessary. Now I think that is all done, and we can finalize on a software version. On the other side, who knows? If something new comes up, then we have to implement it. The most important thing, or one important thing to know, is this stop button here on the keypad. Probably hard to see for the video. Let me take that away. All right. Here's a stop button. This one has no function anymore. There is an option in the drive. You can pre-program that stop button with a couple of functions: a quick stop, controller inhibit, or no function. And in factory default, it does a controller inhibit. That means it disables the controller. And during the tech verification in Toledo, we had just people opening the panel and just pressing the stop button and walking away. We knew that there was something wrong, but there is really no sense for us to use it because you can't really open the panel. There are 480 inside, so we decided to turn it off. If somebody asks you, no, that stop button right now, it's turned off. Then, it's even on my computer, you don't really see a lot of, you see some text. Normally you see here some text on the screen. And what's also nice to know is those left and the right button, they will change the functionality depending on which area you're in the menu. It's, for example, possible that this one does a save and this one does a return and so on. And it will display to you. Yep. Yep, I think here it's again a quick overview. We have 480 or 400 volts, 3 phases coming in. We have 24 volt DC power to keep the drive alive for communication. We have communication, Ethernet or Profinet. The Versa coder, that is an SSI interface. Oh, by the way, maybe more important for the after sales guys. I saw the CT drives a little bit, and I know they have a lot of different option cards. Here in this case, it is basically all one part. The only option is the communication part. This one here. If I have a screwdriver, I can take it out. That is pluggable. And normally, when you order the drive, you order it pre-configured. So you have one S number for the drive and a Profinet, and you have another S number for the drive and an Ethernet IP card. And then it comes like this. You don't have to order another special encoder card and so on. That is all built in here. Yep.
Okay, can you put that back, please? Can you put that back?
Sure.
While Matt is talking about part numbers, we have a specific Kamau part number for the full unit, full drive. In the field for after sales, we haven't really set up individual component part numbers because we have the whole drive with the encoder card, with the Ethernet card, all of that in the drive itself. So the only spare part number we have is for the full drive. What you need to be aware of is there is a motor and drive and resistor part number. There's one unique part number for the full package, the full onboard drive package. Okay? Then there is a specific part number for the motor, the gearbox motor, and then a part number for the drive, a part number for the brake resistor. So be careful when you say, I want this part number, in that if you tell me you want the drive package number, you will get the whole shebang.
Okay.
Okay? So, and as Matt mentioned for Triva, there is a part number for the Ethernet IP and a part number for the Profinet. If you look on the motor itself, there is a sticker on that motor that says if it's good for which part. It'll tell you it's good for the Ethernet. The motor shouldn't matter, but there is a sticker on the motor anyways that will tell you what it's compatible with. Okay?
Yeah, maybe it's also nice to know when we talk about the drive package, at least that's my understanding, that means what you see here in the picture, it is everything. It is a motor with a gearbox, with a drive mounted on it. So for you guys, the whole intention was also to make the ordering process for production streamline it. So instead of ordering a ton of different components that somebody has to put together, you just order one component, you get it like this, the guys have to just slide it on the power roll bed and they're good to go. Okay. On the other side, if you need a spare part, I mean, I would say, I don't know the numbers, but 80% probably the drive will fail. So you probably would just have the drive as a separate spare part instead of having a ton of whole drive units. Right. And I think now we have to have a small break so that our people can run out to the lunch truck.
It's 10:02. Before we leave this subject, when we come back, Matt will show you where to look for those part numbers. When you ask for that part number, there is also a Lenza serial number that you should provide as well. Okay? And that is more for diagnostic purposes. So after the break, we'll get back into that. Okay? Come back in 20 minutes.
AR-15.
Okay, let's start after our break. During the break, Daisy just mentioned again for our after service, after spare parts folks, that when you guys order a whole drive unit for Toledo and for Sterling Heights, it comes like this. That means it is a motor, gearbox, and the drive in one package, one S number. For 552, we expanded here the mounting plate, and then the brake resistor is on the mounting plate. So that means for 552, the S number contains 3 parts. It contains the motor, gearbox, the drive, and the brake resistor, all included in one S number. For Toledo and Sterling Heights, the brake resistor is separate. Okay? Then, again, the other thing maybe for spare parts again is here you can take out the Profinet card and maybe replace it with a different one. But that is the only thing that's kind of modular on the Lenser panel mounted drive. It is everything else you can't really take apart. It is not like a CT drive where you have a separate encoder card or a separate application card, or I don't know how the Allen Bradley drives are. Here, that's what you get. The encoder, both the Versa coder and the motor coder, then are built into the drive. And yep, when you order also the number, it comes with a Profinet or it comes with an Ethernet IP who basically looks exactly the same.
Question for you.
Yes.
What is the timing? Let's say if we want one, are these parts readily available in Glendale? Or?
Yes. The question was, what is the timing for parts, for spare parts? And I can forward there the question to Bill Fong. So what is the answer there?
We're talking about keypads or the whole drive itself?
Well, since it's one S number, the whole. If we determine we have a bad drive, what's the turnaround?
We keep safety stock of the drives that you guys use, or that Kamau uses in the programs. So we should have them in stock. I think the safety stock number. Why do you think
There is a Kamau inventory of components that we are still working on. For Toledo, we had that full inventory, and that inventory was supposed to be replenished via the NCR process. Unfortunately, the process fell through, and my understanding, and we're going to be discussing this while Bill is here, we have motors currently for the
drives?
well, I don't believe they have drives anymore. For Ford, we have a full list of components that will be a recommended spare parts list that the after sales folks will be looking at, and I am hoping to push them to make sure that we have it ASAP. However, as part of the Lenza Kamau agreement, if in need of a product ASAP, they are to provide us a drive within 4 weeks, I believe, and a motor within 9 weeks when cold ordering.
I think it's sooner than that, but something like that.
Worst case, 4 weeks for a drive, 9 weeks for a motor.
But we still have to order it all through one S number.
This is one S number. Well, no. If you want the whole drive package, for Ford, it is the brake resistor, the drive, and the motor. There is one Kamau number for that.
Okay.
If you only need one of those components, only a brake resistor, only a drive, only the motor, they have a unique part number for those components as well.
Okay.
So you can order the whole package or piecemeal order.
Okay.
Okay?
All right.
The motor itself, from Ethernet to Profinet, is the same number, I believe.
Yes,
Yes?
on a drive package.
I'm going to repeat that. For the motor only, I believe the motor only part number is the same part
On a drive package.
for an on-motor
Yes,
drive.
yes, correct.
The reason we say that is because of the fact that the drive, the VFD itself, obviously it's a different number because one is Profinet, one is Ethernet.
Okay.
The brake resistor, I believe, is also the same number on a piecemeal component basis.
Okay.
But the drive package as a whole is of course different because of the Ethernet Profinet drive difference.
What's going to be Kamau's recommended practice? If we find if we have a bad VFD, should we be attacking it as an individual component, or should we be attacking it as a package?
It is usually being seen as a component basis, only because of the fact that what I'm hoping the after sales folks will have is order the full package and only use what you need component wise. So if there is a problem in the field, an NCR should be written, whether it's against the project or a Lensa manufacturing defect. Either way, that NCR will then replenish that component that was taken to replace it.
Okay.
Make sense?
Yep.
Okay.
All right. Yeah, when we do diagnostic, or when we commission the drives, another really useful tool is to use the diagnostic adapter. That is here, this adapter. It comes in with 2 cables. On the one side, it's a USB cable. So you can connect it to your laptop on the USB side. And here, again, it almost looks like an Ethernet cable, but it has 2 more pins. So that is our special diagnostic interface. It goes to the same port. It clicks in here, or it would click into the Protec. If you open this cover, you have the same port and you can stick it there inside. Yes, Bill has a question.
Is there a special marking on the cable that tells someone that it's the 10 or 11 pin versus the standard, so someone knows that they're using the right cable?
I mean, it tells you here it's kind of a Lensa cable, so that's, yep, I mean.
So it stops someone from plugging in an Ethernet cable, which you physically can, and say, oh, this doesn't work.
Yes, I mean, nothing stops you from putting in an Ethernet cable, and it's also a bad idea because an Ethernet cable, if you would do that, and I left my one in Toledo, I guess. If you do that, if you take an Ethernet cable and plug it here inside, it's possible that you bend one of the internal pins. So I normally, when I see new guys working on those drives, I explain to them that that is a special cable and just handle it that way. It's, I mean, I was told when we rolled out those drives in 2008 that it's not a good idea to plug in an Ethernet cable. I've never done it by myself. I've never heard of anybody doing it, but since I heard it, since I was taught to not do it, I relay that information to you guys. It's, yes. So, but, I mean, for setting up the drive, this tool is really, it's basically necessary to set the Ethernet IP up. That's more for commissioning. Even if the drive is already pre-programmed, preloaded with the latest and greatest program, you still have to assign the communication settings. And there are differences between Ethernet IP and Profinet. On Ethernet IP, you do not have the option to do it through the Allen Bradley RX Linux system. So you have to go through Lensa Engineer. That's one option. You connect through the drive and change the Ethernet IP address. Or you would use the keypad and change the Ethernet IP address through the keypad. Personally, I think the software is a more powerful tool, so I would rather go with this interface here.
Now, are they going to be supplied to the plant with these modules?
The question was if the plant is supplied with those models. That is a good question. I don't know what the plan there is. I mean, yes, that's. I mean, what you also can do, just if you don't have, for example, for you for 552, if you get a pre-programmed drive, even if you don't have this communication cable, you still can talk to the drive because we know the pre-set Ethernet IP address. even if that's now a little bit screwed up, you know when a new drive comes in, it comes in with the Ethernet IP address, so you can talk with your laptop here right into the Ethernet IP. From there, you can change your Ethernet IP address, cycle power, and then you're kind of good to go.
So you have limited access via the Ethernet IP card, or is it?
Oh no, you have full access. You can do everything you can do here, you can do through here.
Then can I give a suggestion? My suggestion would be to put some kind of danger tape or only specialty cable use piece of tape over the front of that, since most people walk up, see an Ethernet port, notice an Ethernet device, go to plug into it. So if they have all the access to the Ethernet IP already, then I recommend, because what's going to happen is somebody's going to say, well, Matt, you're not going to be around every time I have a problem 3 years from now to tell the new guy not to plug in his cable to that. So that's just a recommendation.
Oh, you want to make it bigger? Or what you want to do?
I have a question going along with that. Are all of these, the way we're using them, going to always have the keypad on here?
Thank you. For the in-panel drives, we have standardized so that the keypad is part of the drive. So I agree with what you're saying, because I was thinking that when he mentioned some people have done that. So I believe the spare part that we have, the spare in-panel drive, also has a keypad, does it not? It doesn't.
If you guys order separately, there's a part number that you can order both the same, but for some reason you guys ended up buying them separate.
So we would have to take the keypad from the old and put it in the new.
Correct.
Our procedure does, I don't believe the procedure calls out for taking the old keypad and putting it with the new. Jonathan, we might want to take a look at that, please. Because what I was thinking is we had the keypad as part of the spare part, so we would do a full replacement and not even, our customers would not even need to see that port.
I think moving forward, you can purchase it. Chris would have to requote it with the dash X.
With a keypad?
Towards the end, there's a placeholder for a keypad.
A K. Instead of an X, it's a K then.
But there's 3 X's at the end.
Yes.
One of them is for a keypad, one of them, I forgot what the other two are for, but you can order it with a keypad.
Because what I was thinking is the fact that I should not have to remove that keypad
Yes.
in order for me to access that
Yeah,
module,
you can
right?
see it here. On the side, you still can kind of pop it here from the side.
Right.
So yes, you can leave the keypad as it is and still.
That was why I was thinking when you do the replacement, because that keypad is over that port, you wouldn't even have to worry about it.
Correct.
But if our part number does not include that, then we have a problem. Okay.
It's a question I will take up with you later.
And okay, but
I'm sorry.
yes.
Just for the group, for cost purposes, if we make that spare part with the keypad or without the keypad, what do you prefer? You guys are going to be in the field.
No one wants to buy these keypads. They're not cheap, I assume.
But it's
Yeah.
only on the elevators and on the tool tray. So I mean, it's also a limited amount.
How much are they?
I thought they're like less than $200, I think. I don't know, is that expensive in your world? I don't know.
Well,
I mean,
we're
it's
only
a
talking elevators, tool trays, so I think the 200
Yeah,
will
they're
be-
starting to really, the number of these panel mounters are really starting to drop considerably. I mean, I think there's 4 tool trays, I think, and there's talking maybe 20 eyes, I think, or something like that.
20 elevators.
I think, versus when it used to be VersaLift, there was
Yeah,
easily 80
right.
plus 20,
Is there any configuration to the module, to the,
Keypad?
yeah, I mean, no.
Plug in, plug out, right?
Yes, and you can do it live while it's running.
Basically, one keypad is for any of this style drive.
Yes. Yep.
So it's okay to not have one, right? I'm
Yeah,
thinking.
because when they take it, they get the new one.
So do
So-
I not get it in the top level number?
Just get me a number for the handheld, and you said we have a part number for the direct mount, right?
Well, the keypad, you have a part number now if you guys order them separately.
For the direct mount, but I don't have one for the handheld.
Okay, let's say you didn't want that. You do want it now?
I have no idea yet, but get us a part number. Get me a cost for both, please. From what Everett says, I think in the field, keep in mind that Everett is in a different situation because we were in development, so he was on his laptop the whole time. I think you guys will be,
That's not the handheld.
Okay.
That's a diagnostic.
We're
you
gonna,
shouldn't need it.
yeah,
That's
we're,
what I'm thinking.
that's the route we'll take.
Okay. Yes, I think one part on our agenda was to talk about the required hardware, and that's the reason why I came up with here the diagnostic interface and this cable. That's more for for guys who commission the line the first time. You get a drive. Let's say it is. The idea is also you get a pre-programmed drive in the next projects when we. I mean, as you know, it comes with a program. But when I released the program, I screwed up the IP address. Instead of 129, I did it 192. So, but it still has a good program inside you could use. For 552, once we start commissioning, we have to update it to what we have right now in Toledo and in Sterling Heights, and probably even a version better, a version 20. So. On the other side, normally I would do everything through Ethernet, through here. But for the first setup, I have to set the Ethernet IP address. And there I have several options. Since I know that the drive comes in with one Ethernet IP address, I can hook up my laptop, use the Lenses software engineer, and change the Ethernet IP address through the software, through the Ethernet. That is one option. Or what I normally do is I use a diagnostic adapter and use a point-to-point connection from my laptop to the computer, from my computer to the drive, and change the Ethernet IP there. Or I could use the keypad. I have those different options. Personally, I recommend, at least for the guys in the field like Everett and you Trevor guys, if you deal with this, one of those. Because it's always a nice tool when you, for example, you have a generic problem with Ethernet IP. There is something wrong in the line. Then you still can use that port. You can talk to the drive and set up the drive. I was last week in Toledo and I tried to communicate to one station, and for some reason I always have a hard time to communicate with my laptop to that station. So finally what I had to do is I had to grab my laptop and walk to the drive and communicate right to it. So I think this one here is it's a necessary tool. And I don't know how it works with the Comau S number. I know for Lenser, this one and this one are two different part numbers, because you can order this one as a 2.5 meter cable, you can get it as a 5 meter and a 10 meter. Normally you order it as a 2.5 meter cable, but I don't know if we bundled it, or if you order it, you have to order it also as a 2.5 meter cable and the diagnostic adapter. And yes?
Can you upgrade the firmware through the Ethernet, or do you have to go through that diagnostic port?
Yes, the question was inside the drive, the Lenser firmware, what way or how can you update the firmware? And the only way to update the firmware would be through the diagnostic adapter. In Toledo, we had to update the background for a rich question is in Toledo, we updated the firmware from the elevators from version 2. The next version that got released, believe it or not, was version 12. There's a reason for that, but I don't want to go too deep into it. But we had to do that because we got an improved oscilloscope function to do drive tuning and monitoring. For you guys, normally in the field now, I mean, knock on wood, there should be really no need to update the firmware. But if you have to do it, you can do it with this tool here, and you can do it with the software that I can provide to you guys.
That'd be only for the 1.2. We can load drive software. I guess I got clarified because I thought I asked that question. So the firmware, is there anything else that can only be specifically done through the module?
I did not understand the question.
So the firmware has to be done through the diagnostic module cable.
Yes.
Is there any other functions that are specific to the cable module?
Okay, so the question was, what can I, or when I want to do something with a drive, what limits or what can I do with this one that I can do not with other communication ways? And the answer is setting up the drive, changing parameters you can do through the keypad, through Ethernet, or through the diagnostic interface. And in addition to that, the only thing what this allows you more is also to change the firmware in the drive. Also, you have to keep in mind that normally the customer is not really, should not be in the situation to change the firmware. That's, I mean, the drives are, if we run Toledo with a version 12, and in 2 years we will ship version 14, there is no reason to downgrade the firmware before you ship it to Toledo. So version 14 will always be a good replacement for version 12. I mean, vice versa, that's maybe not the case, because maybe in version 14 we implement some new internal functionality. That's the reason why we call it version 14. So if you now put version 12 in, it doesn't offer you that. It's like when you go from Windows 7 to Windows XP, it probably won't work. But if you go with a newer drive, you should be good. On the other side, if there is a problem, then our guys in the field, that they have the diagnostic interface with an additional software tool, they can reflash the firmware. Okay, all right. Yeah, we had this, we had that. Yes. When here at the beginning of the presentation I showed that I was here the first time in, I think, October 2009. We did the proof of concept with this drive. Then I came back a little bit, maybe 6 months later, and I was using the Protect drive. And then I was gone for a while off this project, and Chris Somerek was doing some major programming together with Al Bush. And maybe then 2 years ago I came back like on a regular basis here. But in the meantime, Chris and Al, they already implemented the sync hardwired communication between the drives. We will see that later on. But also this is not used right now in KL and SHEP. We were, the safety, there are two different ways, we mentioned that, to tell the drive to go into a safe state. One way would be over the Ethernet with Profinet or with ProfiSafe, or with discrete inputs. So you have like a remote output card with safety outputs, and then the drive has dedicated safety inputs, and you put the drive into the state safe, talk off. The drives also come preloaded by us, by Lenser. When they leave Glendale Heights, at least the drive unit, if you get it as one unit because it has the the S number for a power roll bed, for a Versa roll, so we know where it ends up. Therefore, the idea is to preload it with a generic or with the latest or with a released application software. And then the idea is that in the field, the integration guy only has to change the communication settings. That is a long-term goal. And right now we are getting there. But in Toledo, we still had to do some more development that basically came up during the process. I mean, we spent quite some time here in the Blue Room to develop the power roll bed, but then a couple of things just popped up on site that we had to address. Therefore, it just took a little bit. I mean, we can maybe you guys want to know it that on the old Emerson solution, you know when you have a power roll bed and you have an alternate configuration. You know all what it means. That means normally you have the motor mounted on the same side as a Versa coder. Now it's possible that you also, for some reason, you have to mount the motor on the different side of the power roll bed. In the past, what you guys had to do with an Emerson drive or with an Allen Bradley drive, I think you had to swap like motor phases and you had to swap encoder phases and so on. And nobody was really keeping that into account. But here on this drive, I mean, you have here the drive, you have the outputs that get hardwired into the encoder and into the motor. There's really nothing to swap. So what we have to came up with a procedure or with a mechanism to change that through the PLC. Now the function block that controls that drive has a special configuration input where it tells them it is like here it is a normal configuration. You have the motor on this side and you have the encoder on the same side. If now this whole unit would mount it on the other side, in your PLC you have to reconfigure it as an alternate configuration. Then the PLC sends a special bit to the drive, and the drive internally has to invert the motor direction and also the encoder direction. In the end, it works really great, and I think it's also a huge improvement from what you guys had in the past. But that needed to kind of get straightened out on site, and also the communication between PLC and drive, and that just took some time. So
Can you go over the slip detection a little more?
yes, right now what the drive does is the drive monitors the motor increments, the distance traveled by the motor, and it monitors the distance traveled by the Versa coder strip. And then those two values, they get rescaled, and then I can compare them with each other. And the idea is, for example, if the motor travels, let's say, so many increments, then I want to see also that the Versa coder travels so many increments. If that's not the case, and if there is a discrepancy and that's out of the window, the drive creates a slip fault. Or in this case, it is the drive just creates a bit that we call slip fault. The drive really doesn't fault, it just creates a bit to the PLC, and then the PLC can react however it likes it. One of the ideas is that if you have the sync mode and you have two drives going really fast, one is chasing the other. You want to make sure that, for example, if on the first drive, if there's a problem, let's say the driven rollers, they are pretty greasy and they are spinning like crazy but not moving the pellet, you want to stop the other pellet not running into the first one, and one way to kind of detect that is with a slip fault. So when the first drive, for example, detects, hey, I'm slipping, then normally the second drive loses the run command and also stops. That's one application where we need it or where we use it. Later on, I transferred that slip fault also into the elevators. Especially, I put it into the 2-column elevators because in Toledo, we had unfortunately the 2 accidents where people in the field, while they were integrating the elevators, they were releasing all the brakes, also the pneumatic brake on the top, without having the motor shaft connected to the elevator, and that never ends up good. So therefore, in addition, I mean, that's bad. I mean, but now the idea is we also monitor on the elevators the slip. That means the traveled Versacoda distance compared with the motor increments distance. And if that's out of a window, then also the drive creates a signal to the PLC, and the PLC can react. In this case, on an elevator, it would kick in the safety brake and, yep.
So which products do you have it on?
I think right now, that's a good question. It's on the power roll bed, on a Versa roll, and it is on the 2-column and 4-column elevators. And I think it's also on a turntable. And on a turntable, the question was, good point, the question was in which standard products we have the slip fault now. It is, again, on the Versa roll, power roll, that is one program. It is in the 2-column elevator, in the 4-column elevator, and in the turntable. And for example, in Toledo, we also had a few slip faults coming up, like in segment 9, station 18. And then Kevin noticed that, for example, that one of those, I don't know how you guys call it, those scrapers, those plastic scrapers, wipers, was mounted like really close or really short. There was no gap. And when it was traveling over the metal rail, at one point the metal rail was a little bit bended up. So it kind of it lifted up the whole section where the driving wheel was. And there we got a slip fault. So that was, I mean, everybody was kind of complaining, oh, the drive got a slip fault, but guess what? There was a reason, because there was something wrong mechanically. So
The slip fault detect, I wanted to make sure we go into a lot of details, because for Ford, when we go into this, that is something that you guys are probably going to be seeing a lot of. What it is really is a mechanical issue. What it's telling us is there's some sort of a physical problem, and that will hopefully minimize your software time. Because I know when we're trying to start up and commission, we can't pinpoint whether did we build it right, did we install it right, and is it really a software. At this point, correct me if I'm wrong, Matt, at this point, we should not be dealing with any drive issues.
yeah, I agree. I mean, now I'm really confident there. I mean, in Toledo, we finished development, and in the past we had, I think, Bill DeShatter would say, what he would say, nuisance slip faults because there was something wrong in the program. But now our experience is that, I mean, if you see a slip fault, there's a mechanical problem, or there's, for example, on a power roll bed, you can get a controls problem that on the one side you still tell the drive to go, but on the other side the brake also gets controlled through the PLC. So it's possible that you tell the drive to go and the drive is spinning, but then you also for some reason engage the brake. That means the motor is kind of still turning through the brake, but it's slowing down, and the power roll bed is already standing still. Something like that will also create a slip fault.
So
Yep.
heads up when you're getting that slip fault. Keep in mind too, and the reason why I'm saying at that point, the drive program should be solid. The only thing we would need to change the drive program for is if you, in your experience, you experienced something that we didn't in Toledo and Shap. The reason I'm saying that is at Shap, they have our programs. It's a replicate of Toledo, and so far, so good. So as soon as you guys see something in Toledo, or in Ford for Novi, please let us know as soon as possible. Okay? The other thing I wanted Matt to go over is on this slide, there is chase and there is sync. Can you go over the difference in?
Yes. Think that's what we use right now in Toledo and in Sterling Heights. It means that basically each drive gets an independent go signal that is a little bit delayed from each other. So the first drive gets a go signal, and then the PLC is basically kind of detecting if there is a gap between the first and the second drive, and then it starts the second drive. It doesn't mean that the first drive has to basically go all the way and clear it until the next one goes. It looks almost like a train mode. So the first one starts, and then a little bit delayed, the next one starts, the next one, and the next one. Errol was able to dial in this delay here really small. And I mean, I think it looks pretty good. But that's what we call the chase mode. In difference to that would be the sync mode, where the drives also need an additional signal from, like a hardware signal from one drive to the next one to tell that the drive is, for example, ready to go and okay. So if you want to run the sync mode, there needs to be more hardware necessary, another drive-to-drive communication. But then the idea is PLC just gives a generic go signal to all of the drives, or normally to the first or the last, depending how you see it. And then only this drive is only looking to the next one, and if the next one is ready, then it just ships it. We tested, or Chris and Al tested that long time ago, and they came up with different scenarios how to do the sync mode, how we use the digital in and outputs from the drive to have an interlock between the following and the previous drive. And there are several ways to do it. We did it with 2 inputs and 2 outputs. And then we had to redo it because we had to use one input for the temperature contract on the brake resistor. So there is something behind this whole stuff, but yep, I mean, that's what we have right now in Toledo. Works awesome. And here you don't need an interconnection between the drives. If you want to get a little bit more cycle time out of it, then you would need, I mean, the whole idea is to not rely on the PLC cycle time anymore, and then you can, the sync mode would be an option. Okay.
With regards to
You want to probably.
With regards to chase and sync, our standard right now is the chase. So the Ford 552 and both the Chrysler TNAP and SHAP is currently in a chase mode. This is for the after sales folks. I say that because of the fact that we have yet to have a customer that wants the full synchronous mode. And as Matt mentioned, for a full synchronous mode, we need a direct VFD to VFD communication. Okay? So for the after sales folks, right now, we do not have a synchronous application in the field. With regards to synchronous, what Matt alluded to in the blue room, we did test it, but we didn't test it to the point that we wanted to with the fastest speed that we wanted to. And this is for everybody. Because of the fact that that power roll bed, the frame, the mechanical makeup, the speed that we want to go to, that power roll bed needs to be updated. So if anybody talks to you in the field with regards to synchronous, right now the answer is we've tested it, but we haven't fully tested due to the mechanical restrictions and limitations. Okay? If anybody talks to you about speed and the fastest transfer capability, what we're talking to everybody about is 5-second transfer. And this is very, very important. Okay? Our transfer right now
22-foot pitch.
for a 22-foot
Yes,
pitch.
you want to,
thank
yeah.
For a 22-foot pitch, we are at a 5-second transfer. Now, internal communication, we are doing faster than 5 seconds in the field. We can do a lot faster than 5 seconds, especially on a synchronous mode. But that synchronous, I'm going to repeat one more time, we have not fully tested due to mechanical limitations. Okay?
One question, that 5-second transfer, is that in chase? Or is that
Yes.
open space, just one
No,
ballot?
no. The question was a 5-second transfer. When we checked it in Toledo, we did it like in a chase mode where you have like in normal production, you have to wait that's the first roll bed. You want to see some motion. It really doesn't matter if there's a pellet or not. The receiving power roll bed has to have like 50 RPM, and then you have a PLC to PLC communication lag, and then the sending roll bed starts it, and we monitored the time from the receiving bed basically starting to run to the in position signal. When the receiving bed was starting to move, because it was told so from the other bed, until the pellet was in position, and on a 22-foot pitch with 1600 RPM settings, then we are below 5 seconds. Sometimes we are 5 seconds or even less. And one of the, for example, the limitations, or Daisy mentioned, we also designed our e-stop ramp. When you do an e-stop and you stop in less than so many inches, sure, one of the impacts there is also your traveling speed. Physically you can bump up the speed kind of more and more and more, but then you have to keep in mind when you press an e-stop, it just travels longer. On the other side, you can't really make it more aggressive because then you maybe would pop the belts. But yep, right now we are at 5 seconds or less at 1600 RPM at a 22-foot pitch. And if you have an aisle, like a 26, 27 foot pitch in a walkway, you should be at 5.8 or less than 6 seconds or something like that.
Thank you.
Yep. Any more questions or? Yep. When we see the drive program, basically the drive gets, or the application gets written with a function block editor, and one way to make the navigation a little bit easier was to color code the areas of the in the function block editor depending on the different tasks, what that part of the application is doing. The function block editor kind of has some advantages. On the other side, for example, if you have a structured text program where you have subroutines, that's maybe easier to structure. So here we came up with color coding and make it easier to navigate. We did that like a year ago. There probably could be some touch up, but it's still, at least for me, a pretty nice tool to navigate through it.
Before we get to the software, are there any questions on the hardware?
sure we will have some questions, but basically, when this drive comes from the factory, you're telling me it's gonna come preloaded, has the wrong IP address, but it will come with 1.2 firmware, already loaded on it.
Hold on. Firmware?
Yeah.
1.2?
You kept saying 1.2.12, I've heard 14.
That's where I wanted to go to. This is why I wanted to go.
Okay.
Hold that question.
Hmm?
With regards to firmware versus program software, I would like him to go into that before we get to this.
Okay.
Hardware-wise, what I wanted you guys to be aware of is the difference between the Siemens Toledo shop and the Ford.
Okay.
Okay? One of the things that we experienced in the field is the Ethernet connection. We were having some, and still are having some Ethernet, Profinet network specifically, issues
Okay.
because of the connector. Heads up on that, okay? The other thing is the fact that for Siemens versus Ethernet IP, for Toledo, we have the Harding connectors, whereas for Ford, it's all Molex,
Okay.
okay? The big issue there, and I say that because of the fact that for easy taking a look at, and again, this is for spares, in case you come across with a drive not on the motor, it's very easy to tell which drive you have is for that purpose alone. Keep in mind and this is for the after sales guys, for the Siemens, we are not using the side Ethernet, we're using this for safety. We're not using it in Toledo and Shap.
Okay.
Okay? We're having a direct safety connection for Ethernet, and we're not with Siemens because we're using the ProfiSafe network.
Is there a timing for when they're going to have compliance with Ethernet IP safe?
That is an ODVA issue, and I don't have an answer for that. The question was, when will there be Ethernet IP safety? And I couldn't tell you on that. Okay. Hardware-wise, as far as the motor, heads up on the gearbox ratio, the frequency, and the connection. I'm talking about in-panel VFDs. Matt mentioned on the elevator, correct me if I'm wrong, on the elevator for Toledo, we standardized on 11 horsepower 11 kilowatt VFD for both the 2-column and the 4-column. The panel is on the mezzanine, whereas for Ford, we took that panel and we located it in between the motors.
Yeah.
Okay? We used to have a junction box and a VFD box. For Toledo, you have 2 boxes. For Ford, you have 1. Okay? The motor size and the VFD size changed on the Ford side. You're aware of that, right?
VFD motor.
The VFD and motor, because for the 4 kilowatt, we use a 120 hertz
Okay.
and a 15 kilowatt drive.
Yes. Mm-hmm.
Yes? And that is a global issue,
Okay.
not necessarily a US thing. Okay? The development of the product, this is for after sales, is a global capable product regardless of the regional voltage and frequency.
Now, does any of that affect the parameters coming from the drive to the software?
No, the idea was to have no effect. I think when they did the power rollback, they even put in a transformer to step it down to 380 and run the power rollback with 380. That was before my time. That was when Chris and Al was working on it. But yeah, they tested it.
Okay. So from the software is transferred.
I mean, for you guys also the new 4-column elevator design, at least the, I mean the motor and gearbox, that is all drive related. That doesn't do anything on the control side. It is more what Daisy mentioned, maybe, I don't know, maybe there are more or less hardware limit switches or so. But regarding the new motor and the new drive, that is all driver related stuff. And I modified the program, I changed the motor parameters, I changed the gearing ratio and some other stuff I had to change, for example, the slip fault detection. And now the next thing is I have to get a real 4-column elevator and test it.
Okay, so there might be some adjustments.
Yes, I mean, yes, I mean.
We just need to be in better communication. We need to understand when you say, okay, I did updates for version 19, I need to get updates to know what.
Yes, yeah, I mean, normally the way.
What you're looking at for version 20, just so we stay in contact, and then a copy of these procedures that Jonathan and you are working on. So I asked Jonathan, he said to get it from you, but it seems like the right point in the
Do
conversation.
you guys have release notes for the version changes?
I mean, normally when I send something to L and he puts it in onto the Siemens side, if we want, I mean, I don't know if L sends it to you or we just copy. When I send something to L, we send it to you too. The good thing is now, since Toledo is really running for quite a while, there are only minor changes. In the beginning with this configuration init signal and the alternate configuration, we had to do a lot of stuff like on the fly. Now there is what?
The dust is settled.
Yep. Yes, but you're right. If there is something changing, and I would like to implement or move one functionality from the drive into the config init signal, I will let you guys know.
Bitmap changes and things like that, or bitmap changes?
No, not really bitmap. The question was, we have a bitmap, an Excel table that basically maps out the communication from PLC to the drive. And the question was, I can show it here.
Before, we're going to hold that question because Matt will be going over that in detail.
Okay.
Okay? What I wanted Matt to do is that specific bitmap and inside the drive itself. This is the whole point of this training. So if we can hold off on that. Hardware-wise, if you guys have any questions with regards to what's going on, I also have Tom Reed trying to look at the differences on the hardware side between TNAP and SHAP, and also for Ford that may affect software. Okay, so I believe he started today. You should have gotten some emails that says, here's some possible modifications or updates. You are on that list, Sean. So hopefully you got it.
Okay.
I believe he's still looking at the Toledo to SHAP hardware. But at this point, and there's some other things that are in Ford that we didn't do in Toledo SHAP. So you guys should be getting, and you're included on that as well.
Okay.
Okay. So before we get into the specific hardware, if anybody has a question or want a copy of the drawing package or bill of materials, send me an email. Okay? Better yet, send Tom Reed an email and copy me in. Before we get into the software specifics, I would like Matt to talk about the firmware revision and the software and parameter versions. Can we do that?
Yes. Yep, we can do that. Yeah, maybe to get an understanding when we talk about programming, firmware, parameters, and so on, I always try to come up with a picture like this to get an idea. Unfortunately, maybe you saw me just modifying an old one. It is not perfect, but inside the drive, you maybe can picture it. You have two different levels of software One is the firmware that the drive comes with, that offers you like the different functionality for positioning, for logic, and so on and so on and so on. This is all built into or programmed into the drive. It comes in here on this. I think we don't even show it on the, when we go online, there's a code, I think code 207 in this ballpark. It shows you the actual firmware revision number. Now we should be here at version 12, or we already shipped version 13. Normally when we go from one version, from 12 to 13, or maybe then to 14, a bigger step means on the one side like improvements, new functionality, and it also means like bug fixes. If we detect something in version 12 that is not the way it's supposed to working, then we maybe come out with a version 12.1. But if we also add new functionality, then we normally go from 12 to 13.
Usually on Ford programs and even Chrysler and that, there's a block point release of all the firmware revisions for the particular program.
Yeah.
So say for like 552, you would have each individual drive type and tell us what version of firmware it's supposed to be at.
Okay.
A list like that might be handy, so that way when we actually start installing, we can verify everything's at that current revision.
Okay.
Rather
Yes.
than trying to just remember all these numbers.
Yes.
We'll have a document for what each drive should be at.
Yep.
Firmware specific or both firmware and
Probably both if they're going to be different.
So then in addition.
Block point release is given on every job, customer what they expect us to do. But I guess now we tell them if it's correct. Or just have to get the latest version. Gives them back with the version we expect.
If we're going to install for
I don't know, is it something you want to address in the whole group or just later on, or because he is probably not going to tape it.
The question is the communication for the firmware revision and the software and parameter revision. And if I understand correctly, we as Kamau provide the end customer a block point release.
Generally, the controls follow up for the customer requests from all the vendors what the firmwares are. They review what the firmware options are, and they basically agree to those firmwares.
Okay.
So then they usually submit it out to all the project people and all the different vendors. It's called a block point release. They release it out and say, this module will be using this firmware with this software. So like, for example, an Allen Bradley Ethernet card, we'll say it's using 1.9 firmware, but using Networks 20.1 as the programming. That type of thing, and they put it out to everyone. And basically, it's an agreed upon set. So if there's any changes, it has to go back to the customer. Customer knows that they're getting an upgrade to the firmware, and they release it out to everyone. Generally, we see it for purchase components, but we haven't seen it in the past for drives. But I think it's because they control it. In the past, Ford was the one doing the drives. So
Okay.
it was part of their package.
We're talking 3 different drives now. One is the Rockwell drive, which GM and Ford control.
Yep, so you wouldn't be,
Correct. The other one is our old Versa drive by Emerson,
okay.
and I'm not sure what Kamau has communicated as far as the firmware and software
Okay.
on the Emerson side. So I will have to follow up with our engineering team to figure out what format to use. But we do have a Excel sheet that shows what revisions we have
Okay.
for the software. We just haven't updated it to the final in Toledo.
These sheets are always particular to whatever project you're on. So there'd be one for a 363, and there'd be one for 552. So it wouldn't be like you have to try to manage all your 3 drive types per one block point release. It's always per project. So you would only expect to see the lens of ones that we're using on this program on this block point.
Yeah. I would have to see how we did it for the Emerson side and follow suit.
I could show you a reference from the Ford one that's current for 552.
Have we done one for Chrysler where we used Emerson?
No.
That's the reason I'm asking.
No, I can just show you what a generic Ford one looks like that
Yeah.
they send back out.
Because the reason we're also speaking of this is earlier on, I took note of that too, that I wanted to include that in our testing tracking matrix. So because we have version control now on our block that we use for drive controlling it. So when we go through testing, we're going to say we tested it with our block 1.8, 1.7, with your firmware 1.2, with your drive load of whatever 19 that you're saying, and this date. So that way later on, if there's a problem in the field and we go, well, wait a minute, we should have caught that in testing, and we see that it's a version 20. We go, whoa, you know, it's an accountability matrix, just so that we know what we tested when, so that way as things evolve, we're not going back saying, well, we should have caught that. Well,
Agreed.
we
And that is something our after-sales folks should have as well.
Yeah, I mean, I agreed to that too. And I mean, long time ago, I asked you guys, Bill, Chris, how we want to handle it. The only problem is that, I mean, internally we maybe can freeze the software, but you also have to keep in mind right now the idea is to have one S number for this drive, and we want to use that for the next 5 years. That means now if I run into a problem in that drive and there is something not working, and we get a new firmware release that fixes that problem, or even if it's not a problem, that gives me some new functionality that I can do the slip fault detection better, that means when we freeze the software, I can't really, I can't take advantage of the new, like when we did it in Toledo.
We have to release a bulletin to Ford, Ford Vehicle Controls. Let them know that you did an upgrade and what it is. They would send it. They would tell you to bring it into their bench. They would bench test it with you, make sure that they agree with it. This is all after it's already in a production facility.
Yep.
They would agree to it, then they release it as a task for their field engineers and for the vendors to update to.
Yes.
So that's the protocol right now for something like that. Once we get to where this stuff is installed on their floor, that will have to be followed. Otherwise, they'll
We're
eat you
talking 2 different things, if I understand correctly. One is documenting what we're installing, and the other is a software firmware management tool.
Well, that's what I thought was answering Matt, because Matt was saying if he has an updated firmware that does something better, he wants to load it in.
Correct.
And I'm informing you, Matt, that Ford is just a little bit, it's a different beast than Chrysler. They're much more controlling. They're much more conservative in their changes. So you would have to come up with a pretty damn good argument for an upgrade. So that's why they have this big procedure.
The software management that we're talking about is our agreement with our partner as to what is preloaded into the Kamau components.
Correct, and that's what
So,
I was asking earlier about when it comes in.
Yeah, but that would be the what we talk with preloaded firmware. I mean, with preloaded, we talk about the parameters.
No.
We never talked about the firmware.
With Chris.
Oh, okay,
With
all right.
Chris,
Then
with Chris, we talked about firmware revisions and what each plant should have along with the software. So while you're here, Bill, we will have to revisit that because I specifically said to Chris that firmware cannot be whatever Lenza says, it's whatever Kamau says it needs to be. So for both the firmware and the software, the revision that is preloaded into the Kamau labeled components must be per what Kamau has agreed to, specifically for that reason. And this is why I'm saying the software management is what we're talking about. The other thing that Mike brought out, I was not aware of, was the block release point. And that is something that I will need to look at ASAP. Okay?
Yep. All right. All right. Any more questions to the hardware, or? Yes, I guess then the next thing would be the software we use to program the drives, to do diagnostic, to do troubleshooting, to commission it. That is a Lancer L-Force Engineer program that works with, I think it works now from Windows to Windows XP to Windows 7. If you want, you can go to the Lancer webpage, to lancer.com.
Did everybody get that email I sent with regards to the software, what you need, that should be preloaded? You didn't? There were two things I sent out. One was an email that had all the specific details on the training. In that email, I had an attachment of what software you need.
I think that was in there.
Okay. And the other one was just an invite that didn't really have anything in it. So make sure you have that letter, because that's where I have the details of the training along with the software. Okay?
Yep. Yes, if you want to get the software, you can go to lancer.com. If it comes up in German, I mean, it should come up in English because your IP is from the United States. Here you can switch the language. Then you go to the download section, to software downloads. And here you want to go with the second one, the engineer software. Then it opens another window, and it gives you here, in this case, the Service Pack 2 version 2.18, Service Pack 2, the download link, and it should give you also a link for the full version somewhere. If you want, I can put it also on a memory stick and give it to you. Yep, normally what you need to do, you need to install at first the full version of L-Force Engineer. That would be right now the version 2.18. When you install it, it pops up with a window, and you have several choices there. You have several options. You can enter a PIN number and run with the full version, the high-level version. You can run the high-level version for a 30-day trial period, or you just go with a state level that is kind of a dumbed down version, and yep, go from there. Then you also want to install the Service Pack 2 that normally fixes, like, I don't know, communication issues or stuff like that. And here it also tells you for what software it is good. Yeah, it goes Windows XP, there it is, XP and Windows 7. I think that's what normally the people have in the field. With Windows 8, you can see here there is a note that the safety model SM301 is not supported. I think the context here is a little bit wrong. They refer to the 9400 series, but I am pretty sure we have the same memory or the same safety model in the same safety model in the ProTech, so we probably have the same restrictions here on Windows 8. So to make the long story short, if you have Windows XP or Windows 7, the 32 or the 64-bit version, you're good. All right. Yep, then you download it. Since we're already here, you can get also in the download section technical documents. For example, if you want to read some manual or if you want to get some technical drawings, you can get it right from here. Another window opens, and here probably want to go to A1 frequency inverter. I hope it's here. And then no, it's not here. Decentralized motor controls. No, it's not here too. Somebody sees it, let me know.
What are you trying to find now?
ProTech.
Decentral.
That's where I am right now.
Should be there.
Oh, Bob.
Oh, here. There it is. Okay.
Oh.
ProTech. Okay. Yeah, so it's frequency drive, 88,400. Yes, then you get different sections. GHB, that's like German meets Gerätehandbuch. Sorry, it's like the device handbook. Okay, and here's the mounting instruction. This one is more for setting up the software manual. I mean, maybe nice to know is a ProTech. You can get also like this drive. You can get it in different flavors. You can get like a state line and a highline version. We always use the highline version. On the ProTech, we use the highline version, and on the 8400 drive, we use the topline version. So when you order, let's say an 8400 drive, one of those, then somebody asks you, do you need a baseline, a state line, a highline, or a top line? In this case, it's a top line. And here on a ProTech, we have 3 different versions. Yep, and Comau uses the highline. On the other side, you guys have a specific S number for it, so there should be no question what to order. But if one of your customers is asking you, hey, I went online, I want to read the manual for this drive, what I'm looking for, he is looking for the ProTech highline. Same here for the normal decentralized drives, parameter setting. Again, we have here baseline. That is with a display, that's with a CAN bus. That is the state line, the high line, and here's a top line. That is what, what this drive is. That is a top line drive. Again, you find that at lense.com and go through the lense.com, go to downloads, and then from there navigate where you need to be. Also for the guys, if you set up PLC communication and you need EDS files or stuff like that, you will find it here. Yes.
Man, I can't see it because of the drive.
Because of the drive. Oh, okay. Okay. Yep, sorry. So then, yes, you download the software. I already installed it on my computer. So unfortunately, I can't really show you how to install it again. What I can show you is that I can have several installations of different versions of my software parallel on the computer. What it means, I have here version 2.16, I have version 2.17, and I have version 2.18. One of the reasons why I do this is Toledo, like a year ago when we started, 2.17 was the latest and greatest, and that's what we're using for Toledo. in the meantime, Lensa released new software that sure has some updates, some bug fixes and so on. And right now we are at 2.18, and also for the Ford project we need 2.18 as the software to program those drives. So that would be basically what you want to install. Later on, when there is a 2.19 out, you can install 2.19, and then in the process of installing, it asks you, do you want to update your existing program, or do you want to have a parallel installation? Personally, I would like to do a parallel installation for one reason. Then I still have my older version, my 2.18 version. I also get the 2.19 version. The nice thing is also, if in 2.19 there are new communication drivers that, for example, improve the communication from my laptop to the drive, they also get updated in the older versions, in 2.18 or in 2.17 and so on. So I get the benefit of those updates also in older versions. On the other side, it means when I have a program that is, for example, in Toledo, that got saved in 2.16. Maybe it sounds a little bit complicated, but in the end it's pretty straightforward. When I have a program that got saved in 2.16, I always can open it with a greater version, with 2.17 or 2.18. But if I save it now with 2.18, I will never be able to open it again with 2.16. So that's the reason why I have different versions. Maybe in 2 years ago, or 2 years down the road, if somebody calls me from Toledo and he has a question, I still can take my old file, open it in 2.16, maybe have a look, and if I need to save it, I can save it, send it back to that guy, and he can work with it, even with without updating his computer.
I want to clarify something, and Matt will go over in more detail. The beauty of our product right now is what is stored in the module, the firmware in the drive, and then the program itself, and what you can do based on what you have on your laptop. So with regards to the software you need and what you have in your laptop, I want Matt to explain the difference between what you can load that is at no cost to the customers, what you can do read or write, versus what you need in order to modify the program itself. Notice I said VFD program, not necessarily the parameter. So what I would like Matt to go over, first of all, is the software you need on your laptop, the revisions, and what that means if you have a new one versus what's in the drive for Toledo or Ford, let's say. Okay? What's in the module, and then what you can do with what when. Is that clear?
Because from a standpoint of commissioning, from my standpoint, I guess I'm going to go to only what I care about. We can use the free software available for saving a program, copying, or parameters, I should say. Copying them, saving them, but commissioning is going to be done by Lens anyways, correct?
Both. The question was, we have the free software, the state level, and we have the high-level software where you need a PIN number to install it, or you can use a 30-day trial license. What does the guy in the field needs to commission the program? That was a question. And the other question was, who is going to commission the first go-around or in 552? For the first one, yes, I think that you can use the free software, but the problem is that guess what? I am a Lenser. I always have the full version. So when they introduced Lenser Engineer 8 years ago, they mentioned all the differentiations between the free version and the full version, but I really never use the free version. So what I think we should do is, we should get one of your computers who is like a virgin, then install the free version, and just see where we go from there. If you can do what you need to do for commissioning, then we're good. If not, okay, we have to come up with something else. I mean, you should be good, but since I never was in the situation to use the free version, I really can't tell you for sure. That's one thing. The other thing, yes, with Ford 552, I don't know what the plan is. I mean, I can see me there for a while and updating the drive programs, or I mean, there needs to be some work on the 4-column elevators, on the new stuff anyway. So, I mean,
there will be full support on the 552. Matt will be there because of development items. I haven't gotten a name from Jim Reinwald at Lenza as to who the application engineer will be. My understanding is that it may be Elmar, but because of the fact that Shap and Ford are at the same time, I wasn't quite willing to accept that.
Okay.
So what I would like to do, my intent and the reason for this training, is to start building up our capability to be application support.
Okay.
Bill DeShutter, and I was looking at Dale Larson, depending on when he can come back, would be starting to get into that mode.
Okay.
Because the development is almost done, or to the point of being almost done.
Yeah.
Matt will be there for the development issues, and he will be dedicated to that.
So all the first time throughs will be with Matt.
Correct.
And then after that, I'm just trying to get a sense of what products or software or cables. I guess I still don't have a clear understanding. I don't want to beat that to death.
And that's why, well, I want to beat it to death. This is where we want to beat it to death.
Okay.
Today's agenda is very light for that reason. And what I would like to do, because most of the items on the agenda we've flown through today, what I would like to is, if somebody has already loaded the software on their laptop, I wanted to go over that and make sure you understand what you can do, the capability of that software, before we get into the program tomorrow. Okay? The biggest thing that I wanted to communicate to you is what exactly is in your laptop, what is in the drive itself, and what is saved in that module. I need that to be very clear to everybody.
I'll be honest with you, I don't know if I order the S number right now when I'm getting what I need to do to it.
Mm-hmm.
That's why I wanted a clarification.
Okay, what you mean with S number? When you
I
order?
go and I order the S number and I say, or individual part number.
Oh, okay.
And I say I'm ordering a drive with this number on it, which is specific, I assume, to Ford for this project. Is it coming in with the firmware loaded in the drive? Is it coming in with the parameter set? What I understand the memory module.
Yes. Mm-hmm.
So I assumed before that the parameters were on the memory module, and the firmware came in preloaded on the drive.
Yes.
And all I did was swap the memory module, and it came in with the IP address and the individual parameters. So communication settings and drive parameters would be loaded into the memory module, and I'd be able to go. So we keep talking about the cable, the diagnostics, the software. When does that come into play, and is that something that we need for general, or is this something we need for service? You know what I'm saying? Normal commissioning, do you see us utilizing those tools? Or is that when once you've loaded in the memory module, you did everything and it still doesn't come up, is that when you pull out?
I mean, I think that's...
That was a lot.
Yeah.
Okay. The first thing I want to go over is the software version and what you can and cannot do with that version.
Okay.
This afternoon I want to go over that, because my understanding is that the intent of this, the drive program itself, no one will be changing other than us.
Well, that's what
Us being GSD controls. Okay? So the program, the software that you will be able to download at no cost is more of a read-only capability, correct?
For troubleshooting, right?
for troubleshooting.
Yep.
Okay.
The other thing I wanted to mention, and this is internal to Kamau, as part of the Lenza Kamau partnership, Kamau will be having a Kamau-wide license with a PIN to be able to modify that program. Okay? Configuration-wise, what is preloaded into the component itself, whether you order the drive as a piecemeal or the package as a whole, what is preloaded is the firmware, the program, and the parameters, with the intent that what you do in the field is configuration requirements at first install, commissioning.
Okay.
At service, that should not be required, and that is covered in our drive replacement procedure.
Okay.
So what we want to cover today is the software, the module, the difference between what you can load at no cost,
Okay.
and then drive replacement itself.
Okay.
Good? That was a lot.
Yes.
Okay.
And
Hopefully we answer all of that.
so, okay. Things then we are ready. I want to show you how to install the Lenza software, L-Force Engineer. I uploaded the latest version 2.18 from the internet that you can find at lenza.com. And so the first step would be, normally you get a zip file from the internet, you have to unzip it, then you go to 2.18 and run here the setup. And as I mentioned before, there's overall one package that you can download. And if you go through this process here of installing it, you will see you have different options. There is the free version, the state level. I have to click through it, yes, yes, yes. And now we are here. You have those different options. The Engineer High Level, that would be a trial version. And to run the full version, you need a license number. For example, for the Comau guys who got a license key from Lenza, they can enter it. If you don't have a license key, you want to go with the state level version. If there's already a high level installed, you can do an update. Since this is a brand new laptop, one idea was I would like to install the state level. Since I've never done it on one of my machines, I always got with a high level. And now the idea is to install the state level, that is a free version, and then see what option that program offers us if this program is capable to do the commissioning. All right, so I selected here the state level, click on next. I can type in some stuff. Okay, I hope, is that the right? Okay, just install it here. All right, and here we go. I hope it's probably takes a while. It's copying data back and forth. And again, the idea is I normally use the full version, the high level version, and I would like to know if the state level version, what is that capable of. I remember when I got trained on that, like in 2008 or so, they mentioned some differences, but that's so long ago, who knows what got changed. And one of the things I recall was in the past that there was a limit of drives in a project that you can handle or you can monitor. For example, now on an underbody framing line where you have, let's say, 14 or 15 stations, and each station has up to 5 drives. You have 2 Versa lifts, you have 2 Versa rolls, upper and down, and then you have a tool tray. So you have like 4 times 10, 40, 50, 60 drives in one project. I don't know if the state level is capable of handling that. Also, they are limited between the function block editor. I would like to know what this program offers me. So, fortunately, we probably have to wait a little bit.
While this is loading, I have a quick question.
Sorry?
You're doing the state level right now.
Yes.
I saw at the beginning, one of the options said high level upgrade, so if this doesn't give them what they want, that's what they would then do?
No, if you already, for example, on my computer, when I have, yes, when I have 217 already installed, then I can do a 217, or then I can do a 218 upgrade, or I can do a 218 parallel installation. Yep. I prefer, in the past I just did an update because I rather wanted to have one program that I go to, but then it was always a pain when, for example, I got something new from Germany, I updated it, let's say, to 219, and all the rest in the room is working with 218. That means if I save now my file with 219 and I give it to you, you can't open it anymore. Vice versa, it works. If you give me something with 218, I can open it with 219.
If the state level doesn't work, it still allows you to go back and load the high level? Or do we know?
Yes, I mean that program that
You
install.
can't go backward, because you said you can't go back to state level if you have high level.
No, that was just version number related. That was just version number related.
Right.
But if
I'm just saying, if we load the state level
Yes,
and find out it doesn't do what we need,
I know what
can
you-
we upgrade to high level?
I think you can do that. Again, I never loaded the state level in the beginning, so it's kind of a new experience for me. I think I did it once to find out, but it's so long ago.
You probably just have to, if it wouldn't let you install it, you probably just have to uninstall it.
Uninstall the state level and start over. Okay.
Hey Bill, can you confirm what we're talking about, that if you install the state line software and in the future you want to change it to a high line, what would be the upgrade requirement, or does it just simply ask for a license and code?
I think you just rerun the program. You rerun the install and then you select a Highline update. Oh, sorry. Any other questions in the meantime? No. Yes.
Has anyone else loaded software into their laptops? Yeah. Did you have any problems when you loaded yours in? You installed state line?
Highline.
Highline.
2.15, 2.16, 2.17, 2.18.
Who gave you the key?
Don't point at me. Ah!
I don't know.
It's on the camera. Yes. Nice.
Everett.
I don't know where I got the key.
No, that's okay, because Kamau is supposed to get a
I know.
So it was okay for that to be done. Cause I think my understanding right now, what I forwarded to everybody was supposed to be for the state line install. Which one did you install on yours?
I had a problem installing, I can't remember which one was it, 216.
16, yeah.
Yeah, 216 installed, the 215 and 217 were no problem. We never figured out why 216.
Did you have a key to install? I'm trying to determine if you installed state line or high line.
Oh, I installed home.
I don't think the light guesses are, the lights will make it better. But about the best you can get is if you turn off the lights, about the best you can get.
Aren't you gonna ask me where I got my key?
No.
Yeah, put the window,
It's in the
yeah.
alley anyway. So I was gonna say, was it 8 mile?
Some guy hands some manual.
Outside that strip club. Yeah, in an alley. $10 you couldn't be. Got a German accent. It was in the shadows, but he did have.
So you will be permanently
in trouble, yeah.
This does pick up everybody's voice.
Videotape it. Look at more reality.
Yeah, one nice thing with that software is when you connect it through the Profinet or through the Ethernet IP, you can sit. For example, now one big difference is that the Protec is mounted behind the fence. It's not in a panel anymore, so it's behind the fence. It's not really accessible. But if the network is running, you can go to wherever there is an Ethernet outlet, hook up your computer, and then talk to the drives through the Profinet, through the Ethernet IP. You also can have one project, for example, for a whole line. A Versa row line with 14, 15 stations has 4 drives or 5 drives a station. So you can have up to 60 drives together and be online with several or all of them at the same time and monitor some stuff. So that's... So the whole communication over Profinet and Ethernet is still a little bit slower than, for example, a point-to-point communication than when you would use the diagnostic adapter. That is just because when we piggyback on the Profinet or on the Ethernet, we just have to basically use the lowest priority of communication channel that Profinet and Ethernet is offering us. And there is also, like, when the computer sends a request to the drive, like a read or a write request, that takes a couple of milliseconds to get executed. So this whole communication just takes longer than, again, the diagnostic interface. So. Yes.
With that too, though, won't that just recognize any drive out there, and you could go out there as opposed to with Ethernet? You have to send out a specific address.
Yes.
So with that, you can see any drive. Well, you're plugging directly into the drive anyway, so
yeah.
It doesn't matter.
I mean, with Ethernet or with Profinet, you normally would like to know the IP address up front to configure it correctly. If you have this one here, it really doesn't matter. You can just a point-to-point connection and go from there. Yes. See? Oh. Oh, when I look here through the agenda, when we talked about the ProTech, about this drive here, all the time we mentioned it is the drive package that comes right on the motor, what we call, the drive package, the onboard solution. It's probably also nice to know in some applications where there is not enough room for the drive on the motor, we have that you can mount the motor, how do we call it? Remote. Oh, sorry, you can mount the drive, the ProTech remote. So instead of having the mounting backplane and then, what is it, that it sits right on the motor, you can maybe move it a couple of feet. Normally where we use it is on the framer for the power roll bed, because there it's so crowded. There is not enough room, so they moved it a little bit to the side, and then they need like an extension cord to go from the... Yeah, we're almost done.
Okay, when this is done, later today,
yes,
can we take it off his computer and then redo it?
Probably, yes.
Then I could just put my camera, lock it on here.
I think it's even not really so. I mean, in the end, really the result counts. If when I installed it, what the software can do and cannot do. I don't know if we even have to. What is it for people who want to watch a video? If it's really necessary to see the installation, or just at the end we say it's good or bad. You know, that's the result is.
Okay.
And one of the reasons why we do this is I always install the full version on my machines. I never installed the smaller version. And we want to find out what the functionality is we get from this one.
Okay.
So.
Then I can just let you talk about it.
Yes.
Matt has a good point with regards to the ProTechs being directly mounted and remote mounted. We have standardized the sizes of the VFDs so that we have a 1.5 kilowatt, a 4 kilowatt, 7.5 kilowatt, 11, and now 15, and that's it. Those are the sizes that we have in our standard menu. When we are talking about the remote mounted VFDs, there is the pop-up, the 90 mil, and the 300 mil, because we couldn't directly mount the VFD on the motor. The motor is inside the power roll bed, and so the VFD is remotely mounted on the side of the power roll bed. On the geoframer station itself, the VFD for the transfer, it's normally mounted directly on board the motor, but because of the structural interferences inside the geo bed for the geoframer, the transfer is also remotely mounted. That is the only location where the transfer VFD is remotely mounted. Okay? So when we're talking about remote mounted VFDs, we're talking about the 90 and the 300, and the 7.5 kilowatt ProTech for the VersaLift application is also located remotely, and it's on the structure itself, the mega leg. Okay? Otherwise, everything is on board the motor.
Yeah, Daisy mentioned we have also the 1.5 kW version. The drive looks pretty much like this, just a little bit smaller. Instead of the heatsink goes like this, it maybe goes up like that. And then also when you look from this side, the heatsink is not as deep. It is only like an inch deep. So it's from like this to here. The right side, here or this side looks totally the same. And the 7.5 kW drive looks exactly like this one here. It just has a fan. It has a fan here sitting on top of the heatsink. And I think it still takes a little bit, or not usual. Okay, so I don't know. Do I have to go somewhere, or? Enough.
Looks like the lens package is still doing something.
Oh, okay.
It's not my fault.
Right.
Matt, can you take that chair, slide it to the left?
Okay. Okay. So now I installed the L-Force Engineer 218, and what I got here on my laptop, I just got an icon to the Easy Navigator. I think when I open this one, I will get another screen or like a menu to open the Engineer. Let's see. Engineer, yep. So one way would be to start it from here, but I think there should be also a way to get that's weird. Normal, all programs. Lens, engineering, L-Force, and that's another way. Then you can put a shortcut on your desktop and start it from there. And now what I wanted to do is I have a program from Toledo on the memory stick, and I want to see if I can open it and what options I have there. I don't want to get maybe too deep into the program, at least for now. No, I haven't copied it. Do I have to copy it from? How do I from here? Or
You're gonna have to go to the main machine.
okay, that's what I. Do I do this from here?
Yeah, just minimize that at the top.
This?
No, minimize left.
The slash.
Just the slash.
Just the minus sign.
Two more over.
Right there. Got it. So now I go to here, and I go to here, and here, and copy it on this desktop
Did copy that?
to here.
No, just copy it. Control C.
Ah, okay.
Then go back to the VM.
Here?
Yep, click on the one on the right.
This one. Cancel.
Just paste on the desktop there.
Got it. Paste. Up. Browse desktop. You can see I used the last time Engineer 216 Service Pack 1. Okay, that's okay because it's I'm using now 218. It really doesn't matter if you go with the new or the old versions. That's also okay. Yes, and here we have a problem. The problem wasn't you cannot add any more. Yep, that's all. But that's not, that's okay. That means if you have a project that got created with the full version, you still can open it even if it has more than 5 drives. You can open it with a free version, and you probably can do some kind of diagnostic. Or for example, here we can change in the Profinet, we can see the station name, we can change the Ethernet IP address. In diagnostic, we would see if the PLC is communicating to it. That's kind of what we need to get out. And the next thing, and then it gets really into the drive programming. Okay, we don't have the function block editor. Yep. You see it here in diagnostic. Normally this one is now populated. It's highlighted, and then it tells you how many data cycles per second you have there. If the PLC is not communicating, you have 0. And if it's communicating, because we communicate in an 8 millisecond interval in Toledo and in Sterling Heights, you will see 125. So, yeah, I don't know if the solution is you can open a project. There are some, you can change Ethernet IP address, but you don't have access to the function block editor, what we will discuss probably, I don't know, later today or tomorrow. And yep. So that was let's see, safety options. Normally the safety, I mean, since we're here, I mentioned it a little bit that on the Siemens side, we do the safety through the bus system. So also the Protex have some safety parameters. Like here's a safety address and like, oh, that was a wrong one. Like safe stop time and so on. And that is also one main difference between the Allen Bradley and the Siemens. On Ethernet IP, we don't have something like this. We have no safety parameters because everything or the safety is done through discrete inputs.
Excuse me, Matt.
Yes.
It's hard for me to see. If you can kind of.
Oops.
Make that a little. There you go. Perfect.
Yeah, it was just. All right. What's also interesting to know for the safety parameters are not a part of the normal drive program. So if you download something to a new drive on the Siemens side or on a Profinet side, you have to download 2 sections. You download the application or the drive program, the power rollback program, and then in addition to that, you have to separately download the safety parameters. That is important to know. So the safety parameters are not a part of the drive program. There is even a special password. If you click here on site, right now it doesn't show up, but if I would press the the download button, a new window will pop up and it will ask me for a password. It is similar like you guys probably know the safety PLCs. If you change something there, you need to put a password in. What's also important to know is that on the Siemens, on the safety parameters, they have a checksum, and there are overall 3 checksums they normally should match. There's one checksum that is in my parameter set, for example, what I have right now on my laptop. Then there is a checksum in the memory module. Here in this, hope everybody can see it, in this memory module, that is the second one. And then the active one, that is the one, basically the safety card who is inside the drive and doing all that safety, that has also a checksum. And normally the idea is that they're all the same, then you're good. Also what, for example, what happens now is if you replace, or if your customer, Chrysler, is replacing one of those drives, you have to kind of picture when they get a new drive, for example, then the safety address here will be different. In factory default, we ship it with 1. And now you see the checksum just got changed. Once you change here one of those numbers, the checksum got changed. So when you get a new drive, it probably shows up with that number here. I'm sorry, I lost a little bit. Where is? Safe transfer. So this number is now, for example, in the safety module. But then when I take the memory card from the existing drive and put it in the new one, that means now the memory module has, like say, a safety signature of 100, and this one has a safety signature of 50. So therefore, I mentioned that before, you have to press, or the guy who is replacing the drive has to press the T1 and T2 button in a special sequence. We will go through this later on, but then the idea is that whatever safety parameters are in the memory module from the old drive, from here, they get transferred into the safety module, and then the drive will work with those safety parameters. And the idea is it needs like a manual confirmation. If you replace a drive, somebody has to confirm that action. That, for example, you can picture 2 power roll beds, and one has safety parameters, and the other one, for some reason, has no safety parameters. And now to prevent that somebody takes the memory card from one drive and puts it into another, and deactivates all the safety, therefore you have to press this buttons. So basically the guy who is pressing the buttons basically confirms that he knows what he's doing. And somebody is laughing here, or okay, but no, that's the whole idea. And then also after you replace the drive, you're supposed to do an e-stop test and make sure that when the line runs, that it still stops and everything is good. So I guess the conclusion from this exercise is, I think when somebody prepared the project file for a line, you can open it with the free version. It looks like you can do some monitoring here. You cannot add another drive. You probably could change the parameters. If you go here to all parameters, you can basically, you have access to everything that you need. The only limit, or the second limitation, is that you don't have the full version. And now, let me just see one thing. No, I was just looking for the option maybe to update it to a full version, but I don't see it here right now. Okay.
Lunch is here.
Perfect timing.
I was going to say perfect timing. I do want to revisit this particular software with regards to state line versus high line, Siemens versus Ethernet, and the module itself. If that's okay. All right. We're going to break for lunch, and I'll be right back. I think so. Thanks, Rick.
Looks like.
It's all you, Matt.
All right. So what we got from Bob is that hand terminal or remote keypad. I mean, you saw the picture. That is basically the keypad. You probably can also take it out somehow. I don't want to break it. But yeah, it comes with this housing. That cable is built in. And then the idea is you can, it works with both drives. I mean, normally you want to use it with a ProTech, but you also can use it with this one here. You just stick it here in, and then you can use it. And the same works with a ProTech. Let me show you. And there it becomes even a little bit more useful. Yeah, you open the cover, and then, oops, stick it in. And then here you can, I mean, technically you can basically program the whole drive through it. You have the access to the codes. But where it makes sense would be to change the Ethernet IP address, save it in the internal memory. Then you have to cycle the power, and then you're good to go. I mean, it's kind of nice to have. I don't have it, and I'm kind of still alive. So, I mean, but I mean, normally what I do is instead of using this, I have all the stuff I need on my laptop. I have the software on my laptop, and then I use a diagnostic interface. So that's how I'm still alive. If you don't have this, and even more important, if you don't have the software on your laptop, that is a nice option to get around. I think that's the best way to see it. When we when we talk about this, about where the information gets stored, it's probably a good idea to kind of address it or to talk about it.
Are we able to change the memory card from one drive to another? Take it, for example, if one of them loses the information, take from this memory card, from this drive, and put it on that end. Change the IP address and make it work. And then put it back and reprogram that memory card.
Yes, the question was when you basically you have two drives and you want to take the memory card from one drive, putting it into the other drive, and then maybe copy it and so on. I think the answer is no, and the reason is what you want to do, therefore the answer is no, because you cannot, the whole program, what we download to the drive, is stored on this memory card. That means you cannot operate the drive without the memory card. So it's not like this is a memory card and now you download it from here to the drive and then you pull it out and you put it in here.
So the drive doesn't function without that.
You know what, that is a good question, and at least during the startup you need this card, because then the drive during the startup, it reads out the information from here and then it works with that. I don't know what happens if while the drive is operating you pull that out and you go to another one and go from there. That is maybe something. I have a drive here, Chris has a, we can maybe play after we're done here a little bit with it, but that's something I wouldn't really promote. I mean, I wouldn't promote to pull out the memory module while the drive is working. That's as easy as that.
This is what we do with the Emerson,
Yes.
We take the card from one and then put it on the other one.
That's a specially designed card that's like an SD type card, other than it being big and flat.
Yeah.
Yep.
Doesn't matter, I mean, it's a memory.
Yeah.
Yeah, but this one, if this one goes right to the processor and if you shut down a part of the hardware, then again, I do not promote it. I mean, what you do is kind of up to you,
No,
but I mean, it's...
Is it possible to do so?
I'm not aware of it. I mean, it's, this one, I don't promote to pulling it out with power. You know, you normally want to pull that out when the drive is off. Yep.
Yeah, because pulling that out would be the same as opening up your PC and yanking your memory card while it's pulled.
Yep.
That's what I'm asking. Is it working that way, or is it something that we can?
That's what it sounds like to me, but I don't know.
Yep. What we also have is a cloning device, and also Office Bob has it somewhere. It is a device. It has it's a size, I don't know, like this. You can stick in 2 memory cards, and you can clone the master into the slave. So that's what we, for example, use for. Right now, we still maybe don't get the drives from Glendale Heights with the latest software, because, for example, I gave the guys the wrong Ethernet IP address. So one way to get around this is to have this, to redo it, create a master memory card, and then when new stuff is coming in for software testing, Everett used it, Rich, did you already used it? You just take whatever card you have in your project, you take it out, and then copy what is on your master chip on the new one, put it back in, and then if it's a Profi safe, you have to confirm, you have to do the safety confirm. If not, you just put it in and you're good to go. All right.
Everybody, this is Elmar Prihoda.
Hello. Elmar, I'm with Lens. I'm a field service engineer.
He is our application support from Lenza, and he is currently supporting the SHAP project, and we are questioning as to who will be our application engineer for the Ford project. I believe that we provided his cell phone number at the very beginning. Yes?
Yes. Mm-hmm.
If you have any questions, concerns, application-wise, application support in the field, Elmar is your guy.
Yep.
Matt, I lost the screen.
Oop, you lost the screen. Oop. Probably a sleeping mode here. Oh, Mike. Look, perfect. All right. Yeah, I heard that request. You're not the first guy who asked me that question, so it's okay. But again, I don't really I don't think it's a good idea to pull it out while it's energized. And
basically, every time that we need to, if one of the drive dies, what are we supposed to do then?
when the drive dies,
I mean, let's say loses the program or whatever.
that is a good question. Normally the only way to get around with, or the next thing would be the software and download the program through the diagnostic interface or through the Ethernet IP or from the Ethernet IP default. That's
Ethernet IP default, what does that do?
yeah, the factory default, how it comes with.
Okay.
Yes.
Does it go to the back? Is there any reset button that you can reset and then goes to the back factory default, everything?
I mean, there is not a reset button. There is a code where you set the drive back to factory default. Yes.
And how do we access that?
Yeah, through the software or through the keypad.
The questions that Baram is asking is with regards to, you have to repeat the question.
Yes, I know. Yep.
The questions that he is asking with regards to program, we covered this morning in that the component itself comes preloaded with the firmware and the program. We have not covered the VFD replacement, but the questions that he is asking will be covered in that portion. Okay? Hold that thought, please.
So, all right. So, yeah, the program, the parameters, communication settings, safety settings, they are stored on this card. And one question was probably hard to read, but the question was, we have different revisions, like how do we see what firmware or is inside the drive, where do we see the application revision, and so on. Let me explain that, or let me try to explain it here in this software. That is, again, that is a free software that everybody can download. I have the file from Toledo underbody respot. I go maybe here to the power rollback drive, and then when I click here on all parameters, I see all the different codes. I mean, that's a little bit, now we are kind of a little bit ahead. And then there is always a folder identification. Oops, that's the wrong one. Here, when we go to all parameters, we see that in code 99, that is standard with all our Lensa drive. We see the firmware revision. That's what we ship right now, the ProTech with, 6.02, at least what we have in Toledo. That would be the firmware revision. And the firmware is basically built into the drive. The firmware is not here, so you can swap this kind of all day long. This number will stay the same. That is it's like Windows 7. I mean, you can install Excel, you can do whatever you want, it still stays Windows 7. You have to update it to Windows 8, then yep, you have something else. So the firmware is basically built into the drive, and you can read it out with code 99. How you can read it out? You can read it out with a keypad, or you read it out with a laptop communicating through the diagnostic interface or through the Ethernet IP Profinet. Yes, so that's a firmware number. More important for you, we also have a software revision number. And there we have two, let me, you know what, let me, this one here expands that a little bit. When I click on it, it gets bigger. Here, since in Toledo, we started, you know what, let me redo this. Start somewhere else. I go back to all parameters, and now I go back to the Profinet options. And here I have process data. The drive is sending 16 words. Yep, that's funny. That's 15 to the PLC, and it's also getting 16 words from the PLC. And by our specification, the last word, the last 16 bits that the drive is sending, that is more, I guess, more important for Mike. There we have the software revision number. In Toledo, or here in the Blue Room, a long time ago, we started with version 1.0, so it was 100. Then we changed it to 1.1 when we went to Toledo. And then after we did some modifications, we revved it up to 1.2. So to see the software revision, the basic software revision would be, one way would be this code here, that's a display code. And the software revision is stored on this memory chip. But there was kind of, in Toledo, we still had to do some development. So we were basically changing the program on a quite frequently base. So, and we didn't want to have this number incrementing like every other day, because then we were kind of running out of numbers. In addition to that, we created a new code. We created this number here. That is also like our timestamp or running software revision. So the idea is here, that is the internal version 19, and it got basically put into place, into operation 2013-08-24. So that was just a couple of days ago when we downloaded this last Saturday to Toledo.
Where would I see that number?
This number you will see in this code 474 subcode 8. You don't see it in your PLC. The only thing what you see in your PLC is a 1.2 and or 120. What we probably have to do or what we should do, because we want to also do some more modifications for the Ford project, or I would like to do them. So I think I could rev this up to version 20, and then I probably bring that to 1.3. And then you can, yep.
So how would I be able to tell from the PLC side if I have the most current revision if we don't always change that 120 number?
Right now, I mean, there is no way to see it from the PLC, because I just mentioned it to you. We haven't revved this one up on again and again and again. I mean, now since we are at one point when we want to, I don't know. I mean,
starting point.
Yep. I mean, maybe with version 20 we just rev it up to one. I mean, you know what? Maybe we just, when this one becomes, I have to talk to Al what he wants to do there.
What do you recommend?
Well, first I would recommend that anytime we make changes in there, we change that number. The bottom number is nice, I understand, to have those smaller revisions. But if you go to, like, let's say 2.0 for the Ford stuff, you're going to have 99 revisions before you get to 3.0, right? So that way, anytime that anything changes in there, I can see it right from the HMI interface, what version is in the,
okay.
drive.
All right, yeah. I mean, that was the original idea, basically, to get exact that out of it. Yep.
Right, because we have a direct link to the drive, so that way we can see all that information right from the HMI. So any drive that I want to see, I could walk up to the HMI for that line, go right to that drive and verify that it's running the correct version versus my AOI.
Mm-hmm.
And then, yeah, anytime you change anything inside the drive, you should be changing that word.
Okay.
That is what I wanted to hear. Keep in mind that because we were in the development stage in the Toledo,
we didn't want to keep changing and changing and changing. So now that the drive is where it needs to be, Matt, I do believe, and I agree with Mike, that from now on, whenever we make a revision, we should change that. Because at this point,
No,
we
I
shouldn't be
agree.
making
I mean, that's the reason why we put it in the first time.
I mean, that's
Yes.
just an integer there also, right?
Yes.
So you could actually go to the thousands place and go to 2.000.
Yes. The only limitation is on the Versa lift. We have it a little bit different because there we had the problems with the 16 words. We had to map 2 revision numbers for the leader and the follower into a 16-bit word, and therefore you have only 8 bits. And I decided how we do it. There we do it like is it like 1.1? You know what I mean? Instead of like 2 points after the decimal, you only have 1 point. Yep. But no, I agree. I mean, that was the original idea. But on the other side, in Toledo, this information, it gets used at one point in the PLC, but we only check if the revision is greater than 0, because that tells us that we have a valid communication between drive and PLC. Anywhere else, we don't use it. There is no CAS spec to show that on the screen or so. So we haven't done anything with it. Here in the Blue Room, we display it, and it's nice. But since we haven't done anything in Toledo, we rather stayed with that number here. But, yep. And again, those 2 numbers are stored here on the memory card. And yes. Any other questions or?
Software versus SP numbers?
What?
The
I just didn't get it.
service pack.
Service.
The software.
Oh.
Service pack.
Oh, the engineer. Oh, the engineer.
What we talked about is firmware, and then we talked about the program revisions. I want to talk about the software engineer.
Okay. Yep. I mean, if you go to engineer here, you will see that is now 218. If it would be service pack 1, it will increment this one here to 218.1, 2, 3, and so on. What's also really nice is that here you get some more information about the internal components of Engineer. For example, the Ethernet communication manager. Right now we are there at version 17. Since we're already here, typical Lancer releases, softwares. In Germany, there are 2 big trade shows. One is in the spring, that is the Hanover trade show. Probably you have never heard about it. And then there is another trade show right around Thanksgiving. That's more in the south. That's another automation trade show, a big one. And those are our main milestones or events where we release new firmware. New software. So many times around, let's say, Thanksgiving, and then in March, April, Lenze is releasing a new software revision of Engineer. 218 is now active, then it would be 219. And in the meantime, if there needs to be some improvement, the last time when we rolled out 218, our colleagues from China came up and they said, you know what, we have with 218 and with Windows 7 or so a problem with the Chinese language set. So therefore they came up with the Service Pack 1, and then there was the Service Pack 2. So the Service Pack 2 is kind of addressing a short-term kind of smaller fix, and then every 6 months, normally there could be a new version of Engineer. Just to, if somebody from you like complains, why is there something new out? When we embedded new stuff, we also, what is it? Like when we roll out a totally new series of drives, I mean, that drive has to be programmed somehow. So therefore, we have to come up with a new software. I mean, on the other side, what we did with the project in Toledo, we tried to take what we had at this point of time and then just kept it using up to now. On the other side, I mean, Everett can probably confirm it. Sometimes it's even nice to use a more up-to-date version, because in 2.16, what we guys used in Toledo, we had that built-in oscilloscope function. Here, the oscilloscope function, you can monitor up to 8 channels inside the drive in a millisecond task, and you can see what's going on. The only problem with 2.16 was that sometimes it didn't really update the data, or when you want to save it and then you want to reopen a saved file, engineer really had a hard time. So then with a new go around with version 17, they fixed it. And that is a nice thing if you have a parallel installation. You still can use 2.16 like everybody else, but for example, if you want to use the scope function, you could go to 2.17, 2.18, and use there some improved functionalities. Yes, software revision.
So if I understand correctly, and I want to make this clear, if you were to order, and this is for the after sales guys, a spare part for Toledo and Shap. In Toledo, Chris, correct me if I'm wrong, you would get the firmware 6.2?
02.
6.02 with a software version standard, the service pack 2.16.
I mean, no, that has no, the service, the 2.16 has no impact of what you order. The 2.16 is only on Engineer.
Okay.
This one is only, that's a firmware version.
Yes.
So when you order a drive for Toledo, it comes with 6.0, or it comes with the next, I think now we ship 7.0. Or, yes, I don't know how you guys did it. That's something you have to figure out, if we attach a firmware to the S number or not. I'm not.
I thought we did.
I don't.
No,
I don't.
we didn't.
Sorry for that. I don't know. That's again something.
Okay.
Somebody has to tell me.
I don't want to do that, because anytime we do an upgrade, we have to go on the numbers, just like every time.
So right now, the only thing that we have controlled is the program version that we're loading in, correct? Matt?
Yes.
Okay. So with regards to the firmware and the service pack version, my concern is making sure that what you have on your laptop, and if you modify a parameter in the field, what version you're looking at versus what you can modify. And I got confused about this. This is why I'm mentioning this. It may make sense a little more to you guys. If I have, and this is the part where I kind of wanted you to go into, the program itself and the parameter is saved in the module.
Yes.
What we're used to in the Emerson, and I'm not familiar with Rockwell, the program is in the VFD. The parameter can be saved on the credit card. In this particular case, the program and parameter is in the module. If you have a software service pack 218,
okay,
and I'm looking at the program here that was made in 216, what limitations or any challenges do I have?
There are no challenges. There's no limitations. Let me just jump in here.
Okay.
Now we start going somewhere where I wanted to go maybe tomorrow.
Okay.
I know in Emerson you had the program and the parameters. Here in the Lancer drive, when we talk about programming the drives and Working with the drives, it is a little bit different. It means that we only have parameters. I mean, even if I program the drives or the drive, what I do is I change parameters. So overall, we just have one set of parameters. That is the program. So there is no separation between parameters and program anymore. That is all. The program are the parameters, or the program is how you set the parameters. That's I know that in Emerson it's a little bit different, but just to, yes.
And we can repeat this again tomorrow because not everybody is here and it bears repeating anyways. But I want to maybe, and I don't know if we can here, if we modify something on the drive,
okay,
whether or not what's in the drive versus what's in the module and what's saved in the module versus your laptop and so forth. Are you going to cover that tomorrow?
Well, I mean, we can, yes, we can do it
I'd
also.
I'd like to cover it today and tomorrow.
Okay.
Because we might have more questions tomorrow depending on who's here. So if you could cover that, please.
Yes.
Is that a drive hooked up?
Yeah, we can hook up a drive here, or I mean, again, I think I just, oops, I'm sorry, that happened before.
That was only his microphone.
Oops.
You want a sec for you?
Oh, I just took it apart. Can you still hear me?
Barely.
All right, then I think we're good. Let me try to swap here the laptop. Oof. Nice. All right. Okay, I just made up this presentation here, or I modified an old slide. The idea is that we have like two different levels of software in the drive. We have the firmware that is basically embedded somewhere in the drive here and somewhere embedded here. And normally the customer, you guys, cannot change the firmware. You get it with version 6, you get it with version 7, or this one is now probably version 12. That's how it comes. And then everything else, or in addition to that, we have the parameters. Basically, one idea is to see it here. That's you, that's the user, and here's the hardware. And in between, you have to the hardware, there's the firmware talking, and then between the firmware and the user, basically, you have the parameters, or the option to configure the drives through the parameters. And there you can do an upload and a download. That means you can go online to the drive, hook up your laptop, and you can read out the program. That means you read out the parameter. You also can download the program. That means you download the parameters. When we talk about this, maybe, sorry to make it a little bit more complex, but when you have a Profinet drive, when you have a Profi safe version of the Protec, then in addition to this, you have here in this area a special or a separate area for the safety parameters. The safety parameters are not inside the normal drive parameters. I mentioned that before. When you have a brand new Protec and you want to download it to the drive, you need to download the parameters, and then you need to download the safety parameters. Is that clear, or Everett, Rich, does it make sense or does it help to understand it? Also compared with Emerson or Alan Bradley? I mean, if there's feedback, let me know. Okay. So now,
Is that clear to you, Rob?
I do understand it. The only problem that I do have is that the swapping, because if it is a parameter, it's going to be the same as the Emerson card that you are putting the parameter on that, right? The credit card is the same, but it's not the application basically, correct? It's not software that when you are getting these information from this slot, and then you are saying, okay, I got this, and then you are.
yeah, that's the whole program. Yeah,
Right.
that's.
Now, but I'm just wondering that why I can't basically take one of these memory cards and plug it somewhere else. That's all I wanted to know.
Yeah.
If it is a parameter based.
Yeah, because this is a part of the drive. As your colleague just said, you cannot steal the memory. I mean, we can try it, but again, I don't recommend it. So it's.
I want to clarify that question because I think everybody that is pretty familiar with the drives understand why you can take that card to another one. There was a difference between Emerson and Lenza. This is the complete shebang. Okay, program parameter, we're just calling it parameter. For Emerson, we have the program in the VFD and we have the parameters on the card. Correct me if I'm wrong, Bill.
We put the program on the card also. The easiest way to compare it to is most everybody in here knows an Allen Bradley drive. Lenza is the same as an Allen Bradley drive. It's all parameter based. You suck them out and you put them in. It's the same thing. Lenza has it on a card. Allen Bradley now also has it on a memory chip. The only difference is Lenza, what she will cover later, has a nicer interface to work with the parameters, move them around, and interface with them. Allen Bradley, you have to remember all the parameters, where you put them. Lenza has a better GUI or a user interface with the drive, so you can just sit there and visualize and see everything.
Mm-hmm.
But all in all, it's a parameter-based drive. It's no different than an Allen Bradley.
If you take a card
You know
from,
what?
say,
I think the problem starts with labeling this a card. If you look inside, it is a memory chip, and the chip goes direct into the drive. That means normally when you have a memory card, you have a card reader with an interface, and the card reader allows you to take out the card and plug it back in. Here, I can show that you around. It is basically just a connector that goes onto a board, and then on the board you have just a plain memory chip. So it is not really a memory card that is meant to have like hot plug capabilities. It is basically just a small chip that comes into a bigger housing to.
It's a sticker RAM, not a flash drive.
Yep. Mm-hmm.
Yeah, so you take a chance on plugging it of zapping that memory chip.
Yes. No, but I mean it's important to address it.
well,
That
there's two things. There's two things we're talking about, right?
Same as your Allen Bradley, you can't pull the chip out hot.
Yeah.
Doesn't
So
run from the chip. I mean, yeah, that thing right there.
we're talking two different things: hot swapping, and going from one product to another, or one VFD to another. So I want to take that one at a time. First of
My
all,
concern is basically going from one VFD to another, because I'm sure sometime in the future, somewhere is gonna happen that the VFD loses the information.
Man, you can take it from one to the other, they just have to have the power off when you unplug it, when you put
Yes.
it in,
Well,
correct?
if
Yeah.
you do that, you are not gonna be able to save it back over here again. That's
But
what
there's
I'm
no
concerned.
cloning
But-
device to reburn.
but that is the whole.
Happens,
That is the whole point. Even if you could do it, the way where when you go online and you download the parameters to the drive, where do you save the parameters?
It's supposed to be in the EEPROM, double EEPROM.
You save it here. So it doesn't do you anything good if you take it from this drive. You want to take it from here. Basically, you don't. The point is, his idea is if it's saved here in the drive, and then his idea is you copy it from here into, let's call it the memory card. then you take it to another drive, plug it in, download it from here to there. That's your idea.
Yes.
But that doesn't work because you save it here. So it's,
That is the program.
yes,
It is the memory.
it's,
Well, it's got RAM.
I mean, it has,
What's gonna happen is theoretically speaking, like Chris we were just talking, theoretically, and I'm not saying to do this, Matt, if the drive was.
I know what
powered
you
up and
want to
running
go.
and everything there, and you pulled the chip out. Now mind you, this is theory, don't do it. You pull the chip out, the RAM would be running and it'd have it in there, and it'd continue, let's say, seeing the program and running. However, once you power it down, it's RAM. Just like a
Yes.
computer, you lose everything.
Yes.
However, because that chip is not hot swappable, you do not want to pull it out while it's alive, because you'll probably blow the chip or create what you call very unwanted results. You don't know what's going to happen. So that's what it is. The drive's RAM, but it needs to see that chip when it powers down and powers up. And because it's powered up, you can't pull it out. But in theory, if you pulled it out, it'd be in RAM, just like a laptop, running
Yep.
or whatever. But you'll probably get undesirable results.
So what am I supposed to do? Let's say the scenario happens and then one of the drive dies. And I
It's
lose
on the
program.
chip. So the drive dies, you pull the chip out, get a new drive,
No.
put the chip in and power it
We
up.
lose the program.
No, it's on the chip.
It's
No,
on the-
he's saying, say the chip goes bad.
Oh, well, then you need a laptop like you do every other drive
Then you
in the
just,
world.
like you do, you take your laptop, save it from the one that does work, make it to the one that needs it and load it in.
Can we do that?
yes, that's,
You can upload
Um,
from one drive
no, I
to a
mean-
laptop and download it to it.
I mean, that's a valid point, and Kevin and I, we were just talking about this in Toledo. I mean, I don't know how likely it is that the chip goes bad, but I mean, it's possible. Another thing is you're in the overhead, it is 3 o'clock at night, you have to replace the drive, then what happens? This memory card falls into the plant and you won't find it again. And then you're at the same situation. And then the next question is, what do we or do you provide the customer? Do you want to provide them the full project file? Yep. But again, that is only, it depends what you want to do. For this, it's not doing you good because you still have to, on Siemens, you still have to change the safety address, for example, in the return loop. So, we talked. Yep. No.
We don't hot swap, period. Now, I wanna make sure we finish that conversation, okay? No hot swapping, period, no ifs, ands, or buts. With regards to taking a memory module from one drive to another, there's a difference between a power roll bed to a power roll bed, high speed to high speed, low speed to low speed. There's also high speed to a 4-column elevator. Just like in Emerson, you wouldn't take this card from a power roll bed to a 4-column. We're clear on that,
Yes,
right?
yeah,
Okay.
we know that. We know that part is clear. The only thing is that how to retrieve the information and make a drive goes bad, whatever happens to it, make it work.
The same way as an Allen Bradley. You've already had that training. If an Allen Bradley drive goes dead, if something goes wrong, let's say the whole thing takes or let's say they lose it, because they do that. That's more likely to happen. You have to take a laptop with the program, grab a new drive, and download it. And just imagine the chip, the drive, everything's gone. The chip takes a crap. You need a laptop.
No,
Now,
that's fine.
on
That's
an
fine.
Allen Bradley, you can go down the line to another Versalift, another roll bed, suck it out, put it in that one. Same thing with the Lenza. It's parameter based, suck it out, go to the
Can
next
we
one.
upload the information from this drive?
I mean, yes, but that means that the memory card is still good. You know, I mean, or.
He just finds another. the
Oh,
same
sure.
type of drive.
Oh, sure.
And
Yes, you
then
can.
bring it and bring
Yes,
it down over
yep,
here and
you
download
can.
it.
Just use the cloning box.
Yes, I mean, the other thing is, yes, I mean, you can upload it from another drive, and you can put it into. I mean that's possible. But in addition to that, you also what Daisy just mentioned. Let's say you have a Versal roll line, and station 12 and station 13. The program is, in this case, the parameters are pretty much all over the same. The only difference is the Ethernet IP address and the station name. So what you could do is even it's a little bit complicated. You have to really break it down to the different drives because they all they're a little bit different. Let's say Profinet, this one here, Protec. On a brick, we have, let's say this one here. Everybody turns around. This is station 3. That is station 4 probably. The parameters in this one and in this one are exactly the same, but the Ethernet IP address and the station name. So what you could do, or what your customer could do, one option would be also this cloning device. Then he can have, for example, a prepared memory chip, or he can go to an existing station that is still working, pull that out, put that here in the master slot, take the other one that comes from the new drive, put it in here, and then you turn it on, and then you can transfer the information from here to there. Takes 2 seconds or so. Then the next thing would be you have to go to the Siemens PLC, and from the Siemens PLC you can reassign the Ethernet IP address from the new chip. It will have a different MAC number. The Siemens will detect it, and then you can assign the Ethernet IP address, and you can assign the station name. Okay, that would work. But you would have a problem if, for example, if you're that is a Versa row line. In a Versa row line, we have for each brick 1 PLC, and that means the safety address for this one here, for this drive, is the same as the safety address for this one, because they are talking to different PLCs. On a drive in a return loop, you have maybe 60 drives, all controlled by 1 PLC. That means, in addition, the program again, it's all the same. The difference now is the Ethernet IP address, the station name, and in addition, the safety parameters. The parameters that are not here, those ones. In the one drive, it is 500. In the next drive, it's 510. So if you would clone it, then you would take a 500 and you would bring it to 500, and then there is no way to change the safety address without having a laptop and the special firmware. The engineer software. So then you're back to engineer. So that's kind of the worst case with Siemens. To make the long story short, I think for example, they need the software and some kind of communication. And then the question is, should they get the program, or should they give them just maybe one master file for each application, and then just tell them, if you have to replace drive number XYZ, you get your master file number BB, copy it, and change those few parameters. The good thing is that happens once in a blue moon, because the whole idea is to use a memory chip. But we should have like a backup plan in place in case this one gets lost. Oh, there it is. When we go to 552, we kind of have the similar problems. In 552, we have kind of, in this case, the advantage. We do not have here the safety parameters, because there we do the safety all with discrete inputs. So that would think, oh great, we don't need the software to change safety parameters. The only problem with Allen Bradley is that Allen Bradley does not support Lense in RX links, where you can assign an Ethernet IP address through the software. So therefore, what we can get away with it when we ship a drive pre-programmed for the application, then you can use the keypad or the handheld to change the Ethernet IP address, or again, they use the laptop, hook it up, and change the Ethernet IP address. It's, yep, I mean, it needs to get addressed, but, and it needs to get like sorted out, but I think if we have done that, even if it sounds complicated, the good news is we hopefully never run into that problem, because this one shouldn't go bad if you don't do hot plug, but, or if you don't lose it. And that's what we kind of aim for. On the other side, there should be a plan B. If this one gets lost, or if it goes bad, yes, there needs to be a plan B. And
Do we have a single point lesson for this?
a what?
A single point lesson?
I think we really haven't. We are still discussing what we want to give the customer. I don't know what.
The question is, do we have a single point lesson? The answer is no, we do not. We have this installed in one project, we're installing and commissioning in a second project, and on a third. The first two are on a Siemens Profinet, and because of the ease of configuration via the network, we haven't really discussed it as much, and Triva has brought up a lot of good questions with regards to the Rockwell Ethernet IP limitations, shall we say, and we haven't quite finished that thought. I want to make sure that we agree and understand with regards to the, oh crap, I lost my memory module. Two options. You can go to another one and take that and clone it, or you can use your laptop to go there, get a copy, and download here, right? If you lose that chip for whatever reason, you hot swapped it when you shouldn't be, or you lost it, dropped it, can't find it, you have those two options. Is that clear?
Yes, absolutely.
It sounds to me like just using the laptop is probably your best bet to start out, because you're gonna have to change the IP address anyway.
Actually, from the factory install, I'd like to see the little handheld unit, because it's gonna be a lot easier to go through instead of 50, 60 drives per line with that little handheld module. Because otherwise you're gonna have a carry your laptop, worry about your battery juice and that stuff. Those little handheld modules are gonna come in nice for just setting IP addresses.
Agreed.
Yes.
Yeah.
Agreed, except for the virtual. Because you have to have direct tie-in to the VFD, and the Versa-rolls are at the top.
Or at the top, right?
Yeah,
So
so,
other than that.
yes.
Yeah.
Okay?
Yeah, but I know, I totally agree. But that was more for install. We were just talking after the install is done.
Yeah,
And
I know. You was just
yep.
brought up the point on install.
Yep.
I was saying that for install, I would rather have the handheld module if I can reach the drive.
With the Allen Bradley, you'll have what you're talking about. It's not I don't think it'll be handheld. It's the keypad that just plugs in the front of the drive, right?
Oh, for these?
Right, it'll be, some of the Allen Bradley lines.
No, there's an actual
Yeah,
handheld module
we're
with a little plug.
talking for the ProTech, you can have the handheld, or you can have the direct keypad.
Right.
He's asking for the
The
handheld.
handheld.
for the ProTech.
That does the same thing as the keypad, right?
Yeah.
Yep.
Yeah, it's just like, cause you know on the Allen Bradley, how we only get one good HIM module, so you gotta take it down the line anyway. This is the same thing.
But this is just a little bit easier because it's got a better connector on it, so you can just plug in.
Yeah, you don't have to. The other thing is technically, you're having Matt cover, that's a Siemens issue. That's, when we're talking about the Profinet, all the names and the IP address, that's all done in the from the Siemens, Siemens control panel as far as, wherever your programming station is. That's not really a drive issue. The drive itself, like, it's parameter based, it's gonna be just like the Allen Bradley, moving a HIM module or moving the keypad like it is. Right now with the Emerson, if you take a card from one drive to the next, what's the first thing you gotta do? Switch the device net address. If you drop a new robot in, you put a program, you still gotta switch the device net address, IP address, that's all the same. Everything that you guys are covering right now is actually the Siemens part of it, not the drive part of it. It all has to do with Siemens as far as the station name, the IP address, that's all done from Siemens. Safety, all that, that's a Siemens thing, so. That's probably why.
yeah, but no, Kevin and I, we were just talking about this like 2 weeks ago on a weekend, and I talked to Al. We kind of, we never really addressed it because we always said that this is our, I mean, that should cover 99% here, come out, the memory model. But we need to have a plan B in case when you get a call, or you don't want to get a call at 2 o'clock in the morning. There should be a, what is it, if that happens, the operator should go to his computer and then like plan B, what do I have to do? And then we can all sleep. And I mean, there are several options. I mean, I don't really, okay, now you tape it, but I don't really care how we do it. But like you just said, we should give the plant guys, for example, the software so they can, at least I think maybe at one per shift, there should be a drive expert. He should have like a software tool to be able to download the drive to whatever he needs. But again, I mean, it is also what do you like? You know, it's and then we have to also separate it between Siemens and Allen Bradley, because on the Siemens we always have those Profi safe parameters. Those are separate, and the only way to access this is through the Lensa software. That's kind of a part. What is it? There's no way around it. With Allen Bradley, that's different. There we don't have safety parameters, and there we can get away with, for example, this one here. All right. So to the, what I wanted to show, or since, okay.
You've got me thinking.
All right.
On the Siemens side, what comes preloaded is the safety address that we have designated, correct?
Yes, for the test stand, yep.
For the test stand.
Yep.
Which is different from what?
Now we try to make 500 is our basic safety address, and 500 would be, for example, would work here in the downstairs Versa row line. This is a 500 drive, the safety address, not the communication address. The same would be if that would be a power roll bed. This one would be 500. But for example, upstairs in this return loop, or what you see here, that would be 520.
We have designated safety addresses that we have identified and preloaded, correct?
No, it just you have, for example, the power roll, Versa roll application has one S number, and it comes with one Ethernet IP address and one safety address, because that is how we test it here at the test stand. I mean, we
had it set up for product testing.
Yes.
Okay. This is for the after sales folks. Not necessarily for Triva because of the difference between Siemens and Rockwell. When the VFD comes into Kamau from Lensa, it is preloaded with the program and the IP address and safety address for the product testing. So when it goes into the plant for part replacement, commissioning is done, production is going on, and you are replacing the component, the VFD, you will still need to modify, you will still need to configure the IP address, the station address, and the safety address, correct?
Yes. On the Siemens, yes, you need the safety address too.
On the VFD side,
because there is no drive-based programming safety, we don't have to do anything safety-wise.
Correct.
On the other side, I think those come not loaded, because they just come out of the box. We don't have an S number for a 4-column elevator. We don't have an S number for a 2-column elevator. So, what?
We do.
For Ford you do, but for TNAP and Chevy,
I didn't know that.
the same.
But do they come now also preloaded? I mean.
No. Paramount Drive never did because of TNAP and Chevy. We couldn't figure out
where they end up.
That's right.
Yep.
That's right. Because we had one drive side.
Yes.
But now
That's
2Com,
right.
4Com uses,
That's
2Com
right.
uses 11, 4Com uses 15.
Are you guys following this conversation? So for the after sales guys, Toledo and Shap, you will need to change the 3 configuration settings.
IP station and safety.
Correct. For P552, safety address irrelevant, and it's only the, yes.
Does it matter if you change or not?
No,
Yeah.
there is no
Yeah.
safety address
I know.
for
For
552.
Rockwell.
For 552, there's no
But
safety
the-
risk, there's only safe torque off. We covered that this morning.
Yes.
The safety address is only relevant to Profinet, ProfiSafe. And with regards to the panel drive, because of the fact that we had several applications with the same drive size, the VFD did not come preloaded. So the ProTech, based on the Kamau part number, comes preloaded with the appropriate application program. The VFD in the panel did not come in and was not set up to be preloaded for the Siemens interface version in panel. For the Rockwell in panel version, it comes preloaded, correct? Because we have,
Yes.
we only have the 11 and 15
Wait.
kilowatt and the 37 kilowatt.
Rockwell in panel did not.
I thought we did that because of the fact that we had different sizes. Didn't we decide that, Chris? For the in panels to come preloaded now? That
Right.
still wasn't preloaded?
I believe the 4Com's not done yet, right? So if you put a program in there that's not done.
I mean, I modified the program, but that never got tested and so on.
So there's a timing issue there, but.
No, but in the future, I thought we agreed. That we're gonna take this, on,
We can, but we have to talk about it.
yeah. So the in-panel drive with a Rockwell version, it looks like we need to finalize that conversation.
Yeah, I don't show you that.
Okay. So same scenario as before. Any other questions? Brown?
I'm sorry. Thank you.
It's 10 minutes to 2. How are you guys doing? You need a break?
Yes.
Okay. Be back in 15 minutes, 5 minutes.
Oh.
You alright?
Where's the Shoko here?
Where's what?
Shoko. I can smell it. You got a cappuccino?
Need something to wake up. You put me to sleep, man.
Oh, I'm sorry. No, that was the food. All right. I think we can start. What I want to show you on the ProTech, a couple of useful information. If you open the cover, you probably remember, here's a ProTech. If you open this one here, then you basically see this information. This one, the status LED, you will see also, guess what, through the cover. You will see here the T1, T2 button. That is for the ProfiSafe version to confirm the model change and also have then the safety parameters from the memory chip transferred into the safety model. That's what you would do with those two. Here you have the safety, the LEDs. When they're mounted on a Versa roll, on a power roll, they're pretty small. But the nice thing is you're kind of looking for a pattern. For example, here we have link 1, link 2. That is the Ethernet connection. Normally, on a typical installation, we use a or from a switch to a drive, so only one link is active. Only in a few cases on a turntable where we, for example, have two drives, we have like one drop that goes to the first drive, and from the first drive it goes to, from the second link, it goes to the next one. So that means there on a turntable you would see one where both LEDs are active. But to make the long story short, what I wanted to say is even if the drives are a little bit away, if you look at the pattern, you still can get an idea of what's going on there. And the nice thing is you have like 500 drives in the body shop. If you don't have really a clue what you're looking for, you can pick 9 drives. They're probably acting up all the same. And if drive number 10 shows something different, you know there's a problem. What do we have here? We have the drive ready, or drive ready. This one here, it's a green LED that when the drive is healthy but not enabled, it will flash green. By the way, you also find all the information in the manual or in one of those presentations we prepared. This one, again, normally flashes green when the drive is inhibited, and then when the drive gets enabled and is basically sending a current to the motor, this one is constant green. The next one is the error LED. That means you normally don't want to see that. If that's flashing red or constant red, there's a problem. Here we have the 24 volt keep alive circuit. If that is active, you will see here a signal. Then you have an output that tells you if the motor brake is engaged or not engaged. Here you see if the bus is communicating, if it's operational, if there's a bus error, and normally more likely for diagnostic is as link 1 and link 2 input. You remember the drive has 2 Profinet ports, and normally what you want to see there a high frequency flashing, yellow flashing, that tells you that the drive is communicating. The next thing is here's this yellow stuff. Yellow means those are safety parameters, or safety, no, sorry, not really safety parameters, but those are information regarding the safety state of the drive. You have here the safety status, the error, the safety acknowledge, and the safety enable. And I will show you a video later on. What you normally want to see is, depending, for example, if you do an e-stop, I think the safety enable is flashing yellow, and when you clear the e-stop, the safety enable is constant yellow. And then when you go here, unfortunately I missed a little bit, you have the states of the digital inputs. The drive has 3 additional M12 connectors with overall 6 points, and we can configure those 6 points as 6 inputs, or we also can reconfigure 2 of those inputs as outputs. In the future, we are going to use that, for example, when we want to do that hardware link between one drive and the next for the sync mode. That means one drive would have input number 3 configured as an output. That would go to the next input drive and so on, and they are all daisy chained. But what's more important for you, again, you have here the digital inputs and the motor feedback. The encoder is wired up to digital input 1, digital input 2, and that means that when the motor is spinning, you will see here that those LEDs should turn on and off with a really high frequency. All right, the next thing, again, that's what you can see even with a closed panel from maybe, I don't know, 20 feet away. If you know what to look for, no problem. Then when you open the cover, you also have access to this information. Again, it is labeled not as a Lensa drive, it is Comau drive or Comau Versa drive. You have here the MAC address. That is sometimes nice if you want to confirm what you have in your PLC. I had to learn that you set up the communication with the Ethernet IP address, but for example, Profinet is only kind of, not really only, but mainly going with the MAC address. I don't really know how Ethernet IP works, but I assume it's maybe similar, because one time we had a prototype in the system with 2 identical MAC addresses. Even if they had like the same Ethernet IP address, we couldn't make it work. So you have here the MAC address. Here, this number, that is important. That is the Lancer part number. I always have a hard time. The one is like a product ID number. This is a production number. And here with the 0, that's normally, I think, a 6-digit number. That is a serial number. The idea is when you order a drive, let's say a 4kW drive with software revision 6.02, this number here always stays the same. If we don't do, let's say, any internal hardware changes or so on, it always stays the same. And then if we build 50 drives on Monday, we assign a number, like say here 650, and then those numbers here at the end, they will increment from 0001 to 2, 3, and so on to 50. So we can identify when those drives are built. When we build another 30 drives 3 weeks down the road, we would keep this number here the same because it's physically the same drive, but this one here would get a different number, and then the serial number would start again with 0, 1, 0, I mean with, not with 0, with 1, 2, 3, 4, 5, 6. I think you get the picture there. Was it right, Bill? Good. All right. So if somebody really is totally lost and is calling us with this number, you always can identify the Lancer part number. What you guys normally want to do, you want to go with a Comau S number. By the way, how does it work now in the future? Or now, since you have, instead of the X number, you have a TEX number, or that's?
TAL.
Ah.
Because of the SAP conversion for Comau, what you will see is the Comau part number for SAP. That is now TAL, and then S, that number.
So,
TA.
Oh, an Apple.
Apple.
Okay. Sorry. Yeah, the German E and the German A is vice versa, the English E and A, and sometimes it still screws me. Sorry for that. But again, yeah, so it comes with a Comau number. Yes. Any?
For the after sales folks, when you need help getting a component, what we need as soon as possible is that part number. But what would help us out is the size. That part number should tell us everything we need to know. But to minimize the time of us looking up which one that is that a high speed, is that a low speed, is that this, is it that? Give us the Comau number. If you can give us the size and the application, that's everything we need.
So the size is the kilowatt.
Yes. If you tell me you have a 1.5 kilowatt, I know what products you're using. But you can use the 1.5 kilowatt for the cross transfers and the low speeds. So if you tell me the part number, the size, and the application, it'll minimize the time that I have to look for a drive for you. The 4 kilowatt is used in many places. So even though you tell me you need a 4 kilowatt drive, I need to know what application you're using. I can easily give you just a 4 kilowatt drive, but it'll help me if you tell me what application you're dealing with. Okay?
Any questions or? Let's have a look here. Now you're a little bit away. Look on a Versa-roll system and you can get an idea. For example, here, the last LED in this yellow section, those are the safety LEDs. The last one is flashing. That means this section is E-stopped. When somebody would pull out the E-stop, reset it, you want to see this one going on. On the other side, if somebody is inside the cell, can you restart that or put that in an endless loop? Thank you. If, for example, somebody is in the cell and you see this light not flashing, you know there's also something totally wrong. Yes. So another nice thing that I've heard many times, and I think nobody in Germany thought about it, is what does this display tell you here? Do you have an idea? Or if you don't have an idea, we can wait a couple of seconds if somebody comes up. If not, many times if somebody who has no clue about this drive looks at this, he tells me, oh, it has a fault 0.00. Unfortunately, that is not the intention of this display. For Lenze, the F is a frequency. So right now the drive is standing and it tells you it's 0 hertz. Later on, when the drive would run, you would see here 10, 20, 30, 50, 60 hertz, whatever the drive is run with. But my point is, when we decided to come up here with F to indicate that it's a frequency, unfortunately, really many maintenance guys, when they see it, they correlate F to a fault and they think, oh, the drive is faulty. And so, oh, no, it's not. Oh, okay. That's, yep. If you talk to somebody, that's always nice to point out. What else do we see here? Again, the drive is disabled. You see the green light flashing. Here in this area, I mean, I kind of know where it is. That is the Ethernet line. The communication is flashing pretty quick. That is good. So you know that you have there solid Ethernet communication. And right now, also here, the digital input 1 and digital input 2, there's only digital input 1 active. That is because you have this HTL encoder, and yeah, just channel A is true now. If the encoder or if the motor would move a little bit, then maybe the second one would go on. What you also see here, Daisy mentioned it before, that is kind of the first design where we have what we call the turd. You have here the Harting plugs right on the drive, but you feed it with a Molex cable, and you have here this adapter. You have two in Toledo and in Shep. We were feeding the power from the left side, and the yellow cable, the 24 volts from the right side. Then later on, you decided to swap it around, and now you have for 552, you have here two Molex connectors, and then on this side you have the 481, sorry, on the left side you have the 24 volt connector, and on the right side you have the 480 mains connector. They have the same color internally, but they have a different pin out and a different keying, so you can't really screw them up. What else do we have here? Here you can see the connection, the motor connection that disappears here in the back. You have here the connection for the brake resistor that kind of disappears here somewhere. On the new drives, you have a bigger backplane, and then the brake resistor would sit here in this area. In addition to this, that's a good example. That is a low-speed drive, or a 1.5 kW drive. Maybe you can get the idea if you look at this drive, and if you look at that one, you can see here the heatsink is less than 1 inch deep, and here you have this big heatsink. And yes, this drive is also, I think, a little bit longer in this size. Any questions? Or all right. Let's see. No, that was not what I was looking for. I think that's upside down, but here, now the guide, sorry for that. Oh man. Now he pressed the e-stop, this light is flashing. Now also LU means low voltage. Somebody kills the 480. The drive is still operational with 24 volts. Sorry for that. But now the e-stop got cleared again, and the safety light is constant on. Yep. Now somebody pressed the e-stop. Yep. And I turned off the power. Then the DC bus capacitors will bleed out, and then you get the low voltage. Okay.
That displays more than just the frequency.
Oh yeah.
Yes. I mean, it also with the, if you open the panel, it is pre-programmed to display also the bus voltage and the motor current. You have to kind of cycle through it by pressing, I think, T1 button. But the problem is you have to be next to the drive to do it. And since the drive is behind the fence, that is normally something you don't really do. But another good thing is if the drive is in a fault, let's say an encoder fault or a short circuit, it will also display a fault message here on the display. Let's say an overcurrent, a short circuit on the motor side would be an OC1. You would see here OC1 or stuff like that. Or when we lose the communication to the PLC for, in this case, more than 20 milliseconds, I think that's, that is probably the one where, the problem is this one here, I don't know where that is. That's probably in the blue room, the pop-up, when we go to the blue room, the pop-up, because here, it's a pop-up because on a pop-up we use digital input 5 and 6 for the lowered and raised limit switches. And now it is in one position. So that's probably a pop-up.
So that's the pop-up drive.
Yes. And
there's no inputs on for the encoder.
Yes, you're right. Yep. And also you don't see anything here. Yep, you're right. That. Yep. Yes, and in the blue room, what we do instead of having each drive going back to a switch, we kind of daisy change them. So what I wanted to say also is, I think I just missed something. But in addition to that, here the dip switches on the drive below this cover, they don't have any functionality. On the panel-mounted drives, in the VersaLift application, they do have a functionality. Here, they don't have any functionality. I was talking about the. Anyways, I was talking about the display here. If there is a drive fault, you will see it also here on the display. Normally it is like 2 or 3, it starts with 2 or 3 letters and then 1 or 2 numbers. That is typical Lenze fault message system, and then you can look it up through the manual and go from there. Think that's it. This side, let's go back to this one here. On this drive here, we basically have some LEDs that gives you some information about drive ready, drive faulty. We do have also, where is it? Here, dip switches built in, and in the Siemens application in Toledo and in Sterling Heights, where we use this drive in the VersaLift application, we need those dip switches to set the CAN bus communication address. Because in the VersaLift application, you probably know there is the leader who generates a position and speed profile, and then there is a follower, and pretty much his job is to follow the leader, and he gets the set points not through the PLC, not through the internet, Ethernet. He gets it from the leader through the CAN bus. The CAN bus here is this plug, and normally the drives are next to each other in the panel, and there is a short bridge from here to there. And yep, to set the communication address, there are those dip switches. They are also in the drawings. If somebody replaces a drive, they also, that's one of the things I haven't addressed. When you replace the panel mounted drives, you should take a small screwdriver and set the dip switches. I think what I also did, I set the dip switch or the software address by software. So if somebody leaves it in factory default with 0, then you would go with a software set address. Yep. Yep. On the new application for Ford, where we use the 7.5 kW drive, where we use this one as a 7.5 kW version, we have here on this side, on the one side, the safe talk off input on the M12 connector, and we have also a CAN bus connector where we just use a plain device net cable and wire it from one drive to the next one. And the CAN bus termination resistor is built into the drive. You don't have to do anything there. You just have to, or we just have to wire it up, and then the address is set inside the software. Here, those dip switches, they do us nothing good. Any questions there, or any feedback from you guys in the field, or?
On the other one, the panel mounted one, you said that those dip switches set the CAN bus at.
Yes. Mm-hmm.
If that's being used for 552, for Ford, do they have any use at all, or it's
no? Here, the only way where we use the CAN bus at all is in the VersaLift application, and for Ford, we are using this one. Yes.
So those switches do nothing on like an MHL.
That's right. I mean, you still set the CAN bus address, but because there is nothing connected to it, you can set it to wherever you want. You know what I mean? It's sometimes I use the CAN bus on an MHL to do some more diagnostic, but besides that, you can set them wherever you want to. The CAN bus, sometimes it's a really nice and powerful tool to do, for example, long-term diagnostic. If you want to do, let's say, a 20-hour run and want to monitor the cycle time, there is a third-party diagnostic tool, CAN Bus Explorer, and with the right hardware, you can hook up your laptop to the drive, and you can use the CAN bus as like you use your laptop as a data logger, and for example log the cycle time. That's one of the reasons, or one of the applications where to use it for. We haven't talked really about this. In addition to the drive, I think I really haven't talked about it too much. Here, the incoming power is on the top. You have the 3 phases and the plus and minus UG coming in. Unfortunately, right now I don't have the plug here. I don't know, you have to kind of believe me and help me out here a little bit. But yeah, you have the 3 phases coming in, UV or L1, L2, L3. Sorry for that, L1, L2, L3. And then you have the plus and minus UG. Does everybody has an idea what plus and minus UG means or stands for? If not, I will explain it to you. If nobody says something, I explain it anyways. That is a connection for the internal DC bus. So the drive gets 3-phase AC coming in, 400 volts, 480 volts, and then it gets rectified. And then you will see here the DC bus voltage. In our application, what we normally see is 650, 660 volts at 480 volts incoming DC. So this is a really hot terminal, and the reason why it's there is you can daisy chain drives, and for example, if one is in a regen mode, you can use the other one for kind of sharing the load. We don't use it, but it is there. What we had, for example, in Toledo, one panel builder decided to wire the ground connection. No, instead of L1, L2, L3, they did it L1, L2, L3. After we turned on the panel, we needed 2 spare drives. Not a surprise. So, but that. What else do we have here? More important for you guys, we have here the motor connection, UVW. The motor connection, like the power connection, is pluggable. The only thing what is not pluggable and what you need to, where you need a screwdriver, is here and here, there, the ground connection. So if you replace the drive, and for some weird reason in our older drives, the 8200 drives, they had everything pluggable. Now with the new drives, the ground connection is a screw terminal. So somebody needs a larger Phillip, size 3 or something like that, to unscrew this one here, unscrew that one, pull out the ground connection, take off all the covers, and then you have your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 screws, and you can take out the drives. Here you can see it's a push-through variant. You can see here the seal that seals the backside, and also that drive has a built-in fan in the heatsink. It's possible that this fan gets stuck, and then you get a fan fault. So somebody has to look inside and see if there's a problem. What? No, up to now, no. We haven't got anything. What else do we have is here, those terminals are for landing the, normally the, like the shielding. If you have a motor cable coming in, you can basically put the motor cable here, have the shield terminated with a nice metal clamp, and to make it a little bit easier to install it, you can, there is one screw that you can loosen up, and then you can pull, okay, that was too loose, but you can pull that out normally, yep, like this, and then you put the screw back in. So you have here some room for your cables, and you can lens the cables here. I think in your case you barely use it because you have here other contactors inside the panel, but that is the intention. It comes like this, and then the idea is that the guy who's installed it loosen it up a little bit, pulls it out until it snaps in, and then tightens it up, and then he can land here the motor cable, for example. Yep. Here again, the yellow card is the indicates this drive comes with a safety option, and here you will have the safety inputs and the safety outputs. On the top of the drive, you have the digital inputs, digital outputs. We mainly use the digital inputs for limit switches and pretty much stuff like that. And here you have two feedback connections. You have the resolver feedback connection. In many cases, instead of using now an encoder, we use a resolver because there the resolver is just more immune against noise, and it also gives us the option here we land now the resolver, and here this 15-pin connector is our SSI Versacoder connection. So that's where you would hook up your SSI Versacoder. Again, that is all one part. The only modular thing would be the communication card, but normally in production you guys have one S number for everything. All right. The Profinet card has also a separate 24-volt supply terminal that we normally don't use. The idea is you can supply here the Profinet card with 24 volts, and then, for example, if you have to replace a drive, you can unscrew it, you can pull it out, then the Profinet card gets still supplied by the external 24 volt, and yes, you can replace the drive and your bus is still intact. But we don't use it. The drive is supplying the card with a 24 volt operation voltage, and if somebody has to replace the drive, there's a problem anyways with the machine, and if they have another Profinet problem, if you turn off the power, nobody really cares there. You have also here on this card, you have here a couple of LEDs for diagnostic that tells you the state, if the bus is connected, if it's talking, and you have here LEDs that show you if you're connected and talking, similar to the one I showed you on the ProTech. Again, a nice, a nice feature in your installations, because you have so many. You just look at the first 3 drives, how they work, and then if number 4 has a different pattern, I mean, then there's normally something wrong. Yes?
What do you expect to see on the keypad display?
On the keypad display, this one here? It kind of depends. Normally, I would see, when I plug it in, I would see the...
This is for the on the in-panel drives.
Yes.
The direct mount keypad.
Yes.
When we're running it, are you expecting to see anything there?
I think in factory, that's a good question. I think normally it shows you the actual RPM, like almost on a Versa lift, on a Versa drive, where you see the F number going through. You can see here the actual frequency. Yes, that's how the factory default is came up. The only problem is with the internal one that after a couple of minutes, that keypad has a background display that brightens it up like in an orange light and makes it kind of easy to read. But after 5 minutes or so, that light, if you don't do anything if you don't use the keypad, that background lighting disappears, and then it's really hard to see the LCD display, especially because that's normally a little bit mounted. You have the window here, yes, but you normally see there the actual motor frequency. All right. Whoa.
With regards to the ProTech or the in-panel drives. Communication, diagnostics, digital displays. Anything? Okay. VFD replacements again?
Yeah, we have this other slide. Where is that? Hold on. No, good point. Let me just see what Jonathan came up with.
I think the replacements are in separate.
Yes, I was just seeing if there's something more in that documentation that we maybe can use. And I think, let me just go through it. I already did it, but this presentation, that should be on the server, or that is something that you guys can have. On the panel-mounted drive, you have some you have a couple of LEDs. You will see it here. Basically, I try to show it when the drive was in my hand. Maybe now it's a little bit easier to see. You have on top the CAN bus, the built-in CAN bus that besides in the Versa lift, we don't use. You have here the drive ready, the drive error. Those are basically the important one. And then we have the user LED that I don't know if I ever programmed it for. My intention was to make it, if the brake is open or closed, to indicate that with the user LED. I don't think I have done it. I have to look into it. The problem is normally with the brake, once it's going, you hear it right away. But that thing here, we kind of went through this. Oh, you know what? That's a good point. Sorry for that. This one here, that is the Ethernet IP. That is Profinet, safety over Profinet. This drive, I mean, it's a prototype, but here the safety is a little bit different. You will have only 2 marks, because there we don't have Profinet over safety, or 1 or 2 that I think just the safety enable, if it's yellow flashing or yellow on, that comes now from the digital inputs. So what you have in 552 is slightly different, especially here in this area. But besides that, it's pretty much the same. Another thing that I learned through when we did the installation at Toledo was that the drive overall has 3 MAC addresses. The way it works is the drive by itself has 1 MAC address that you see here, and then each of the ports have another MAC address, Basically, the first port will have 84, and the next one will have 85. And the reason is that Siemens has a topology tool where you kind of can draw lines who is connected to who. And with that functionality, you basically need to know when you, for example, daisy chain a drive, that you go into the first port and go from the second port into somewhere else. So that's the reason why the drives have internally 3 MAC addresses. And I think the same is with Ethernet IP when I have to look it up, but I think that's the way I saw it. Yep, we went through that. Yeah, the fault codes. Again, F doesn't mean fault, it means frequency. Yeah, and now that is the engineer software, we don't need to be there. I think that's good. So the drive replacement. Let's do the panel drive first. If you want to replace here the drive in the panel, it's kind of hard to see. Okay. All right, so I mean, you turn the drive off, wait 3 minutes to have the DC bus discharge, depending what kind of connector you have. I think there's something wrong with the projector, because here on my laptop it looks pretty sharp, so I'm kind of sorry, but and then you have here on the top, you have the connection, and as I mentioned before, it starts with L1, L2, L3, and then the next 2 are normally not used. That is the DC bus connection, plus minus UG. You would pull that out. You can grab in, or if you have a larger, a really big screwdriver, I like to pop it up, so you don't have to sneak in with your hands there. Then the next step would be to unscrew here the ground connection in this area. Okay, you kill the communication or plug that out. You remove all the IOs. Here, that is a VersaLift drive. I can see it because we are using there the CAN bus. Those are the inputs. Here, that is a brake output, and that is a hyperphase encoder to the motor. You remove all that.
How many outputs?
Sorry?
How many inputs, outputs?
We have, I don't know, 7 inputs, 6 inputs, 6 or 7 inputs. We have, I think, I have to look it up, I think at least 6, maybe 7. We don't use all, and we don't need any outputs at all. The outputs are not used. There are. Yeah. Yeah, then here he disconnected the CAN bus, pull that out, get rid of, those. You know what, I'm sorry. Unplug, okay, sorry. Yep, I think everybody will kind of figure that out. Then you have here for the motor feedback connection, there are 2 screws. It's a little bit painful to go into this one, but you have to loosen it up, and when you put it back together, you have to tighten it up. So you take them off, and then the motor connection, you pull the motor out. Oh, sorry, at first he does the safety terminals, the ones that were not existing on my drive. You can see it here. That is the safety connector into this yellow card. You pull those out, and then you pull, here there's a motor connected, and here you can get an idea of the shielding I mentioned, and that is kind of a little bit poorly done with a tie wrap. You normally want to have there like a metal bracket. But anyways, he pulled that out, and then the last thing, or the next thing, would be the ground connection, and then you just have to get rid of the 10 screws. Yep, he does a ground connection on top. This one you can slide back in. Yep. And then, okay, you have here the screws. Get, yep, 10 screws. And then you just pull out the drive. Yep. Put the new drive in. I was a little bit too fast. Here you see a Versa lift. That's on top on the brick if you want to have a look there. You put the new drive in and then just go backwards, put everything together. And let's see if we have that also as a picture. Yeah, at the end, you take go to the old drive, you pull the memory module out of the old drive, put it into the new one, and then you're done. Okay. All right. So, any questions there, or, I mean, if the memory module is not damaged, it should be pretty straightforward. I mean, if you tell an electrician over the phone, turn it off and put the new one in and pull the memory module or the memory chip, I think that's how we should call it, from the old one into the new one. I mean, normally a skilled electrician should be able to do the job with
Start unplugging. It's that hard.
Yes, I mean, they should be able to do it without really big instructions, but I said should.
This panel drive replacement map with regards to network, whether it's Profinet or Ethernet IP, is there a difference?
No, I don't see there a difference. No, I mean the replacement is exactly the same.
Safety is
It's all discrete. It's yep, you just pop out the memory chip, put it in the new drive, slide. I don't know if it came with a communication card, then you just put in the connections for the communication card. If not, you have to pull out the communication card from the old drive, put it into the new one, and then you're good to go. We haven't really talked about this, but here you basically see the same informations I showed you before on that one picture. You see again on the drive. You have here the serial number, and here this large number that I showed you before that was broken down in 3 segments. It's all one large number, but that's it's exactly the same. Here, this number. This is a prototype, or not really a prototype. This is an original Lensa drive. So it has here a Lensa label. That is the one in the panel. Normally you don't see that. This one will has the one that you will see has a Comau label. But do we have there the S number on that label, or how we do this here? Yeah, there's a Comau ID number, yes. So basically, in this area here, instead of the Lensa type and the software revision, you have the Comau S number, and you can identify it there. You still have the Lensa ID number too. You still get this one. Yes. Yeah, those drives get manufactured in 2 locations. I think so, in Germany, in Hamelin, and a couple of years ago we had to open a second plant in France because a lot of big OEMs in Europe, they kind of demanded to have Lensa have another production facility in Europe just in case something happens to the one in Hamelin. You can run the same production in somewhere else. So we have now 2 production facilities who do the drives, and I just want to mention that sometimes you will see here made in Germany, and sometimes you will see made in France. That's, yeah. Oh.
For the after-sales folks, please keep in mind, I'm going to be repeating a lot of things over the next few days. For the Toledo and Shaft Siemens application, you have the VersaLift in-panel drive, which is the 7.5 kilowatt. You have the 11 kilowatt on the elevators and on the 2-column and the 4-column elevators. So keep that in mind because of the fact that in the Ford, you only have the elevator and tool tray. The tool tray is a 37 kilowatt. Because the VersaLift 7.5 is now this. This procedure that Matt went through on the drive replacement, I believe I gave a copy of that document to someone in after sales. I want to say Jeff Reed. Okay. Matt has another document for the VFD replacement for the ProTech. There is an actual document, thank you very much, Jonathan, and also a video for the ProTech replacement. We don't have a video on the in-panel replacement. So that document is what we have.
Do you have on the GSD SharePoint?
Pardon me?
Do you have it on the GSD SharePoint?
At this point, no, sir, I do not. But like I said, I believe I gave it to Jeff Reed. If he does not have them or does not recall getting those, let me know. Right now, we are using that as in more of a informal communication, only because of the fact that it hasn't been Kamau-ized with all the legal blah blahs on it. So it is not posted or published anywhere right now. Okay?
Yes. Yeah, if you want to replace the onboard drive, the drive package, this picture I think was taken in the blue room, but really doesn't matter. What you need there, you need a 5mm Allen wrench, you need a you need a Torx T25 and a small flathead screwdriver. And I mean, again, it's pretty straightforward. You start disconnecting all the cables. Here you can see the 2 Ethernet cables. In this case, we don't use anything special. We just use plain office IT cables. Normally, you have here like a little bit better push-pull connectors. Here you also have a good picture on it. Yep, the power connection got pulled off. In Toledo, we have here the 24-volt connection that you have to pull off. Then, I mean, again, it goes step by step. The brake resistor. Yep, then the Ethernet. I mean, the order really kind of, I would start with the main power and just go from there. And yep, then you have here the M12 connectors. You have one of the M12 connectors, the one kind of on the left side in the back. That is the Versacoder connection. And here's the one in the front. That is the motor encoder. Yep, you have to unplug both of them. And then there are a couple of screws on top. That is, by the way, the new design where you can see the hooks are kind of bended. When the ProTech comes kind of totally new out of the box, and it can come with those straight hooks. So I don't know I probably, when they order a plain Motec, just not the drive unit, just a plain Motec, sorry, Protec. When they just order a plain Protec, it probably comes with straight hooks, does it? So you have to, I don't know what the plan there is, you normally have to take those hooks from the old drive and put it into the new one.
Just mount a couple screws on the back.
Yes, yep, they're just, yep.
Oh yeah, you can see just a couple.
It looks like it talks too. I don't know if that's a 22, but maybe we have to adjust that. But
Depends
yep.
on how you order it. You order a pop-up, the brackets are right now.
Oh, okay.
You order like a 7.5, they are.
Okay.
Depends on what you order.
So.
Mark, Matt, can you repeat that?
Chris said when you order it as a pop-up drive, the brackets are already bent like this one here. And then, okay, I mean, in the worst case, if it comes differently, you have to take off the old one. If not, if it fits, it fits. But let's assume it just fits. So you have to take off here with the 5mm Allen wrench the top screws, 3 of them, and then you have here 3 on the bottom. By the way, we also redesigned the back plate a little bit. Now it looks a little bit differently, but in the end, it is the same procedure. I couldn't find it. I was looking for it, but I have to relook. Right now, I don't have it. Then you pop up here the cover, take out the memory module. Yep, and here it gives you the procedure for this T1 and T2. You have to press them in sequence, and you have to watch, you have to watch this safety acknowledge start blinking. When it goes out, you release T1, T2, then you have to wait until it starts blinking again, you press it, and so on. It is pretty straightforward. Or Everett, you're, okay, all right. Where's, can you close it? Just close it. There it is. Oh, perfect. Everett, you're laughing. Why is that?
Oh, did you guys get to the meet?
Once you've done it a couple times, you hear that first try.
We're going over this.
Oh, did it again.
We're going over the VFD replacement procedure fairly quickly. In the field, during commissioning, I don't have any problems, only because of the fact that we have ample support for you guys. After sales, it's critical that you understand the VFD replacement procedure. If you want to practice it, let me know. We have the blue room as well. But I can guarantee you, if I can do the changing, you can do the changing. Okay? You know, the only thing for me is, you know, I'm a wuss sometimes when it comes to the weight of the VFD, but it depends on if I had my readies in the morning or not, but it's a 10-minute change.
Are you going to put these documents together?
Yes. I'm keeping a track of everything we are going through. I actually still have the thumb drive from Sean. Tomorrow I'll have it ready for you.
Okay.
So as far as the after-sales guys are concerned,
Awesome.
these documents are specifically put together because of the fact that we've been asked by customers, and I know that the after-sales guys will need these documents. So I'm pretty sure we gave these copies to Jeffrey. Okay? But like I said, if you want to practice it, let me know. We can always.
Yes. Oh.
There's sound to this, Daisy, or no?
Can you stop it? Yep. By the way, that is now the new design where you see the brake resistor mounted right on the back plane. And we kind of, with the old design, because we ship this as one unit, we decided on the end of the drive, on the end of the motor, you have the encoder with the pigtail M12 coming out of the fan. And normally when you guys get a new drive unit, the encoder connection is not connected to the is not connected here to this terminal. The reason is, if we, on the old design, if we would put in here the encoder, then the M12 connector with the cable coming out would be really long. And then the problem could be if somebody takes a whole drive unit, puts it on the ground, it will rest on the cable and maybe damage the cable or damage the inside of the board. So therefore, we guys decided to ship it with the cable is kind of tie wrapped here somewhere to the drive, and then the guy who has to assemble it has to cut the tie wrap and put the encoder M12 connector in terminal X41. That works pretty good. I don't have a problem with that. The only problem is that we see now that drive in the field get replaced, or the whole drive unit gets pulled off the power roll bed, put on the ground, and in that moment it's possible that the encoder gets damaged because the people who handle it, they don't pay attention and they're not aware that when you pull off the whole drive unit that you're better off with taking this M12 connector off. That's something we see in Toledo. Shep is probably the same. The good thing is we normally don't have to swap drives a lot, but there were a couple of instances where they had the wrong, like a high-speed drive instead of a low-speed or vice versa. And then we kind of ended up with bad cables or damaged drives. The nice thing is with the new design, as you can see here, normally the brake resistor is a little bit deeper than the drive, and now the whole stuff rests on that side. So that also prevents it a little bit. But again, when you get the drive or when you get the drive unit, the motor encoder is disconnected and the guy who assembles this needs to put it together, and there is a reason for that. That's, by the way, the new design for 552.
Motor power cable. Ethernet cable.
Also, the 552 has M12 connectors for Ethernet.
Motor encoder cable.
That was the one I was talking about.
The first program.
It was a motor. Yes.
Encoder cable. Brake resistor cable. Wiring harness.
The Safe Talk Off variant for Ford, we are using there's a Protec in the variant 10 that has only here one input. So you can see here the version for Profinet has 3 additional safety inputs that we are safety contacts, safety connectors, let's call it this way, that we don't use, but those are available. The only difference are on the 7.5 kW drives for Ford, you would see here still 3 holes and 2 connectors, one for the safety and another one for the CAN bus to connect one drive to the next one to do the like the electric line shift.
Socket head fasteners.
That much space for the cylinder.
In case you haven't figured out, the superstar model is Jonathan Henley himself.
Never got paid for that yet.
I'm trying to figure out the monogram, that initials on there. Good job.
That's, by the way, also the 1.5 kW version. You can see here the heatsink is not as deep as the one here on the table. So that's a little bit a smaller version.
There's 2 screws in the bottom, there's 3.
Yes.
Don't lose it.
Faceplate.
Also, what Bill just mentioned, one difference between the 1.5 and the 4 kW is on the 1.5 you had only 2 screws here and 2 screws there. Here on this one you have 3. I mean, not a big deal, but just nice to know. That's a little bit bigger.
Socket head fasteners.
It's a screw. Oh, I don't know. We should edit that movie also and have a fast forward in between that. Screw, 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 and then that would be.
We're trying to provide the real-time replacement.
Like a Benny Hill type of thing, you know?
Yes, exactly.
If you had a nice design where we didn't have to unplug the cables
Wiring harness.
and you didn't need tools for the screws,
I know.
it would go a lot faster.
Yeah.
unplug everything.
Yep.
Allen Bradley, once you go start.
Rather go through this than right on the other.
I'm just saying, if I don't have to unplug the cables, I don't have to have screws.
I'd rather unplug cables than unwire cables.
I'm just asking for the moving stars, guys.
Why not try it? Yeah.
Brake resistor cable. Versicoder cable.
The best way is you start with that one because that's all the way in the end, and that's normally the thickest one. Then, yeah. I mean, that area is really cozy, so it's kind of hard to get it in, but.
Are those keyed differently or pinned differently?
Um,
You can't plug them into the.
those.
They're coded differently.
This one, the Versa coder, is an 8-pin connector, and the other 3 are 5-pin connectors, but they are pinned or coded the same way. So it's possible that you put in this one in one of the wrong spots. But then if you would run the power roll bit, it would give you an encoder fault. The question was those M12 connectors, if they are keyed differently or coded differently, and we have 4 different M12 connectors, and the one here in the back for the Versa coder, that is an 8-pin connector. All the other 3 are 5-pin connectors, and in the normal power roll bed application, we just need 1. In a pop-up application, we need 2. And you know what? Just by talking about it, I also realized that this video is a little bit older because now we also use sorry. Let me. Perfect. No, not really. For the brake resistor, here it's a mounting or it's an adapter for the connections. We also have now a temperature contact, an M12 connector that goes from here into one of those M12 connectors. So basically, when we basically we have now here we have the 4 connectors, 1, 2, 3, 4, and now we have here the Versa coder, we have here the motor encoder, and we have here the brake resistor thermal monitoring. I think that goes, you know what, I don't know. I think it goes to the last one, but I'm not sure. And on a pop-up, in addition to that, we also have the 2 limit switches for the upper position and lower position, and that is another M12 connector. So there's also the possibility that you change it or that you swap it, but then you probably get an overcycle or something like that. But yes. Also, you can see here the display. There's only one yellow LED that indicates the safety compared with ProfiSafe where we have 4. I think I mentioned that before, but besides that, it's pretty much the same.
Safety IO cable.
And Jonathan, that's the same one with on the power roll bed, or is there a difference, or?
Was there any difference, Chris, with that one?
Good.
Between the one I redid and the one, it's just, that one just mounted on the motor, that's really the only difference, right? Yeah.
Okay, then I think we can.
Fast forward to
Maybe one thing I want
the
to,
two, T1, T2.
that's what I just want to mention. We don't see it here. Because here we have a drive with one yellow spot and an external hardware safety. So here there are no safety parameters. So when you replace a drive, it's not necessary to marry the memory chip and the safety module together because there are no safety parameters. If it would be one of those drives, if it would be a Profinet version, then at the end of the replacement, when you power it back up, you need to do that T1, T2, basically push both buttons at the same time. There's a LED that goes on, then you have to press it. At that moment, the LED starts flashing. At the moment when the flashing stops, you have to take your fingers off. You have to wait until the LED comes on again. Then you have to press T1, T2 again. The LED is flashing for a few seconds, and then when the LED goes off, you take your fingers off, and then you're good. Normal.
You have to power down the 480 and power down the 24 volt.
Yes, you have to cycle the power, and
then you get a FOO instead of an SD3.
or SO or something like
SO
SO or user fault 5, depends.
USO, yeah.
Yes. But it's
I wanted to make sure that was clear for the after sales guys. The video, because of the Ethernet IP and safety, direct safety connection, we didn't do the T1, T2 simultaneous push. Where on the written procedure, because it follows the Profinet network, it tells you to do that to marry the safety address. And then on the cycling power portion, if I understand correctly, if we're not changing the IP address, there's not a need to cycle power, or we cycle power in both cases regardless, for Ethernet and Profinet when we replace the drive.
no, only when we do the T1, T2, you have to cycle power.
Okay.
After on ProfiSafe, after you marry it together, you need to cycle power, and both. It means 480, and I mean honestly, let's say it this way: if you replace this one in Toledo, for example, if you just connect the 480 volts, and then just turn it on with a circuit breaker, then you do your T1, T2, and then at the end you turn it back off, and so on. That's maybe easier than pulling the 24 volt plug in and out. But
Is that
that's, yes, I mean,
So basically what you're saying, when you hook everything up, don't hook the 24 volt up till after you do the T1, T2?
yes, I mean,
Then
that
just cycle the power switch.
you probably
and then
save,
hook 24 volts.
you save your 20 seconds putting it in and then putting it back out.
It's not gonna hurt it,
Yes.
but you can get the 24 volts with the 480 turned on, will supply 24 and the 24. So if you totally want to cycle power, you gotta disconnect the 24 and turn off the 480.
I mean,
Follow
it,
the procedure somewhere, right? You're gonna hand out?
Yeah, and that was why I was mentioning the video is going through the sequence of an Ethernet IP version, which is why it's missing the T1, T2. The written procedure goes through the Profinet, which identifies the T1, T2,
It has
and
built-in
cycling.
safety, that's why you have to do it, I believe.
Correct. And also the need for power, cycling power at the end. Okay?
yes. I mean,
Are there any other questions with what we went over today? We went over the organization review, the manufacturing locations, the contact information for Lenza. We went through the differences with the IP65 ProTech, the Highline in-panel mount. We went over the Harding connector versus the Molex connectors, Siemens versus Ethernet IP, the hardware that you need for communicating to the drive, whether it be from the laptop to the drive or the keypad. We went over synchronous versus chase. We went over part replacement. Any questions on any of that? Okay.
I want to mention something.
Okay.
But when you're done,
I'm
can.
done.
Okay. What I also want to point out is that we do have the two different drives, the 4 kW drive and the 1.5 kW drive. In the future, we also have the 7.5 kW drive, the bigger one. We have, you know what, I just hold it. On the drive package, you get it only in 1.5 and 4 kW. So, in addition to that, you have here the brake resistor. For the two different drive packages, or for the two different drives, you also need two different resistors. For 4 kW drive, you need a 47 ohm resistor, and for 1.5 kW drive, you need, I think it's a 180 ohm resistor. Just want to bring that up because the resistors from the outside, they look pretty much the same. I mean, there's almost the same physical size and so on. And I mean, normally there should be no need to, to mess around with it, because that is the one who is already there. But it's still nice to know. And for example, when you guys did the picture here, I think you kind of screwed it up a little bit, because here, because of the short feet in the background, I can tell this is a brake resistor for a high-speed drive, for a 4 kW drive with 47 ohms, and you mount a low-speed drive to it. There was something probably messed up, but anyways, just want to point out there are two different brake resistors who almost look the same. The easiest way to identify them is by the shape of the feet. The one has like 4 legs, the other one has just 3 legs, and also the legs are like independent. Here are those legs, it's like butterflied. This side goes straight through, the other one also. That is a 47 ohm resistor.
I don't know if that's true for these resistors.
Oh, you changed the supplier, or? Oh, okay. Why you don't tell that? I mean, it's.
But that's a very good Toledo, this is for the after sales guide. What you see in Toledo is only the drive and the motor, because the brake resistor is mounted directly to the frame.
But it's close.
It's close, and it's critical that if you change that brake resistor, make sure it's the right size, because it does look very similar.
So without the identification of the brake resistor, when I take it out, I will read what it is.
Nameplate. There's a nameplate.
Nameplate.
There is a nameplate on the brake resistor. Please make sure it's the right part number.
It's always mounted on the bottom so you can't see it. Is it?
Can you hear? It's, you heard. The nameplate, I'm just repeating for the video. The nameplate for the brake resistor is at the bottom.
Yep.
We don't have it here. One of the reasons why we modified it is, well, actually many reasons. One is because we were constantly having issues with the wrong size resistor, wrong location for the resistor, cable connection for the resistor. This is why we mounted it here directly, to avoid all those problems. Okay? You will only see this type of configuration in Ford right now, P552. This is now our standard configuration for mounting purposes. Now, what you see here is the brake resistors to the right. Depending on the application, it could be on the top. Or was it on the side? I can't remember. On the back. For the turntable?
I thought it was on the back, right, Chris?
Was it on the back on the?
For a turntable's on the back, it's mounted by the field because they actually run their straps, their hoisting straps rather than their back. So if you put it there, we just kind of rip it off.
So the brake resistor is on the plate on the motor, but the resistor location may change depending on the application.
Yep.
Okay?
Okay.
You think of anything else, Nish?
No.
Okay.
I don't know. Is there maybe questions?
Going around the table. Rich. Mike? Omar?
Nope. Nope.
Okay. Done for the day. Tomorrow, 8 o'clock, we're going to go over software, VFD.
Oh, wait, yeah.
Mike.
Okay, yeah, my name is Matt Rem. I'm from Lenzer, and today is the 27th of August, and that's our second day of the Lenzer VFD training. I think we can start now. Introduce you to David and Elma. Those are my colleagues. Elma is based out of Detroit. David is coming in here. And yeah, those are the technical support guys for the SHEP and the Ford 555 project. So if you guys have questions, you can call them. I put the cell phone numbers also on the contact sheet. We all three work for Jim Reinwald, the service manager. So he's normally the guy who's scheduling people. Okay. If there are any questions, again, say them loud. I have to repeat them, and then I will give my best to answer it. Also, there are a couple of new guys here. Maybe you can introduce yourself and just point out what you try to get out of this meeting, and then, or out of this training, and then we go from there. I think we start with Al. Oh, sorry. But
Al Bush, GSD Controls. What I expect to get out of this meeting is just maybe fill in some holes, since we've been pretty busy developing all the standard products over the last 2 years. And as much time as I've spent with Matt, we haven't taken a deep dive into the Lenza program.
Kevin McCann, GSD Controls. Same story as Al. Been working with Matt and Al over the past year, developing the Lenza solution for Versa Drive too. Again, Matt's been mostly instrumental in implementing the Lenza parameters. So we need to catch up a little bit, get a little more familiar with the Lenza end of the software application.
And who's next? Guess I don't know. You guys introduced yourself already?
Arthur Masijeski, GSD Controls. I'd like to learn more about the Lanza drive. So in the future, gonna help me with the debug. Thank you.
Right.
Bob Gordon, GSD Controls, basic understanding of the software program.
Right. I don't know. Did you introduce yourself yesterday or? No. Okay, so do it today.
Bahram Salihi, after sales group, and I will be taking care of all the equipments when they are commissioned, and basically I have to know all the details.
Okay.
I'm Amar Baroda, field service. I'm here for your assistance at the P552 and the shaft antenna and so on. The number is up there on the board.
Yep.
I'm David Botts. I am, I guess, field service and training. So I'm here for training.
Yep, to learn as much as possible. Yep, that's good. Okay, then I think we start. Who is from? I think Mike is coming a little bit later. He left his cell phone, has to turn around. Is there anybody else coming from Trevor, or just you guys, or I mean Mike and you? Okay. So, okay, so we pretty much can start now. All right. When I came in the morning, or the last couple of days, I was thinking how to explain the drive programming the best way for you guys. I mean, I know you guys have all experience with PLCs. You have experience with different drive manufacturers like Allen Bradley, CT. I think in the past you used even Yaskawa. Depends how long you're on the job. So you have quite some experience. Every drive, every PLC is a little bit different. And I mean, on the one side, the whole idea from the Lanza or from that new Versa drive solution is that basically Lanza provided the programming. I did mainly the application together with Chris and some help from my friends in Germany. But on the other side, it really does not hurt when you guys get a kind of a deeper understanding about the program and also about how the drive is basically working. With working, I mean how you program the drive, because again, each drive is a little bit different. Some gives you a little bit more flexibility in this direction, others give you other flexibilities, and it's, I think in my opinion, nice to know how the drive internally works, to see what are basically, for example, the strengths, also the limitations, because then later on when you go through the program, I think it's also better, or you can understand why I did it this way and maybe not the way you probably would do it with a different drive. So therefore, yesterday I came up here with this one picture that I kind of modified a little bit. That is the software, or what's inside the drive. I mean, you probably all remember it from yesterday. We have the firmware that is preloaded inside the drive, and then we have the parameters that I can change, I can up and I can download those parameters. So what does it now mean with the firmware? One big part is that inside the drive we have a library of function blocks. I will show you that in a bit. And those function blocks are embedded into the firmware. And when I talk about drive programming, I'm kind of a little bit cheating, because I don't really program the drives like you maybe program the PLC. I'm more configuring the drive. That means I have here really a huge set of function blocks that I can use. Then I have my application, and then because of my kind of application knowledge that I gathered the last 13 years, I know how to basically take the application and take the function block that the drive offers me and make it work. That is kind of the success to to write the program. And to do that, with the internal function block library, you configure that, or you don't do anything here in this area. You do everything in the parameter area, and there you basically connect or you configure the function blocks who are inside the drive. Maybe you guys know, plenty of you know the CT drives. There I think it's a little bit different. You know what, let's go back a little bit. One thing means that when I download the program, I just have to download here the parameters. I, for example, have everything here, again, is already built into the drive, and I don't have to touch it anymore. So when I have now, let's say, a counter function block, or I want to count an event, I would normally use a function block to counting, a counter function block that is already built in. That means I doesn't have to declare that function block, I don't have to create an instance like you probably would do in the PLC. Then you have to compile that file and download it. Here I don't have to do it, it is all already built in, embedded. The only thing what I have to do is I have to tell that existing function block where it gets the signals from. I think that was maybe a little bit, or that was a lot in the morning, but did it make sense, or there is a question? Yes, Bob has a question.
The firmware, if at all possible, that it has to get upgraded, does it affect the parameters at all?
Yes, the question was if the firmware needs to get updated, does it affect the parameters? That's a good question, and normally the idea is when we upgrade the firmware, you can still use the older program. Let's try to explain it this way. Right now we use in Toledo for the elevators the version 12. The firmware version 12 in this drive here. Maybe in the future we will ship the firmware version 13. But then you still can take the parameters who are inside the memory chip. By the way, when I'm talking about those parameters, all those parameters are inside this memory chip. So when I get now a new drive with a new firmware, the idea is that it's backwards compatible. So if you have a version 13 drive with a new firmware, you still can run it with the old parameters from version 12. In addition to that, maybe it's a valid question, there are normally kind of two reasons for a firmware update. One reason is if we find here, for example, in the library or somewhere else a bug, then we have to fix it, and that means there is a firmware update. And another reason would be if we improve or enhance built-in functionality. For example, on the Protec for Toledo and for Sterling Heights, we were using the firmware 6.02, and then in 552 we are using the firmware 7. And one big difference between 6 and 7 is that in 7, because of new UL regulations, we had to implement a new motor temperature monitoring model, like not a temperature contact, it's more an internal algorithm that monitors the motor temperature. That is now built into 7. That also means that you have to configure that motor temperature monitoring. You can turn it on, you can turn it off. In factory default, for example, if we implement something new, we normally always turn it off in factory default. So when you put it into an older system, it doesn't trip and creates a message that nobody knows because it wasn't implemented in the older version. So you need a code to activate it. You need a code, for example, to set the motor parameters and so on. Those codes are all here. But yeah, the functionality is built in here, and with the new firmware, you still can use the old parameters. Was that clear, or?
Lots of times in most of the AV drivers, a firmware also can affect parameters. That's why I asked.
Yes, okay. I mean, normally, I mean, really the goal is to have it like backwards compatible, because we know there are so many 100,000 drives out. I mean, and if you release new firmware, it should be capable to work with the old stuff. And sometimes there is just no way around it. For example, I mean, now we are kind of drifting off a little bit in Lenze history, but our old drive before this one here, our big successor was the 9300 servo drive. We are producing that drive since almost 20 years, and we still produce it. And during those 20 years, believe it or not, but a lot of internal components became kind of obsolete or kind of got replaced by something cheaper or better. That means we had to change the internal firmware to accommodate for that new hardware. But on the other side, we want to make it the same functionality to the user. So, again, are there any questions, or everybody understands the concept? I think there are two more people came in. Mike was here yesterday, so he doesn't have to introduce himself. But then we have somebody else here. Maybe he just says hello and what you maybe want to get out of this meeting. So let me.
Hi, my name is Milton Bodas. I'm just pretty much here to learn anything that I can, man. Anything new is good to me, man.
Okay, all right. Yeah, I'm the only one with the microphone, so I have to come a little bit closer. Okay. Yes, here what I also mentioned, you can up and download the parameters. Again, those parameters are inside the memory model. You can connect your laptop, you can read them, you can download them. The firmware, normally the customer cannot change it. You need like a special software tool and the diagnostic adapter to refresh the firmware. If you, sorry. If you want to look into the drive program a little bit deeper, we have, or I have here 3 different PowerPoint presentations: the service, the commissioning, the application, that I can share with you, maybe that you can go through. I can't go through those PowerPoint presentations today because each one with the exercises and all that stuff takes way, way longer. And on the other side, normally the game or the idea on those PowerPoint presentations is to have somebody trained to basically program a drive from scratch. In your case, you get a kind of a drive with a pre-programmed solution that I think mostly you just need to troubleshoot the interface between the drive and the PLC. But if you're interested in and you want to look into it, again, there are a couple of PowerPoint presentations that you can look at. We also have here, in addition to our hardware I showed yesterday, we have those mobile drives. That is a smaller version of an 8400 top-line drive that runs on 110 volts. And yes, you can hook it up to your laptop and maybe make some exercises, see how it works. This belongs to our rep, Chris Somerek. Many times it's upstairs in the GSD office or down in the blue room, and I think if somebody wants to borrow it for a week or two, that should be durable. We just have to coordinate that with Chris so we know where it ends up. So, so yesterday we were talking about the software that we use to basically change here those parameters to program the drive, and that is the L-Force Engineer software. I also explained yesterday that when we started in Toledo, we were starting there with 2.16, and normally every half a year, I mentioned that also yesterday, Lenze is releasing a new software revision. There are two big trade shows in Germany, the Hanover trade show in the springtime, and then the PLC trade show in the south of Germany, Nuremberg. That's always on the Thanksgiving weekend. It's like a punishment for our American people to go over there. Yep, but anyways, those two dates are kind of milestones, and it's possible that, for example, next Thanksgiving, we get a new software revision that normally includes some new functionality, bug fixes, new drives, and so on. That would be here. Right now, we are at 2.18, and then probably the next one will be 2.19. The software version, that stuff runs from Windows XP to Windows 7, and looks like also that 2.18 runs with Windows 8, but there are some limitations. And I can, for example, see that in the future they try to make it work with Windows 8. Yes. Another nice thing, what I recommend is that you, or I do a parallel installation of those software programs. Let me maybe arrange it a little bit better. So I can have all three together, 16, 17, 18, because the benefit is now when I use in Toledo 2.16, I can open it with all three versions, but every time I save it with one of those versions, I cannot open it with an earlier one. That means, for example, when L or Everett, when they have now 2.18, and we agree that we do the Ford project with 2.18, but then Germany is coming out with a new version with 2.19 that I would like to install and see what the differences are. Then when I would take the project file, open it with 2.19 and save it with 2.19, nobody can reopen it with a lower software version. We addressed that yesterday. I think it's pretty easy to understand, but the workaround is that I normally have all software versions parallel, and then I just have to pay attention that I save the project file with the right software version. In addition to that, there's also a benefit. For example, even in Toledo, when we agree to stay with, or let's say at Ford, where we agree to stay with software version 18, what we have right now, just as an idea. Then in the future, we will come out with software version 19. There's still a benefit to use or to do a parallel installation of version 19, because then it will update, the new version will also update the communication drivers for all other ones. So let's assume there is maybe something wrong in the in the PC to drive communication, and then with 19 that gets addressed. You just have to install version 19, and the communication drivers basically gets also used by all the other ones, and that should improve your stability with also version 18.
Sorry, Matt.
Yes?
I may have asked this question yesterday, but how do we know if I open one of the projects? How would I know that if it is revision 2.16, 2.17, or 2.18?
Yes. So the question was, when I open a project, how do I know with which version it was created or it was saved the last? Good question. Let me open here a project with 2.18. That is the latest and greatest. At first, I have to open Engineer. Takes a while. then unfortunately I probably have here only really large projects. Here, when you open Engineer, it shows you right away what Engineer version you have. In this case, it is 2.18 Service Pack 2. And then here you can, what do you want to do? You want to exist or you want to open an existing project? Yes. Then you can select here the path. And here in this case, it tells you last saved with Engineer 2.16. Also, what I want to show you is you can still open it with this one, not a big deal. Then it gives you here a message, more recent version of the, you can keep the old versions or select new catalogs. Let's say normally if I would go now with, if I would update the whole Toledo file with, let's say it this way. I think here it really doesn't matter, because normally it is more important when you have software that changes also here the firmware. We have another set of drives we don't use in this project. That is a 9400 panel mount variant or panel mount drive. That is similar to the CT drive, where you also basically have a full-blown PLC in the background and you have to download the PLC project into the drive. So you have like here a middle layer between the firmware and the parameters. You have here like a PLC project application layer, and then it's important to update. Then it's important here to select the new catalogs. In our case, I mean, we can do it, but we don't need to. It really doesn't matter. Yep. So again, right now I'm opening an older project with a newer version. I still can see here last saved with Engineer, so it gives you the message. Since that is what I call the master file, there are all the different applications with all the different version levels inside, so there are quite a lot of drives in. It takes quite a while.
I got a question right here, Matt.
Yes.
I saw that you can select the old or the new catalog.
Yes.
And does that mean when I select an old catalog and I save it with the 2.18, do I get a Engineer 2.16 version?
No, you don't.
It always saves it 2.18?
Yes, because now you get here this message. The data structure has got adapted into the 2.18 version. Yep, that's okay. And now, I don't want to go right now too deep. I mean, we can leave it the way it is, but now when I want to save this file, for example, I press here on the save icon. It gives me another warning. It tells me the project was saved in 2.16. Do you really want to save it now with 2.18? If you do that, you need 2.18 to reopen the project. So that is something that, for example, I don't want to do when I get, let's say, 2.19 out and all you guys have 2.18. At the moment when I save it with 2.19, then nobody from you can open it. And then everybody has to update it again. There's another question, yeah?
Are you on the website? Do you continue to supply the older software?
That is a good question, and I think on the main website we don't have the older version available. I know on the Lense intranet there is, I mean, that is the Lense website, that's for me available, and I have a copy of the installation files and the for the older versions. One of the problems with the older versions is, for example, that if you go really back in time, they don't support Windows 7, a 34-bit version. So, I mean, it's on the one side, we don't want to reinstall software on a daily basis. I mean, I understand it, but on the other side, it is nice to use something that is up to date. For example, Everett can probably confirm in version 16, when we were working on the elevators and doing some troubleshooting or diagnostic with the oscilloscope function, that was working pretty good. Everything was fine. But with the oscilloscope function in version 16, we had some I don't know how we want to call it, some hiccups when you saved oscilloscope file and you want to reopen it, and that got fixed with version 17 and also with 18. So even in Toledo, there was a benefit for us to use a higher version for example, using the oscilloscope. And I think the most important part is that you can have parallel installations. You will see that when you already have installed one program and you run, let's say you have installed 217 and you run the 218, then it gives you the question, do you want to update your existing engineer or you want to have a parallel installation? And personally, I recommend to have a parallel because then you can have both choices.
Matt, if you have 2.16 at Toledo, but you went online and somebody went online and downloaded the parameter set with a higher revision, 217 or 218.
Mm-hmm.
Would I still be able to go online with the drive with 216 and upload the parameter set again?
Yes.
And get back in shape?
Yep. The question was when I take my laptop and I download now the parameters with my laptop and version 218 into the memory chip, those parameters, is then somebody else capable to go online and read out the parameters with a lower version? And the answer is yes. Sure, you can go online, read out the parameters. The only limitation is that also if, in addition to, or how to explain it the best way, when we release a new firmware, or I don't want to do that. For example, if I want to create now, or inside the engineer program, there is a library of all our inverters. We have here the different types of or product lines, the 8400 baseline, 8400 baseline, 84 high line. Can you guys read that? Then the high line with the safety 100. We talked about it. That is basically this one here. I mean, technically those drives are pretty much exactly the same. The only difference is those drives have here the version 100 has the safe talk off option. What you also see now that the version here on the high line right now, engineer is offering you version 13. We have here, for example, the ProTech high line. There's the version 12. The ProTech is a little bit a different animal, but we can address that also. Also here is this checkmark display only the latest version. When you uncheck that, for example, then you get here a description for all the drives we were shipping the last couple of years. The 8400 Highline version 1, 2, 4, 5, 6, 10, and so on. This is now a part of Engineer 218. It will be possible that in the future, maybe 2 years down the road, there will be a firmware version 14 out that has improved functionality. I don't know, more function blocks or better function blocks or less bugs, you name it. Because here it is not embedded in this library, then the question is, can you update this library, or do you need to reinstall or run like a parallel installation from 219, 220, or whatever we are in the past? So your question was, your question regarding the software has one impact, that, for example, if somebody has a a really old, let's say, engineer to 16, and then you want to connect to a drive, for example, the Ford drive I was mentioning that has a software version 7. If you can connect to it, but I mentioned to you in software version 7 there is this new functionality for the motor monitoring regarding to UL, then you don't get access to it because engineer only knows the software revision 6, and in 6 it was not implemented. So there, the funny thing, it is there, but in engineer you don't see it. I know it's maybe a little bit confusing and I'm kind of drifting off here, but I mean, many times it really works. You can connect to an older drive, no problems. But sometimes you just, for example, you wouldn't get access to the improved or added codes or added functionality. And therefore, again, it is nice to try to be with the software up to date, even if you, for example, for this project, you don't need it. Because, yep.
So what he is saying basically, if you are able to read them, are you able to save it as well or not?
Yes, I mean, sure, you can, when you can read it from here to your computer, I mean, you can save it on your computer, you also can download it back to the computer.
Yeah,
yep.
basically when you are downloading back, you are downloading version 16.
I mean, you don't really download a version to the drive, you just download like plain parameters.
Yes.
So when you download something to the drive, it really doesn't matter what, the only difference is between the versions is that, let's say in version 18, we know there is this new code for the UL temperature monitoring that exists in version 18. And if you would use version 18, you would up and download that code.
No, what he asks is that if you go back with the version 16,
yes,
and read the one that it is version 18.
Yes, and that's what I was just going to explain. If you have a drive 18 that has that new code, let's call it the code 888,
right,
that is new for the UL temperature monitoring. If you use 216, you can connect to the drives, you can upload everything from here, but not 888, because 16 doesn't know it.
Right.
So you can upload it, you can also download it.
So when you're downloading back, that drive is going to be version 16, or is it going to be still version?
The drive is not version 16 or 18 or 20 or 15. The drive is always a firmware revision 7. Is that kind of clear, or?
My question was more, if somebody unintentionally downloaded a higher revision they opened up my parameter set from my 2.16.
Yes.
Then they inadvertently saved it at 2.18.
Yes.
And then downloaded to the parameter, which the firmware wasn't flashed. And my question was, with the differences with 2.16, can I go back online with the drive and just upload the parameter set again and get back into shape?
Yes, you can do that.
Yes, that's all I was
actually
asking.
Okay,
yeah.
But what you cannot do is if, for example, if I save it by accident with 218,
yes,
I give it back to you,
yep,
you won't be able to open it with 216.
No, but if I have the old parameter set, I can go online,
yep,
and I can upload.
And for example, if I did in the meantime a change with 218, I was changing the, I don't know, the decel ramp in the positioning profile. If you go back with your version and you upload whatever is in the parameters,
yes,
you're just fine. You can,
That was my question, yes.
Sorry for that. It is maybe a little bit confusing with the different software version on Engineer and the firmware versions, but on the other side, it's nice to kind of address it now. Not that maybe when you're in the field and you try to download something and it doesn't work, then at least you're sure that you do all the technical stuff the right way. You know what I mean? Bill is not here right now, but he mentioned to me that the Allen Bradley drives supposedly work in a similar way. You have built-in function blocks, built-in function block library. You just have to program. I don't know. Can you guys confirm that, or is it similar? Or
there's some of that for some of the if you use sit motion.
Okay.
You can use some of the built-in move controls. But as far as if you just use the Premiere integration that we've been using for Ford, mostly, it's very simple setup of forward, reverse, speed.
Okay. You do everything in the PLC, and you just
Just give a command.
Yep. Okay.
But if you change it to the sit motion, then it's far more intuitive,
Mhm.
a little more intense to
But-
once you get in and out of the drive.
But I know, or my impression was on the CT drive, it's a little bit different. You don't have like a built-in function block library that you can use. It's more like a full-blown PLC that you have, where you can basically create more and more function blocks. That also changes the execution time of your whole program. And then you have to download the whole. On the CT drive, the impression I got, you download two parts. You download the program, like the PLC program, and you also download the parameters to the drive. And here what I wanted to point out, that kind of what you have in the CT drive, here it is kind of already flashed in and you can't change it. And the only way to do the programming is by changing the parameters. I think that's the whole, that was my main intention to explain how the drive works. And good, all right, everybody is still awake and nodding with their head. So, since we're already here, I want to show you a little bit that function block editor. By the way, that is when you start L-Force Engineer, we open here a project. You get on the left side the menu tree. In this case, it is what I call the master file with all different applications. I have here, for example, the high-speed power roll bed. We went here through a couple of different revisions. Right now, that's what we use in Toledo. I mentioned I have a couple of more improvements I want to try. I already put some in. For the project, we have for each line a file. Let's say for underbody framing, we have a file like this. Then for each station, there's a drive. You can be online through the Ethernet with all drives together at the same time. Or if you want, you can use your diagnostic interface and connect just to one drive. Let's select here the drive I want to program or I want to go into. Normally, when you click on this, automatically this application parameter tab becomes active, where you see like a broad overview what's going on in the drive. From there, here are a couple of tabs where you can navigate through it. And before we make the easy thing, I want to show you how it's really complicated. No, I want all those parameters here inside the drive. I mentioned it many times. You will find those parameters also when you go to, guess where, all parameters, and then into the parameter list. Here is a huge list. Right now it's in numerical order. It starts with code number 2 and it goes all the way down. There are gaps inside. It goes down to like 15,000. There are not 15,000 codes, but there are a couple of thousand codes. And all those codes are, basically many of them are to program the drive. There are some, since we're already here, there are some display codes. I use this one here right now, and it's probably hard to see on the screen, but this value here is grayed out. Those values here are grayed out, and those are display codes. That means the drive is telling me something that I can use for diagnostic. Here, those codes are highlighted or are white. Normally, when you're online with the drive, they have a yellow background, and that means you can change it. For example, here you have the option to change this code here, and you can change the response for monitoring the Profinet communication from no response, fault, quick stop, warning, and information. Just to refresh it again, what does it mean? It means that, for example, that is the code 13880. It means inside this firmware, we have a function that monitors the Profinet communication. Right now, that means I have to set up how many milliseconds I want to wait until I don't see a telegram and then I trip it, and then what is the reaction? Do I trip it? Do I do nothing? Do I do a quick stop? Or do I generate a warning or an information? The functionality, again, is built in. You guys, you don't have to care about it. The only thing what you have to care is you have two codes, and with those two codes you configure that monitoring function that is embedded here. So you can, for example, here you can say the reaction time. You can configure it to 20 milliseconds, and then here you can say if basically after 20 milliseconds the drive is not receiving a new Profinet telegram, I want to have the drive getting faulty with a CI fault. That's, for example, what we see in Toledo all the time when somebody goes to the PLC, downloads a new program into the PLC. During that time, the processor is not sending information over the Profinet, and then the drive, after 20 milliseconds, it's tripping with a CI fault. Again, you don't have to, in this case, you don't have to program it. It's already there. You just have to set the monitoring time and the response. I mean, and kind of straightforward, but I think that also, just by accident I came up with that, but it really shows you where the parameters, I mean, all that stuff, those two parameters, again, they're here on the memory module, but the source code, that's built in the drive into the firmware. Okay? All right. Yeah, then we have monitoring functions. We were talking about that yesterday, but okay, let me continue what I wanted to show you. Here we have all the different parameters that are inside the drive. And with those parameters, you can configure the whole drive. Everything gets done through this stuff here. Oh, besides the safety parameters. That is something we have to address a little bit later on. But the safety parameters and the ProTech, they are, as I mentioned before, they are outside this area here. The safety parameters, they reside in a special area where we need basically a standalone program that accesses the safety parameters. I think I should update that. When I say standalone program, it's really a standalone program, but it is embedded in Engineer. So if you use it, you won't see it. But in the background, there is a special algorithm that got approved by TOV because it's all safety related and so on. Yes. So now what I want you to show, or we started with a really I would almost say complicated stuff. All parameters, you have a broad overview of everything. One benefit of this is if I tell you, please go to code 13,880 and change it from 0 to 1, one way or the easiest way to find it, if you know nothing about the drive, you just go to all parameters, you go to the parameter list, and then you scroll down to the code I was just mentioning. Yep, there it is. Okay, agree? I mean, if you're, I don't know, in Tuscaloosa, I don't know, just make something up and we want to try something and I tell you, you know what, you guys get a CI fault, let's try to deactivate it, that would be the way. So you have to change it from 1 to 0. Without knowing anything about the drive, you just have to go online, all parameter list, scroll down, then you're there. Yes, that's one way. I mean, we know you can't really program the drive through the list. That would be a little bit punishing. So therefore, you also have all those codes separated in subcodes that makes the navigation a little bit easier. For example, if you want to see what's going on with the data coming from the PLC, one way would be to go here to the Profinet option. You click here on Profinet option, then you get another submenu. You get here subsets of, for example, yeah, just give it a try. Identification. It tells you here that's the Lancet type number of the Profinet card. In this case, built into the Protect drive. That is the software revision, the station name. Yesterday I mentioned that the drive has 3 MAC addresses. That is the main MAC address that is talking to the PLC, and that is the MAC address from the first port and the MAC address from the the second port. Here you see the Ethernet IP address. Also, guess what? When I click here inside, there is not a window popping up. I can't change it. So what does it mean? That is a read-only code. That means that is the active value what the drive is using, for example. If I change the code now, I can show you where. Or with this one, I can make sure what the drive is using right now. When I scroll down, it's not here. We will see that a little bit later. We will see, for example, Yep, let's do it step by step. For example, if I go to process data, the PLC is sending to the drive, and the drive is sending to the PLC 16 words. That's basically how we set up every Lancer drive. And here you see the values from the PLC, or in this case, when we say to the master, it means to the PLC, or when it says from the master, that means it comes from the PLC. And maybe here, word number 4, 1600. Kevin, what does it mean? Or Everett is paying good attention. Do you know 1600? Does it sound familiar, or what could that be? You got it. That is the RPM value. That is the PLC sending to the drive. So, for example, if you want to do troubleshooting, one way would be to, you send a value from your PLC, and now the next step would be to double check that the drive receives that value, and that would be here an option to use that. There's a question?
That's number 3's position?
Yes.
For the 552 drives, and they're not using Profinet, is it still going to be under Profinet options?
It's basically an Ethernet IP option, but it's still labeled like that. Yep. And so, for example, now we know that the display code for the speed value is 13 851 subcode 4, that was German, subcode 4. So one way would be, again, to go through all parameters, scroll all the way down, and then find that code. Another way would be to go to the Profinet option. In the case of 552, where we use Ethernet IP, it tells you here Ethernet IP option. Then you go to process data, and you go to all words from master, word number 4, and you see here your RPM. In the word above, you see the target position, and so on. So, but yes, here it's a little bit, the usability is a little bit better, but far away from what we normally need to really program the drive. And therefore, we have the function block editor. That is here, that is a different tab, the FB editor. When we click on this one, another nice thing is, even here with a limited screen, when I click on this icon here, then I enlarge the workspace, and I get a little bit more. I mean, I sacrifice this view and I sacrifice that, but I get it a little bit better. And now, when I scroll down a little bit, for example, here we have the LP_MCIN. That means that is a lens port, I think motion control input. This is basically, for the lens drive, the interface to this card here. For the drive internally, for the program or for the parameters, it really doesn't matter where it gets the information or what you stick in here. If you stick in Profinet or stick in Ethernet IP, or if you stick in DeviceNet or Profibus, it always ends up at this function block, and then I can connect it or I can use it in my application. And what I want to show you now would be where we find this one value again. Scroll down a little bit, but here we have the word number 4, W, it's a word, input number 4. In input, in this case, it is from the point of the drive, because I'm kind of drive-based, and for me it's an input. For you guys, for the PLC guys, it's an output. But here, yes, I get now the move speed in RPM, and if I would be online right now, I would see here also the 1600 RP or 1600 value that the PLC is sending. And I just want to one more thing before I have a small break. What yesterday we pointed out that there are two different versions of Engineer, of the program LForce Engineer. If you go to the Lensa webpage, there is one download package, the version 2.18 that you can download. And when you click on the file to install it, it pops up with a window. If you go with the full version, with the high-level version, you need to enter the PIN number. If you don't have the PIN number, you can install the state-level version. And there are two main differences. And one main difference is that in the state-level version, that, for example, Mike, you can install, you don't see the function block editor. I mean, there has to be a separation. I mean, it kind of sucks a little bit. On the other side, if you go with the state level, and that was a part of this whole exercise, you still can do some decent diagnostic. You can see all the data coming in from the drive. And with my experience from Toledo, unfortunately, Andrew is now not here, but he set up all the drives in Sterling Heights. But I guess his experience was the same. I mean, 99% of all the trouble you have is like the PLC thinks it's sending something to the drive, but then it's not showing up in the drive. And that's a way to diagnose it. For example, we had a problem a long time ago in the turntable where somebody was sending the turntable was at 200, and when he pushed the button, he was still sending 200 as a target position. So the turntable was saying, yeah, I go to 200. But in his PLC program, he showed me a different value. He showed me 3000, but in the drive, here in that position, there was 200 coming up. So it's like, you know what, I mean, I can't do anything about that. If you send me 200 and I am at 200, I won't move an increment. So finally, he found that he overwrote the same hardware address somewhere else in his program with 200. And okay, after he fixed that, everything was done. So yeah, just to repeat a little bit, I wanted to explain how the drive has a function block library built into the firmware. We configure it or we program it through the parameters, and you have basically different views on the parameter. You can see everything in one shot through the code list, all parameters. It's also broken down into functionality based. If you want to set up the motor, or for example, if you want to find out what drive you have, you go to identification, standard device. Here it tells you the firmware revision. If you click on the power board section, it tells you it's a 4kW drive and so on. So it makes the navigation a little bit easier. But then basically normally the way to go would be the function block editor, where you see that all in a nice graphical user interface. But if you don't have it, you still can do some basic troubleshooting with all parameters and then this list. So now I think we have a small break, maybe 20 minutes, and we start again at 9:30.
Matt, maybe you want to mention the second downfall of the state level regarding multiple drives?
Yes, yeah, that's a good point. We noticed that yesterday also. You can only create your own projects up to 5 drives. But that, for example, an underbody framing line contains normally 40 or 60 drives. So if you want to create an underbody framing line by scratch, you can't use the state level. But what you can do, you can use the highline version or the high level version. You can create the project file with more than 5 drives, and then you can give it to Mike, and Mike can still use it with the low level, with the state level version. It just gives you a warning and says, oh, you have more than 5 drives. You're not capable of adding more and more and more. But I don't think that's something that, I don't know. I mean, that's, I think, the smallest problem we have to tackle in this whole project. Any more questions or? No? All right, then 20 minutes break, maybe. All right, I think we can continue. So breakfast break. So after you guys had a 20-minute break, did any new questions popped up or any more regarding?
Just to maybe go over the compare function when you get to it.
Okay. Mm-hmm. Yep. Let me just, a good point. All right, so we basically went from the parameters to the function block editor. We try to structure this whole program, the function block editor. You kind of have to picture it as one big page. If you click on this icon here, overview, or if you do somewhere a right click, you can get the overview. So you see here kind of if you want, you can call it the program inside the drive, but you also know it's not really a program, it's more configuration of already embedded functionality. And it's like one big sheet. To make it a little bit easier to navigate, we try to have like a color coding, or all the function blocks who work or accomplish one task. You PLC guys normally would put it into one rung, or maybe one or two. We try to put it in one area and surround it with a unique color to identify it a little bit easier. So the most important thing are the in and the outputs. You can move this this mark. You also can make it bigger, or you can make it smaller. Up. So maybe here. I mentioned that before. That is our lens support function block, LP. Don't ask me if it makes sense or not, but that's kind of, it tells you it's a port function block. So it describes something that is hard connected to the hardware. And let me zoom in here. You also can use those buttons, zoom in and zoom out. Maybe like that, 150%, or, yep.
Those are handy when you accidentally zoom it so big.
Yeah. Then basically all the different programs, we have the inputs here on the left side. Okay, it's kind of a little bit hard to see, but this area here, you will see that green mark. The green mark is now what you see here in the window. And you will see here, for example, that, I don't know, orange area. That is this area here where you have the inputs. And then here is basically the drive functionality for the power roll bed. And here on that side are the outputs. And that's where mainly your troubleshooting will end up. If you want to, for example, see, does a drive gets enabled or not? You look on bit 0, and then you see here drive gets enabled. There's also a remark when the PLC is sending me a 1 signal to enable the drive. For me, internally, I have to invert it because I need like a disabled signal, and therefore I invert it internally into the MCI function block, into this one here. There's some functionality even built into this one. And so you will always see the opposite. If the PLC is enabling the drive, you will see here a false, because that would, yep, and so on. Then if somebody presses a reset button, you hopefully see here a true signal. If not, you go to the guy who does the screens and complain with him, and so on. No, I'm just kidding, but here you get all the information. If you want to force one of those inputs, you can't really override it. It's almost like in your PLC. If you write on a variable cyclic, and yeah, you can't force that variable. But what's really handy, you can, at least the first 32 bits, you can invert the actual signal that comes from the PLC. What does that mean? It means that you can give the drive a run command, even if the drive doesn't get a run command from the PLC, because what you just need to do, you kind of just have to invert the drive forward command, because the PLC is now telling you 0. When you invert it, it becomes a true, and then it should go. Let me show that to you. Another thing with our function block editor, always in the upper right corner, you have 2 or 3 icons, and one of the icons is our help file. If you click on that, you get a pretty good description about that function block, what's going on there. Did I click on it? Now I clicked on it.
The help file, does that reside
correlate to?
No, this help file is a part of engineer. And we are, I just got some feedback from the guys in Germany that we are going to, for example, how to update help files and how to reinstall like improved help files. Oh, the question was, where does a help file stays, or where does it come from? And it's normally a part of engineer. And there is also, when you install engineer and you have an online connection, you have here, this icon not connected to Lensa server. I will probably, I can show it right now.
So the help is generic to the function block, not to the application.
That's right, yep. Yep. You know what, we do that a little bit later, but another good.
I wonder, is that phone active? Yep.
All right. Okay, I think there was another question, or the problem is I have to repeat it because of the taping and. Oh, okay, all right. Sorry. No, it's. Yeah, no, if you have a question, I was asked to repeat it and then address it for everybody so that everybody gets something out of it. But yeah, the help file is, it's not related to the application or inside the drive. It is just a generic one to this function block here.
Thank you.
So in this case, it opens here the description. It opens the description for the Lensa port MCI function block, and it basically shows you the internal configuration of this function block. And I hope, or not, that's probably all really confusing for you. Come on, say yes. Good, all right. But in the end, the idea is it is normally it's really easy to read. On the function block, you always have the inputs on the left side, you have the outputs on the right side. And here, even with this pretty simple function block, that is basically the interface to kind of this field bus card. Here's a field bus. So what we see for the drive, it doesn't matter if we stick in here Profinet, if we stick in here Profibus, if we stick in Ethernet IP, if we use Interbus or whatever. For the drive, for this part, it really doesn't matter. Somewhere else you have to configure, there are other options to configure Profinet or Profibus or Ethernet IP, but this function block does not give a damn what communication medium or so you're using, because it just goes right to the hardware and grabs there the up to 16 words and basically makes them available for the rest of the function block editor. What we also can see, and there is in the normal help files or in the presentations, we will see that quite often, or I have to address it anyways. You see here the outputs, and the outputs, they have different symbols. What does it mean? It means just by looking at that symbol here, you can get an idea what type of variable you're using. For example, if you see a square, that indicates it's a binary variable. This is just a bit. If you see here this black rectangle, that is a 16-bit signal. And if you scroll down or go down a little bit, I don't know if we can see it there on the screen. I probably have to move that a little bit. If not, I will show it later on somewhere else. You see here this triangle, solid solid dark triangle. That is, guess what? You have an idea, one word, you have another word, turns into a double word. So this one is a 32-bit signal. So now what we learned, just by looking at those symbols, you know if the internal signal is a bit, a word, or a double word. It also means that with a function block editor, where we connect the inputs and the outputs, you only can connect matching signals. So I can connect a bit to a bit, I can connect a word to a word, or a 16-bit to a 16-bit. I cannot connect a 32-bit to a 16. If I want to do something like that, there's a special function block that, for example, like this one here, that turns two 16-bit variables into one 32-bit variable. But it's not like you in your PLC, you have there a 16-bit variable, and if you address it wrong with a memory location, that you transfer it somewhere else. Here the idea is, and I think one of the beauties is that everything here inside this function block, even if it's just a stupid port function block, there's some functionality inside, and it is basically tested, pre-programmed, and you don't have to touch it. And you can rely on it that when Lenze gives it to us, that it's proven and working. In this case, there's not a lot of stuff built in, but overall, I think it helps really to do the application. So there's one I mentioned before. If we want to now do something with bit 3, bit 3 in general is our move forward or move to position command, and the PLC for some reason is not giving us bit 3. What can we do now? We have here this one option. We see this parameter. This is you can't probably read it because it's so small. That is 876 subcode 1. That is a display code. That means, for example, for Mike, if you don't have the function block editor, but you would like to know what values come in from your PLC, that is basically the same code as we went through that list, that 876 subcode 1, that is subcode 2, 3, and so on. And then here we have the option to invert those different 16 bits. Is it all clear? Yep.
If you have the state version, are you able to access this help file?
Yes. You just.
You can't see that.
You
can't see the actual function block, but you can access the help file.
Yes. What you do is, for example, if I mean now I have to, just give it a try. You know what? I mean, go to help. Say search LP MCI. I probably have to put in. That's not it. I have to do an underscore. No.
Is it number 3 state line?
No, it. Content. I mean, one way to navigate through it is, for example, if you just go to content, inverter, then we have, for example, the 8400 Highline. And now we want to go to the field bus interface. And then we're back at the same function block. So I'm pretty sure when you have the state line or the state level version of the program, you still have access to the help file. You just don't have access to the function block editor. The nice thing there with the function block editor is that it gives you here basically the direct link to that matching help file. And since you don't go there, you have to basically get that by hand. Up to now, I haven't inverted anything. That's a good point. That's the next part. I just wanted to show you that there is the option to invert here, can I zoom in? Yeah, that I can invert here the signal. And to do that, that is the next important part. I use here the right icon. That is parameter list. You can click on that. Then you get, again, here's the display codes. You can maybe increase it a little bit. Oh, perfect. You get the display codes from 876 subcode 1 to all the way to 16. And those are the values coming from the PLC. But they are grayed out. They are grayed out because those are display-only values. But here, there are values who are white. And here you can do something with it. You can basically, when you click inside, a new window pops up. And now you have 16 bits. In this case, we count from 0 to 15. And you can invert those bits if you want. And in our case, in this application, I always, when the PLC, whatever is sending me, I invert internally. Therefore, I have this bit here checked. If I want to do something else, I just check bit number 3. Another thing, if you are now online connected to the drive, when you change it here, right now it is only here. Then the next thing is you want to transmit it to the drive and make it active in the drive. There you have two options. When you press OK, at the moment you press OK, the state of those inputs gets basically transferred into the code on your program and also transferred into the drive. And the window gets closed.
So if the bit comes on from the PLC at this point, does it change or is it stay inverted to the value that we sent to the drive? So
Sorry, what?
All right, let's say a signal 0.
Yes,
you
and
inverted it to 1.
Yes, and
you send it to the drive.
Yes,
and
and
the PLC comes active. It
yes,
turns on the signal itself.
Yes, and
does it stay 1 or does it invert to 0?
It will go to 0. So the question was, when I check this mark here and the PLC is sending me 0, then basically the functionality is I invert that bit. I cannot force it. I think you were looking to force it bit to make it like true all the time.
No, I was just
or basically, okay. So it's not forcing the bit, it is just inverting it. When the PLC would send me a true signal, I would see a false signal. There is no built-in way to force it, it is just to invert. I'm sorry, I'm sorry, you have to slow down a little bit.
For this
yes.
specific application, you are simulating the input and then you want to see if the PLC function is working or not.
No, that's not the intention. We don't want to check the PLC function. In this case, the question was, do we want to check the PLC function? And the answer is, by this, you normally check the drive functionality. For example, you have a turntable, and the turntable gets a new target position to 3000, but for some reason it doesn't get a move to position command. There's something, maybe the PLC is not ready. And then instead of waiting for the PLC to get ready the move to position command, you can create your own move to position command. There are also other ways to do it, but that means you have to modify the program. Here you just have to basically toggle a bit, and then you can check the drive program, at least on this side here. But the next thing what I want to explain is what is the difference between accept and OK, because there are some misunderstanding worldwide. Basically, the main difference is when you press on this button or on this button, both times the changes you made get transferred into the program and also into the drive. So they will be active right away. The only difference is when you click on OK, the window closes. When you click on accept, the window stays open. Let me show you. I mean, right now we are not connected to the drive, but if I click here on accept, I can click on accept like 30,000 times, then my finger falls off, but the window is still open. If I click on OK, the window closes. That's the only difference. It also means if you want to just change a value, some people press accept and OK. It's not necessary. If you just press OK, it does both for you. It changes the value and it closes the window. But on the other side, sometimes you want to, for example, toggle several values, so you don't want to have the window close. You can turn that on or turn that off by using the accept button. Instead of closing it, reopen it. That's the whole purpose of it. In our case, I don't want to mess it up. I want to put it back to 0, press OK, and go out there.
Yeah.
Yes?
Is there any signal from the status or anything that we know that inverted has been optioned on that? Do we get a signal from the interface at all? So if someone goes in there and inverts some signals?
I would consider that free programming.
Yeah. No, there's no warning.
So there's nothing like a force active or something?
No, I mean, in that case, probably, I mean, it wouldn't work at all. And then the next question was how to troubleshoot it. You probably want to upload what you have in your drive, compare it with, let's say, the master file, and then it will come up here with it.
Safe torque off?
Oh no, you cannot invert safe torque off. No. I mean, it's, you know what? That's a valid question, and you know what? I have to rephrase it. The answer is on your system, on a panel, on a hardware safe torque off, you cannot invert safe torque off. What you could do on a ProTech, you can deactivate the Profi safety function. You know what I mean? It is like you almost would wire 24 volts permanently into the drive. I mean, so that's kind of how you can invert safe torque off. You just take 24 volts and wire it direct into the drive. But I mean, the safe torque off here on this drive, this yellow card, those inputs, they go right into the hardware. What they normally do is, I don't know how familiar you are with VFD drives, but yesterday we mentioned we have the 480 coming in, then the 480 gets rectified into a DC bus voltage, and then there is a IGBT. That's basically a high frequency switch that modulates the DC bus voltage to the motor. And that IGBT, that high frequency switch, is driven by optocouplers. That's basically the interface from the low voltage microcontroller to the high voltage power IGBT part. And then with the safe torque off, we kill, or one part is killing the power supply for the optocouplers. So even if the drive would like to, let's say, turn on the power, the transmission from here to there is kind of interrupted because there is no voltage there anymore for the optocouplers, and then you can't turn on the powers. So that goes right into the hardware logic, and I mean, you can enable the drives all day long with software, but if there is no hardware safe torque off signal there, then the drive won't run. On the ProTech, that's here, we have two options. At Ford 552, it's basically exactly the same as I just mentioned. We have a hardware input that goes right into the power board section, so there you're good. On the Profi, on the Siemens side, where we have Profinet, there basically it's possible to deactivate the safety settings through the safety parameters. Because there you have safety parameters and you can activate different functionalities, and if you would turn them off, then yes. That's the reason why the safety parameters are also like in a separate part of the program. They are not accessible from those parameters. You need a special, when you do a download, you have to confirm it by typing in a password. You also get a checksum from the safety parameters. So if you just change the safe torque off time from 100 millisecond to 101 millisecond, it will change the overall checksum, and you will see that there's something different, and so on. I mean, there's also, in addition to that, we also have that feedback in the PLC. If, for example, somebody presses an e-stop and you don't get a signal safe talk off back, then you know there's something wrong. And vice versa, if everything is clear and the drive is still sending you a signal safe talk off, then you get a safe talk off fault. You're looking really scared right now, but that's the impression I got from Toledo, where we get the safe talk off fault. So PLC is basically monitoring what it's sending to the drive and what it's getting back, and if there is a discrepancy, it runs or triggers a safe talk off fault. But your original question is the hardware safe talk off is not overridable with parameters.
Thank you.
You're welcome.
But if you go straight 24 volts.
Well, we have no interruptible power. So even if I get a discrepancy between the signals, the input and the output of safe torque, there's no, I have no means besides enunciating the fact that it's an unsafe condition.
So,
Not much else I can do with it.
all right. So just by looking at this one function block, this really boring one that is basically here for the communication from the PLC to the drive, we got a lot of information out of this function block. We found out how to access the help file, how to read it. We found out about the parameters. When you click on this one, you get only the parameters who are related to that function block. And even in the small port function block, there are some built in this case, to display the actual value coming in. I mean, honestly, you would also see that value here in Engineer if you're connected to it. You can invert some signals. And we also found out here that there is the signals, the variables, who have different types. You can see this here by the icons. That is a square. Let me scroll down a little bit, then it's maybe easier to see. Here, this one's a square. It tells you also in the description, it's a Boolean input 2, bit 12. But just by looking at this one, you can see it's a binary signal. And here, if you scroll down a little bit, this one is a word.
Does it highlight if it's on or off? 0 or 1? Is there any kind of
says true or false?
Yes, the question was, when you're connected to the drive, what feedback gives it to you? And yes, I think it says here in this area below it, it says you true or false. Also, for example, if you have the move speed in RPM, you will see here below the actual value, like 1600 RPM. You're welcome. What you also see is the input number 4 is now connected. In this case, it's connected to a signal switch. The input number 3, there you see those 3 dots. What does it mean? It means that input number 3 is connected to something more than one target location. So, and therefore, when you click on it and do a right click, you will see to where it is connected. In this case, it is connected to 2 other function blocks. Let me show you here. For example, this one is just connected to one function block. What you also could do, or what I could do, is I can replace that by doing a right click and say show as a line. And then I get a new line. For example, this line here. I don't know if you can see it. But I normally try to use only lines. I will show it if it's like one embedded functionality. I can talk about the slip fault monitoring. In this case, I would use, when one function block is next to each other, I like to use a line. If I have to go from here all the way to here, I don't really like to use a line because it will screw up everything kind of. This is a whole overview. I rather use then the flag. I click on it, show us a flag. And here is this function block for it, or this input, or that signal bit 3 is connected to 5 different function blocks. And a nice way to navigate it is just by clicking on it. If you click on it, brings you right to that function block, and then you see this is yellow highlighted, and yep, there you are. Is there a question or?
No, I just said very intuitive. Doesn't seem dirty.
No, I mean, believe it or not, Lenze, I mentioned this 9,300 drive that Lenze came out more than 20 years ago, and it basically had something similar in like that. And that was the only difference, or the main difference was, instead of having all function blocks on one screen, you only had one function block, and you had to navigate. If you click on an input, it brought you to the next function block. But I think for 20 years ago, I mean, that was in the late 80s. Was it in 1990 it was available? Yes, I mean, around that time, I think that was pretty awesome. I mean, everybody else, like our main competitors, there, Siemens, who did a servo drive they did all the programming by codes, you know, and you have, I mean, you can do all that stuff by codes, you know, because basically in the background there is one code that describes where this input gets the signal from. So there is one code, and there is a selection list of maybe 200 possible sources, and you have to set it now to MCI control bit 3. But by doing this, it is pretty straightforward. All right, if you want to go back, you just click on this and it brings you back. Yep. There is one, if we are already there, and what I show you now, I mean, normally I think you never have to go as deep into this as I'm going now. The only thing what I want to show you is that if you, for example, went from this one function block by double-clicking on the input, and if this one is now highlighted, does everybody see this now? This is now highlighted. You know what? Let me show it. I'm sorry. Let me show it with this one. It's easier to see. I will do this one here. Now what happens if I click on this function block, for example, now I want to add a new connection. Now, because that was already highlighted before, that means the connection from here to the digital delay function block gets unconnected. And that can be kind of dangerous while you do it in an online system. I mean, sometimes it's really beautiful. If I just want to basically disconnect this one from here and connect this one to here, it is pretty easy. I just have to move it to here and connect it. But if I don't want to do that, if I want to add here another signal, if I want to connect this one to, I don't know, to somewhere else, I have to make sure that this one is not highlighted. And even if it's always tricky. That's and if you do that in this case while it's live, we will probably lose the controller enable signal.
Is there any indicator on top where it would tell you that you highlighted another area?
I think what he's
Is there an indicator that says you're disconnected?
I mean, you will see it when it's disconnected. I mean, it's.
What you have to watch for, you think, because what you're asking is the lining up all of a sudden it gets disconnected. If you're in this editor, and especially if you got a touchpad mouse, you're moving around, all of a sudden, boom, you got a line attached to it. You're like, where did it come from? You're done. There's no undo. There's no go back.
Oh, that's a.
You changed it. Do you guys have the undo function in there yet? So if that happens, you need to go offline and re-download the program, I think, isn't it?
Yeah, you have. That's a good point. There is, unfortunately, in this graphical interface, there is no undo function. If you delete something, you deleted it. I mean, then one option would be to go back to the original file and start from there. Or the other good thing is, even if you delete something inside the drive, you have the memory chip where the program is stored. But now when you're talking to the drive, you're talking to the internal RAM. So if you screw up the drive by messing with the running program, you still can reload the program from the memory chip. Therefore, you have to go to all parameters. And basically in the parameter list, you have...
you can edit this online while like in a production environment?
Yes.
Can I download in a production environment?
No, because there are some of the codes that are here in the parameter. Again, the code list from code 1 to code 15,000. One of the codes, for example, if you have a positioning system and we want to change the motor mounting direction, or the question was, what can we do in a production environment? You can change parameters while the system is running, but there are a few parameters where the controller needs to be disabled to change them. For example, if you change the mounting direction, that is in our case, that would be the differentiation between a normal configuration and an alternate configuration on a power roll bed. If you would change that code, that only can get changed while the drive is disabled.
But I could delete one of these lines, one of these connections
online? Yes.
And to download to fix it, I can't do that while it's in a production.
Yes, I mean, what you can do, you can upload the parameter from the drive, or you just go here. Oops, sorry.
Is there an option anywhere to turn that off?
Don't go inside the functionality block.
Yeah, you know what? You can use,
no. I don't know if you've covered it yet, but you have the parameter listing where it's just, because
he doesn't.
Like Alan Bradley, where it says linked and everything. I mean, you can go through and say, I want to look at this enable, look at it, see where it's linked, and then go to the parameters, and it's a lot safer than using the function editor block. Because what you're talking about happening, I did on a cross transfer out here. And I didn't realize what was happening. It was happening so fast. I was disconnecting the line and then accepting it. It doesn't like confirm. It's like, and I'm just going on and I'm online. And I was like, shit started going to hell in a handbasket. So I ended up grabbing a mouse and using it instead of the touchpad. It's not that I got the best fingers in the world for it anyway.
But Sean, for you, it's even not an issue because you don't have the function block editor. You have the state level version, so.
In a weird way, I started off just a little bit ago
to like it.
My hands on this, and then now I'm thinking
No, I mean I never have a problem with this. I think it is important to tell it to you guys, but I don't know. I mean, I use those drives.
It's good information. I mean, it really is.
Yeah,
I have
for
to understand
first-time users, you want to be really careful.
I mean, it's a valid point, and I mean, I bothered with it all the time, and I accepted it, but I can ask is there a way to deactivate it or?
Yeah, that's really the.
Yep.
Maybe the benefit there is a checkbox somewhere that says, I don't want.
Because you want to go through it for trouble, like you showing, is it on, is it off? You're afraid while you're doing that, all of a sudden, yes, you can accidentally mess something up. But that's where I said too, they got the parameter list where you can look at it too, where it's, like I said, it's almost identical to an Alan Bradley to the T when you go into the parameter list file and everything. So you can go, this is like an added function on top of what the Alan Bradley is. This is something Alan Bradley doesn't have, but did you cover, can you show where the how they did you already do that? How to get to the parameters, so I mean,
Yes, we did that. We started with a parameter list that you see everything, and then we went from there to the submenus. For example, if you want to, where it's broken down into.
So right there, you can see if it's on or off, what the speeds are, what the counts are. Like I said, anybody, if you're familiar with Alan Bradley drives, you can actually, it's kind of nice, you got two ways of editing or looking at the lens. You can do it either way.
So, all right. So again, for the guys who have the function block editor, I think the most important part is really the lens support function block, the input here on the left side. That's where you get all the information. And if you're in the field, if you're in Sterling Heights, if you're in Ford, okay, let's do that first for the. But anyways, if you call Elmer, you call David, you call me, and for example, then you have a problem, we can start troubleshooting. And normally, what I would like you to do is maybe go to the function block editor and see do you get the right signals, and then we go from there. Or if, for example, then the next thing we haven't, that's on the to-do list, the application ID, for example, those are all the inputs. Here are the outputs. If you have a problem reading something from the PLC, you tell me, oh, I get a Versa roll application ID, but it's a power roll application ID. The first thing what you would do is you would go here to the outputs. Can you see that here on the screen? I probably have to scroll it up a little bit more. Here, bit 16 is always the application ID. Oh, sorry, word 16 gets mapped to the PLC. The idea is that each application has a unique 3-digit number, like 101, 102, 201. So we make sure that not by accident somebody takes a memory chip from, let's say, an elevator, 2-column elevator. There are no safety parameters, puts it into a 4-column elevator, maybe through the Siemens PLC changes communication settings, you can do that, but it still would not run because the application ID between 2-column and 4-column is different. In your function block, you double check it, and if you call out a 4-column, but it tells you, hey, I am a 2-column, then you get an invalid configuration and it's doing nothing at all. So you get here the application ID. We talked about the software revision yesterday. Yeah, you get a couple of words here, and that's basically what we use for troubleshooting. And then we can determine if, for example, you have the wrong application ID, do I send the wrong one here? Maybe by accident I downloaded the wrong file into that drive, or do I send the right one and something is messed up in the PLC. Maybe you access the wrong hardware address, and instead of reading the 2-column elevator, you read the power rollback information, something like that.
Is there a way to mute or mask a connection without actually deleting or disconnecting?
Not the only way. One way is on the input side to invert the signal, like we exercised it with bit 3, for example. Here on the output side, there is, let me see what options we have. I think we have the same. Yeah, we can invert. Again, when we look in the help file, it's basically the same as on the input side. We have here the first 16 inputs and the other 16 inputs. We can invert it. So on the first 32 bits, we have some online capabilities. On the rest, no. Then normally what you had to do is you have to disconnect it, for example, here from the input, and then we would send 0 or yes.
Both of your charts show the inputs only showed 3 doubles and the output shows one double. Is that true, or is it just not? Is the chart just not extended? Can you only take input word 2 and 3 and combine it to a double? Is there only the capability of making 3?
You mean this one here?
Yes. Is there only one double out?
Yes, there is. I mean, it's more internal stuff. When we have an internal, in the drive, an internal 32-bit variable, one way would be that I take that 32-bit variable. If I map it to here, then the drive automatically is using word 3 and word 4 and sending it to the PLC. If I need more, if I need another 32-bit variable mapped to the PLC, what I have to use then is I have to put another function block here up front to basically take to take a 32-bit value, split it into two 16-bit, and then map it to 4 and 5, for example. And you know what? There's even something similar. There is an example in our program where we do the slip fault value. For example, I mean, I kind of know where it is, the slip fault monitoring. It is in this area here. But here it tells me also where the slip fault gets generated. Again, if I just double click on it, sorry, that was the encoder fault. Just basically here, that is the logic for the slip fault. We were talking about that yesterday a little bit. Everybody has an idea about the slip fault. We compare basically, we have two speeds. We have the multi-encoder actual speed value. The multi-encoder is in our case the versacoder. And we have the actual frequency and digital input 1 and 2. That is this one here. That is a motor encoder. Then what I have to do is I have to rescale the encoder signal that comes into motor increments. I have to rescale it into versacoder counts. I do this with this function block here. Probably you ask yourself, what is that function block doing? Guess what? One way to find it out is by clicking on the help file. And that help file here, it's basically just a converter function block where you have a numerator and a denominator, and then you can enter the conversion method. In my case, when I click on it, now the next thing would be click on the parameters. I do here a conversion 40 by this number. And I hope, you know what, let's give it a try. I have to 3092. Perfect. This number, kind of that's close enough. But here I did a comment, a remark, kind of for me and the people who come after me and want to service this program. One versacoder count is equal to 773 point so many internal motor increments. That is just because our gearbox ratio and so on. So and this function block basically rescales it now from motor increments into versacoder counts.
Is there a way to store the program onto the memory card in a non-volatile area or something?
Okay, let's do it again. What was the question?
Right now you have the memory card that stores the parameters in the drive program.
Yes.
Is there any way to also store
the comments?
Comments and everything onto it?
No.
Even if it's in another area of it, not accessible through the drive?
Yeah, I know what you mean. In this drive, it's not possible. In our 9400 drive, what you have to do is, or what we do there, we download the whole project basically onto a way bigger memory card. And then you get all the comments, everything on that memory card. But here, again, in this case, and I'm sorry, but I like that picture, we just have here, we just really have here the plain couple of thousand parameters, and that's all this tiny memory can store. Who knows, in the future, I mean, memory gets cheaper and cheaper, and probably the next go around, it's like, okay. But then in addition to that, here we have also the beauty, it's doing it this way. Let's say you can have, you have the codes 1 to 1000 and they're all there. if you start putting like drive comments and something like that, you need a full-blown file system here, and it just it's a different animal. So, but on the other side, sure, I mean, it would be nice, and who knows what the future brings you, because this one, memory gets cheaper and cheaper, processing power gets also cheaper. So basically, hopefully in the next go around, basically the question was those comments reside with the project. That means if you have a new laptop and the engineer and you go to the drive, you can upload the program, you can see all those interconnections, but you don't see those nice comments that Andrew and I and Chris put in to make it a little bit easier to explain. But yep. Again, the slip fault, what I was just explaining to you guys is here we converted, so basically the scaling of those signals is the same. I don't know if you have a hard time to understand or to picture it. It's like when you have, I don't know, you're in your car and you get you have maybe two instruments. One gives you miles per hour, that other gives you in kilometers per hour. So with this one, I take the kilometer per hour and convert it into miles per hour. So both are now the same. Both are in miles per hour, okay? And then with this function block, even if we don't know what this one is doing, we figured out how to read it. We just click on the question mark, and here we have 3 inputs. In this case, it is it's an analog input, 16-bit, and the first input or the second input gets added to the first one, and then the third one gets subtracted from this. There's also an internal 15-bit limitation, and then it gets mapped to the output. So basically, go back. What we do now here is here I take the actual speed minus or I take the Versacoder speed minus the rescaled motor speed. Because the idea is when the motor spins, if I get the scaling right, if the motor makes 1 revolution, I want to see so much traveling on this side. And now what I do is I take this one into an integrator, and the integrator basically, it's almost like creating the average. It goes from, you all know it, when you take the speed is distance per time, and if you integrate the speed, what you get the distance. So if everybody followed me there? So basically if I travel with 20 miles per hour and I travel an hour, I traveled 20 miles. If I travel only half an hour, I travel 10 miles. And here the idea is that normally, even if now maybe the motor speed is kind of bouncing a little bit, the actual encoder speed is bouncing a little bit. So here the output is maybe a little bit positive, a little bit negative, a little bit positive, a little bit negative. I put that into an integrator. This one will calculate kind of the average value. So it doesn't trip right away. You have to, for example, if the actual position, if they move like that, it really doesn't matter. It really has to start moving and be like above a special window, and then it trips. And you know what? Why I even came up with this? Here we have another 16-bit input, and the output is a 32-bit position or 32-bit value. And Kevin's question was, like, here in this case, what we do, we take the 32-bit value, and this function block splits it into 16-bit values, and then the lower 16-bit, we bring it to the PLC. That's kind of how I came up with this example, because Kevin had a question. In that other function block, we only had one 32-bit output that we even don't really use. But here there is, for example, a function block that takes a 32-bit value and splits it into 16-bit. And I know that was pretty much a lot, but it also showed you, I think, a little bit about the capabilities of the program, how we did it, and the nice thing is, you guys, I mean, pretty much all of you, even if you would have the function block editor, you don't have to really deal with it, because suppose the intent is that this got all troubleshooted. I mean, it is in service, it works. So normally, if there's a problem, if there's a slip fault, there is not really the reason to question this one here. Then it's normally somewhere on the outside. The only kind of reason for a slip fault would be if we, for example, change the motor gear ratio, because then this equation here, the Versa coda counts per motor increment, will be different, and that means I have to readjust that converter function block.
So you have a set point in the integrator?
Yes, or the
Tell us where we exceed that average?
Yeah, the integrator is, I like those integrators, they're pretty mighty, because they have different functionalities. An integrator, you put in a speed, and then every millisecond, let's say you run 1 increment per millisecond. That's pretty easy to imagine. So this millisecond, at the end of the millisecond, it changes the output value from 0 to 1. And then at the next millisecond, it changes this from 1 to 0, from 1 to 2, then from 2 to 3, from 3 to 4, and so on. That is what this icon is showing you. The idea is you have here, this picture represents a constant input speed, and then the output changes like that. But then Al's question was that inside this function block, we can scroll down here, and it tells you here this load with level. Yep. Inside this function block, I also have a compare function. And now, if the internal value is greater, plus minus 164 Versa coda counts, then I set here the status bit. And with the status bit, I set the flip-flop, and the flip-flop sets the slip fault to the PLC.
Now, did you guys get that set up for the slip fault, because that's going to catch contaminated rollers?
Yep.
Right? So if you get contaminated rollers, you end up, because it goes to the PLC, can they go to the PLC and like change it or branch around to get by until they can clean them? Black it out.
I mean, I think,
the drive's not gonna,
yeah, I think
the drive won't block us out. You can go on the PLC and still get
this,
by
yes,
until the weekend or whatever, like we've done.
the slip fault, Bill's question was, or I think the intent is that this is just a message or a signal that's generated to the PLC. The drive doesn't care about it. I mean, the drive still operates, it just turns on the bit and tells the PLC that there is a slip fault. What then the PLC does is up to the PLC. Right. Normally it will stop the system, but if you think now the maintenance guy saying, hey, I can't clear it, so Kevin, what are you going to do? You are going to block the slip fault, yes.
That's what I'm saying, just because like we had there before,
yep.
Stuff, just to get by instead of shut production down.
But for example, on a, I mean,
you could go in here and double the value.
You can do that too. Yep, but I mean, but on the other side, that's something we normally don't want to promote. But I think Bill's main question was that when the drive is creating a slip fault, the drive does not react. It just runs as normal. And then the PLC has to shut it down. Yes. I think the only time when in the sync mode we had an impact on the slip fault that was taking inside the drive the clear to the next away, I think so. Yep. So there, in this case, when we go sync, then the slip fault has an influence. But what we have right now, it's all in the PLC. I mean, the feedback from Toledo and this logic is in the power roll bed. That's where it came up with. Then I put something similar into the elevators for for additional safety reasons. I mentioned yesterday we had the accident or the incident where somebody was releasing the brakes and then the motor shaft was not connected. So now the idea is, at first it won't happen again, but if it ever happens again, now, I mean, the drive is sending a signal to the PLC, and then the PLC could override the safety brake and kick it back in. And in Toledo, we also had just a couple of weeks ago, Everett and Karen were working on it, a turntable where the how you call it, the visor or the wiper. So the wiper was really close to the tracks, and at one position it was so close that it kind of got stuck, and that was on the side of the driving wheel. So it kind of, I think it lifted the wheel just a little bit enough to basically make this one trigger. And sure, then the plant complained all the time that they had a slip fault, but on the other side it pointed out that there was something wrong mechanically, and they had to readjust the visor, and then they fixed it. So again, I mean, I think the last hour was a small introduction into the function block editor, basically how to read the function block. In the upper right corner, you get the parameter values, you get a help file. The most important function blocks for you are the one on the left and on the right. Those are the one for the Profinet communication, those ones, and those ones. And maybe since I'm already here, I want to mention this one also, that number 3. I don't know if you can see it. That is the spot in our internal processing order. I think I mentioned that before, that the drive is operating in a 1 millisecond task. So, I mean, you know your PLC, Siemens OB1, that starts somewhere, and depending how much program you put in, it stops somewhere, and then it starts again. Alan Bradley does pretty much the same. On the other side, in Siemens, for the safety, you have, for example, OB35 that gets executed in a 100 millisecond task. Here, the drive internally runs in a 1 millisecond task. From this 1 millisecond, I think 600 microseconds, so a little bit more than the half, is available for all our application. And this number here is basically is showing you at what point of the task that function block gets executed. Let me bring that here a little bit, maybe back to our slip fault that we know already so good. If you can't read it, I will give you the numbers. This function block has a number 10, that has a number 14, that is 16, that is 11, that is 17, and 18 and 41 or something like that. You have an idea, or you probably all see the similarity to the PLC. That would be kind of the order, if you have different rungs in your PLC, which one gets executed first, and so on. And normally what you would like to have, you want to have like a constant signal flow. So that's the reason why I put this function block who is in the signal flow before this one. So this one is number 10 and this one is number 11. That means if something changes here, it gets basically executed at the same scan. So it just takes 1 millisecond. Sometimes I want to play a little bit and I want to have the, let's say, the last scan variable. Then I would swap the order of the function blocks. I would say this is number 10 and that is number 11. I do that in some places on purpose, and therefore for all the people who come kind of after me, I put in here a note that unfortunately you can't see because the screen is not do not change the order of the function blocks. That is more, I know my colleague in Italy, when he got the program, that's a long time ago, by accident he was messing around and then it wasn't working as it's supposed to be. I just have here that remark. But so now I think we covered pretty much the whole stuff for the function block editor. This number, the question mark for the online help, and the parameters, the inputs and the outputs. Some function blocks, they don't have any parameters, like a digital OR function block. I mean, there's really nothing you can configure there. Therefore, you just have those two icons. Then there are also the LS function blocks. They have a different color here. Those are system function blocks. They still get or executed in the 1 millisecond scan, but they normally get executed at the end or at the beginning of the scan, and they don't have a number. You don't have to, they get already or always called. That is basically a function block that describes the hardware interface to the drive and so on. But all right, I think that was a lot of information. I hope there was something useful.
I got a question.
You got a question. You shouldn't have a question. Okay.
You mentioned not to change the sequence of the function blocks.
Yes.
But you put it in a color label. So do you mean that applies only to the color label or in general?
In general. Mm-hmm. Yeah, that's, you know what, that's a good question because, yes, no, but yeah, that means in general, yep. But because everything there is kind of color coded, you can think it's only for that color, yep. All right, think we make another small break. Are there any other questions? I mean, all right, then.
I'm good with that.
You got too many rules here.
You got a form out on your plate. So you can't, no crinkling.
Waterproof tablet?
Oh, the chew is okay. It's just the bag.
Yeah, it's the cellophane.
Answer a call from work.
Mm-hmm. All right. Then I think we are ready for the next round. There was a question regarding the gearbox ratios, how we came up with that, where we get the information on, where we put it in. That's a nice point. Also, we are supposed to cover here the motor nameplate information and the feedback type. So maybe let's start there. Do you have, or in the past you were using an HTL encoder, something like that, but with 4 channels. You had an A and an A not channel, and you had a B and a B not channel. Now we have several different feedback systems. On the power roll bed, on the ProTech, we use this one here, single-ended A and B channel HTL encoder. That HTL means 24 volt, goes right into the digital inputs. Then on the elevators, the 2-column and the 4-column elevator, instead of an HTL encoder, we are using now a resolver. That has some advantages compared with, one idea was we do it the same way as here with a single-ended HTL encoder, but that would be a bad choice, especially on an elevator, because then if you would disconnect the cable, we just went through that exercise, we wouldn't see a fault until we start moving, and we don't want to have that on an elevator. So we couldn't go with this one. If we would go with the 4 channel HTL encoder, what we could do, but then we would use this input here, the 15-pin input for what we call the multi-encoder. And on the 4-column and 2-column elevator, we use this port for the versacoder. So that's kind of also not available. So therefore, we were using this input on the drive. That is the resolver input. And in the end, I think the resolver is also the better choice, because there the signal is normally less, or it's more resistant to electrical noise, because it's an analog signal. If you there have a noise peak on it, it is not as critical as you have here a peak on the encoder signal, a noise peak. The drive can read a peak as an additional count. On the analog signal, it is normally way better to handle that, because you get like a sine wave over 360 degrees. And does everybody know, when I talk about a resolver, what it is, how it works, or do you need there some more background information? Or okay, but a resolver is basically, let's see if I have something here in my manuals. If not, I would normally draw it on the paper, but man, where is it here? I just take one of the old ones.
Matt, you sent out an email. We do have a solid resolver connection diagram in our prints now. Is that's all been resolved? Right?
I don't know.
Oh, I thought you'd sent out.
I think with a 2-column and 4-column, yes, we do. On the other side, it also got changed. So that's basically. A resolver is, I think technically the best way to describe it would be a rotating transformer. Because what you have on a transformer, you have a primary and a secondary coil. You have here the same. You have, for example, here the one coil, the primary, and you have here the secondary coil. And one way to understand the functionality is you apply here a frequency and a voltage. And then on the other side, you kind of monitor what voltage you get out of it. And now the idea is when you, those two, those are kind of on the outside. They are not moving. The other coil, the third one, is mounted on the motor shaft. And now if you kind of try to imagine, if this one turns all the way up, then this coil and that coil, magnetically, they are pretty good coupled. And the you basically get here the most voltage amplitude out of that coupling ratio. And then when you start turning the motor shaft, here the voltage will drop on the one channel. On the other channel, it will increase. And that's basically the resolver. So
the reference coil is rotating itself?
The reference coil is rotating, and then you have a sine and a cosine coil. And there are two different ways to operate the resolver. The easiest way would be to apply here a frequency, in this case like 4 kilohertz, 10 volts, and monitor here the voltage that you get out. The frequency always stays the same. There's no, just to monitor the voltage. And I think that's what we do with an 8400 drive. But in in other drives, what you also can do, you can, for example, you apply here one frequency, 10 kilohertz, so many volts, and here you do like a phase shifting of the frequency that you always get here zero volts and basically no frequency. that in the past that gave you a little bit better, resolution or reaction time, but I think it's easier to understand when you apply here a frequency, you measure, or the drive internally monitors the amplitude on this channel and on that channel, and then it can determine the position of the rotor. And the nice thing, that's also one of the things why I like the resolver more, it is more robust than an encoder. I mean, you all know how an encoder works. That is basically a disc, a round disc, glass or plastic or something like that. There's a photo eye, and the disc has also black spots. And when the disc runs through the photo eye, it basically creates the signal here. So that means also the encoder is really doesn't like any kind of jerk or power coming in. If somebody takes a motor shaft and maybe slams on with a hammer, it's more likely to damage a resolver. Sorry, it's more likely to damage an encoder than a resolver, I think. Therefore, the resolver is mechanically more robust. It's also a little bit less expensive. That doesn't hurt. And yeah, we were using now the resolver on the elevators. And I think that's it. 2-column, 4-column elevators. Basically everywhere where we have this drive and a versacoder, there we use where we have a panel mounted drive, the tool tray, exactly. There we have a resolver on the motor and a versacoder for the absolute position. Okay, then in addition to that, on the VersaLift, that is now a new solution. In the past, we were using in Sterling Heights and in Toledo, we were using a panel-mounted drive with what we call a hyperphase absolute encoder. I think you pretty much use the same for the CT drives. That is an encoder that has also like not only one set of glass discs inside, it has several. They are coupled with a mechanical gearing, and there are several layers to pick it up, and then the encoder knows the actual rotor position over 4,096 internal motor revolutions. So the idea is when you can home the system, you know the position, then when you power it down and you power it back up, the encoder reads out the actual positions through that set of different kind of tiny built-in encoders and sends it over an RS485 to the drive. So the drive knows where the encoder is right now, and from there it just kind of counts up and counts down. That's a hyperphase encoder on the VersaLift. And for the 552 project, our guys, they decided to go away from the panel-mounted solution because that always takes up so much room and so on, and to do the VersaLift also with a ProTech. But therefore we need the bigger ProTech with 7.5 kW. That is the same drive as here, just with a heatsink on top. We really haven't figured out if we need the heatsink under full load. Sorry, not the heatsink, the fan. But in addition to that, also now this drive has different capabilities than this one here regarding the feedback system. So we have to come up with a really special feedback for the new VersaLift. Because on the one side, we need basically for the speed feedback, for closing the speed loop inside the drive, we still need this A and B channel signal here. That goes into the first input 41. And then on the other side, because it's a VersaLift, we also would like to know the absolute position from the VersaLift if we start up the power. And this drive does not have this hyperphase signal, what I just mentioned this drive has. So instead of using now the hyperphase here, we have to use basically the same SSI, that's a synchronous serial interface that we need for the Versa coder. You all know on a power roll bed we also have the encoder, the Versa coder, that talks to the drive. And now instead of using like a Versa coder with a strip, that is kind of built into a dual tandem encoder, and that encoder provides two signals. It provides this AB signal for the actual speed, and it provides that SSI signal for the position. The good thing is you guys normally don't have to sweat with that. That is all up to me. So I don't know if that's a good thing, but that's a good thing for you. So just want to point out the differences that we have there, different type of feedback systems in the field. And for example, also in Toledo, it's not even, yeah, in Toledo and Sterling Heights, it's nice to know that the two-column elevators between Comau and the two-column elevators, the third-party two-column elevators in KUKA, Utica, mechanically, they're exactly the same, or they're the same. They have the same motor, they have the same gearbox. The only difference is the Lenze two-column elevators, again, they have a resolver feedback system. And the KUKA, Utica elevators, they have an encoder feedback system. That's, for example, also nice to know for our own people who built the part. We had kind of the small problem when they built it next door. The first one for Sterling Heights, they just pulled the wrong motor and put, let's say, an Emerson motor on a Lenze elevator, and then were wondering why we always got encoder faults. But that's one thing. Yep. Are there any questions related to feedback systems or? No. I was just thinking about something else. Another thing. And we don't really see it here pretty good. That is even a bad example. I don't like it. Even if that is a total different drive, I mentioned it before, it is a 9300, but it is still, that's another bad example. Up. That's what I was going. I just heard Kevin saying the magical word shielding, and I would like to bring that up. Unfortunately, yeah, but unfortunately I don't have the perfect example here. But to make the long story short, Lenze as a supplier at first always recommends to use shielded motor cables, shielded feedback cables. You're supposed to, during the install, separate them in different cable trails and so on and so on. So that's kind of basic stuff. In addition to that, we recommend, our CE certification is for a CE approved system means that the motor shield and the feedback shield is connected on both sides to ground, or the ground on both sides of the shield needs to get connected. For example, here on the 9300 drive, there is again, that's not what you're dealing with, but you get an idea. That's maybe even good enough. You have there's a special piece of kind of sheet metal, almost like the one what I mentioned here that you can pull out. And that is, the idea is, for example, if you have a longer cable, you can open there the isolation of the shield, and then I call it the butterfly. You can wrap it around and give it a really good large surface contact. And with shielding and grounding, it really comes down to get as much surface as possible. The reason is that, for example, if you have a motor terminal box and you have a drain wire coming out of the motor cable, sure, you could have like a foot-long drain wire and connecting it to a ground screw. And if you then would take a fluke meter and measure the resistance, the impedance, what would you see? You would see, I mean, like almost 0 ohms, a really low impedance value. But for electrical noise, the DC resistance is not really the important part. It is more the overall inductance or the impedance at a higher frequency. And there, if you have a drain wire or a long wire, that kind of acts more, that has a really high impedance compared with a short wire or with a large surface connection. And then, a larger resistance means also at a higher frequency more voltage drop or more generation of voltage that can disturb your system. So basically grounding is one thing, but in addition to that, you normally want to aim for really a low impedance connection. And to get that, you would like to get as much surface as possible. I mean, that's what we recommend. How it later ends up in the integration side, it is something totally different, but I just want to bring it up. Also for example, if you look at the drive unit, if you maybe take one of those apart and you see that even that short pigtail motor cable that Lenze delivers to you guys, if you look into that shielding connection, that is kind of a really high-end connector. It is like what we normally do there is you take the motor cable, you kind of almost like here, you strip the isolation away that you have the motor shield, and then instead like cutting off the motor shield, what you do, you bend it. At first you put in like here the, how you call it, the screw, that later on screws the screws it into the compression coupling. So you put the screw in, then sometimes there's a special piece of rubber, you put that over, and then you bend the isolation backwards and move it back in, that this whole stuff gets connected with this terminal, how you call it, gland, or you know what I'm talking about? That would be a perfect applying the shield to ground, because it is a really short distance. It is connected with a large surface to ground. In addition, you still want to have the internal green-yellow cable running to the motor ground, but that would be perfect. But unfortunately, that does not happen all the time. And then in addition to to ground the shield from the motor cable on both sides, you would like to do the same for the encoder feedback or resolver feedback. You would like to ground that also on both sides. That means in the panel and on the motor side. And in addition, every time you have a terminal box, a junction box, you want to do it there the same. When you basically break the cable and you open everything, you want to make sure that electrically both sides of the shield are good connected to each other and good connected to ground. There's a question. Yes?
You said shield on both ends?
Yes.
Isn't that top bullet point say single-ended?
It's what?
Top bullet point on the board. Am I misreading that?
From this manual. It says single.
That's a good point. We only for analog, and no, that's for everything else but analog signals. And with analog, I don't mean a resolver cable. I mean like a 4 to 20 milliamp signal or a 0 to 10 volt signal. There, you're right. You want to have it also depends on the cable length. but you're better off to start with single grounded. I mean, it has to be shielded all the way through, but you want to ground it on one side. Everything else, and honestly, that's all what we're dealing with. The motor cable is not analog, it's digital. The communication cable is digital. The feedback cable, it's also high frequency. So everything else is connected to the shield on both sides to ground. There was another question.
My question goes back to the gear ratio.
To the what?
The gear ratio.
The gear ratio. Yes, we will. Yes. Yep.
And also, how do we do the homing sequence?
Okay.
If I have a Lenza Versa lift.
Yes.
How do we do the homing sequence and synchronization between two?
Yep. All right. We will do that in a bit. I was just thinking about the shielding. Think we addressed everything there. Okay.
There is one thing, and I think most of you are already aware of it. He went through what is a resolver, feedback, an encoder, and an absolute. Because of global design, for Ford, we do have a 120 hertz motor on the 4-column elevator. So I wanted to make sure you guys are aware of that. When Matt gets into it a little more, when he talks about gear ratios and all that other stuff, you just need to be aware of the motor, and that's getting into the motor nameplate, not necessarily the motor feedback situation. I think other than that, I can't think of anything else. Can you guys think of anything else motor-wise that we need to know?
You know what?
I can't think of anything.
Motor-wise, it'll come up in the nameplate. Talk about high efficiency motors.
We didn't talk about high efficiency.
No, but stop. Shut up. Quiet.
Yes, for maybe 4 years ago, our engineering or our design department in Germany came out with a new kind of motor design, and they call it the 120 hertz. And now guess what? MF motor. Yep. M in Germany means it indicates it's a motor, and M it's for frequency. So therefore we have an MH motor, that's a high efficiency motor. We have our standard MD motor. D it's also German, means for Drehstrom, so it's like an AC inductance motor. And the third one now is the MF 120 hertz motor. And when I heard that the first time, I said, besides that kind of stupid name, why do we call it, or why we did it? And a long time ago, I wrote something together that I try here to find. Man, I don't know where I put it. That's shit here, no. Because maybe somebody asked you why, and it's.
Matt, I forgot about the VersaLift encoder.
Yeah, I kind of mentioned that dual encoder. Yep. That. Come on.
What kind of switch are they using on the Ford VersaList for the photolyzer? Are they using, huh? Gate Ryan. I haven't actually seen it. What's the range on that switch?
Got it?
Yes, I got it.
2 feet only? Oh, beautiful. probably a whole funnel, a block.
Reflector is what Mason said, because it reflected the beam.
Oh, they would deflect it down. Oh, that makes sense.
But the problem is that reflector wasn't permanently mounted on a structure, it was floor mounted, and I'm assuming that's how it got lost, is somebody could actually on the ground.
The problem is right switch, right back.
All right. So I hope you can read it. I will explain it to you. But what are the reasons or the advantage of that new 120 Hertz MF motor, or how does it work at all? When I was in the first sales meetings, we were told that the new motor is way smaller than the old one, and I asked myself, why is that? And when I was looking into it, you can explain it with looking on a couple of equations. At first, the power of a motor, the power P, is basically the motor torque times the speed. That is a basic equation. And now the next one, the torque, is equal to the square of the diameter times the length of the motor. And therefore, right now I have not really a good example. Let's assume this is an old motor. The length, we really haven't changed. It is still the stack length, like this one. And now you have this diameter. What we did now, we kind of reduced this diameter a little bit. So the torque of the overall motor got a little bit less, because again, the diameter is smaller. But therefore, we kind of doubled the speed, and therefore that's kind of compensated for it, and we kind of get now the same power out of a smaller motor. You guys probably have seen that all in the past. And where have you seen that? You will see that if you supercharge a motor. What does it mean? It means you take a normal 60 Hertz motor or 50 Hertz motor, and instead of running it with 50 Hertz at 230 volt, you run it at 400 volts with 87 Hertz. And then our guys basically took that idea and moved it a little bit ahead. And instead of, they redesigned the whole motor and kind of designed it right away for 120 Hertz at 400 volts. And that's, when somebody asks you, why is it smaller? You can say, okay, because it spins faster. Still, sure, it's smaller, it has less torque, but because it spins faster, it compensates for it. That is basically the background. And okay, we get there some benefits. The first one is less cost. I mean, on a motor, you kind of pay it by the pound. All the metal, the iron, the copper, if it's smaller, I mean, it has to be less money. That's one thing. Another thing for dynamic applications is that now, since the motor is smaller, it has a less rotor internal inertia. So, I mean, you probably compare a couple of 100 pounds heavy sports car with a couple of 1,000 pounds heavy truck who is accelerating faster with the same engine, probably the sports car, because it is less inertia. Then there are even a couple, now since the motor runs with a higher speed, we need a higher gearbox ratio to compensate for it. For example, you still, in your application, you need 10 RPM on the output shaft. In the past, you had the motor spinning with 1800 RPM, and you needed a gearbox ratio for that. Now the motor spins twice as fast, but you still need the 10 RPM. So therefore, the gearbox ratio helps you also in some points. The gearbox ratio helps to compensate for the inertia mismatch. The inertia mismatch is inertia from the motor in relation to the inertia on the load. In a perfect world, you want to have a match from 1 to 1. You will never get there, but you want to maybe in an area from 20 to 1 or so, because that also tells you how good or how easy it is to control the load. because in the end, when the mismatch gets smaller and smaller, it is easier for the motor to tell the load what to do. If there is a huge inertia mismatch, let's say you have a winder coil so big and a really tiny motor, then the load is telling the motor what to do and not the motor the load. One thing with the inertia mismatch is that it goes into the square ratio. So that means if you change the inertia, if you have a gearbox ratio of 10, that gives you a ratio, the square of 10 is 100. Now we have to double the gearbox ratio, so we go to a 20, and then the 20, the square is 400. Now the reflected inertia gets back, or basically we have four times better ratio, because we went like from 100 to 400. Again, not really so important for you guys, but it's another advantage. Also, we normally can get away with a smaller brake, because let's look back on the load side where we need maybe a 10 Newton meter brake. And in the past, we had a 10-to-1 gearbox ratio. Sorry, we have a gearbox on the output side. For the load, we want to have 10 Newton meters. So we have a 10-to-1 gearbox ratio. That means here we have to put in a 1 Newton meter brake. Now, we still want to have for our application 10 Newton meters, but we have a 20-to-1 gearbox ratio. That means we can get away with a way smaller brake of half a Newton meter. In this case, it were really stupid numbers, but the bottom line is when you increase the gearbox ratio, you can reduce your brake size and still get the same at the output shaft. And again, a smaller brake means normally less money for you guys. So there are another of nice things that hopefully help us also with a 4-column elevator, that normally all the motors you guys used in the past, it really doesn't matter if it's SEW, if it's Lenze, if it's Flender, you name it. Those motors are designed for 400 volts 50 hertz or 480 volts 60 hertz. And they're designed to run across the mains. Those are standard IC inductance motors who are like 4 horsepower motor. You normally are supposed to hook it up to the mains and then it runs. The problem is if we have a VFD drive, there's, for example, a main choke built in. So you always have voltage drops in the main choke. You have voltage drops in or losses in your inverter. Not a lot, but it's all adding up. So what our guys in Germany did, they said, okay, now instead of designing a new motor for 120 hertz and 400 volt, we always automatically reduce also the rated voltage. Depends on the size. It's everything between 340 and 370 volts. That means now you don't kind of run into the problem that you have in your normal power supply chain voltage drops who are kind of normal and then have an impact on the motor quality. I mean on the torque quality. This one is a little bit hard to read, but basically the idea here is now, even with a normal 400 volt 50 hertz motor, the torque starts dropping. Even if the motor is rated for 1500 RPM, the torque starts always dropping. The peak torque, I'm talking now about the peak torque, it always starts dropping at a lower RPM. And with our motor, again, that is a peak torque. Forget about this one here. We have the peak torque basically available to kind of the rated speed of the motor to 3500 RPM. Why do I refer to the peak torque? Because our applications are pretty much always dynamic. Dynamic means we accelerate for 2 seconds, we maybe run for 2 seconds with a constant speed, then we decelerate, and then we do nothing. So in that application, we have to hit it really hard. There we need the peak torque, and then we have a break, and everything can kind of recover. So therefore, for us, the peak torque is really important, compared if you maybe have a conveyor belt system or a fan that runs day in, day out with, I don't know, 1800 RPM, and the load is not changing. Again, if somebody gets asked, why do we use that weird motor, at least now you know where to go to, and I can come up with some, facts and try to beat that guy up. But maybe you also took some information out of it, that there is some good reasons behind it to use that new MF 120 Hertz motor design.
How many leads is that motor? The 3 leads?
It's just a normal AC inductance motor. And it's, it's just a normal, it looks like a normal AC inductance motor, nothing special. It's a normal mechanical part. I mean, we just
Well, your motor that we're using for the 4 column, has it got 6 terminals on there or 3?
You mean with the terminal? I mean, it still has 6. I mean, it has 3 windings, so therefore it has 6 one. Yep. Mm-hmm.
So you still have a choice.
I don't know. I think you can't supercharge that motor, because right now it is. Yeah, and kind of it's already designed for running at that voltage, that frequency. You run it with 3,500 RPM, and you don't really want to run it faster, because then you probably would get in trouble with the bearings and the seals. And that is one thing that also get addressed here in that document. If somebody...
Hence my question about motor wiring.
The motor wiring, I have to look up. It should be... what is it? If it's a delta or Y. I don't even know. I know your question. Good point.
Only one diagram in there instead of both?
Yeah, I mean, that's what I think. Yes, I mean, I have a photo from the motor nameplate. I just have to find it. Before I did the presentation here, I cleaned up my laptop, and now I can't find the photo anymore. But okay, there are a couple of, if somebody want to argue with me or with you about the motor RPM, for example, since the motor now spins way faster, is there a problem with balancing the rotor shaft? And it's not. I mean, we balance that motor shaft at a high speed, and there are no problems. The MF motor uses special bearings that also perform or are for that high speed. Then normally the most critical part on a motor is the first seal on the motor shaft. In our typical start-stop application, the seal doesn't get really hot. It's not an issue. If you would have a large duty cycle, you want to consider the whole application, but that's something we don't have here. With large duty cycle, I mean, you would run the motor for 3,500 RPM for hours and hours and hours. That's not in our case. And the gearbox, you use the same gearbox as you use now, the same type, beside a different gearing. There, the gearbox is already approved for 3,500, 4,000, 4,500 RPM. So, and we already use it in other applications where instead of using an AC inductance motor, we use a servo motor. So there is no problems with the gearbox. So overall, the MF motor is really, in my opinion, the way to go in those type of applications. There are a lot of advantages, and okay, let's see how it works with the 4-column one.
How about the tool tray? Are we using that on the tool tray?
No, I think that was a standard motor. I don't know what the plans are. I mean,
Is that
no,
because of the load of the tool tray?
I don't know. I really don't know.
Well, what we have works.
Well, was it for the load of the 4-column elevator? Because we were right at the peak, right at the max of the.
Yeah, I mean, the 4-column was always a little bit on the weak side if you want to push it. So we had to retouch it anyways. And then we were, since we had to retouch it, I think our guy said, okay, give this MF motor a try. And I just wanted to come up with a couple of points that it really makes sense to use it in this application. Probably would use it also make sense to use it in a power roll bed and so on and so on. But I think, again, what we have right now, we spend so much time there. We should, build it a few times.
For a while?
Yes, build it and then maybe revisit it.
What transfer time on a roller would get the roller bed to do?
Yeah. 2 seconds.
Al?
Mhm.
Get on that.
Be amazed at what we can do now.
Mm.
Did it transfer yet? You want to see it again?
All right, here, Rich took a picture of the new 4-column elevator. Thank you, Rich. And here we also answer all our questions. That motor needs to get wired in a, how we call it, in a star configuration. Y, yep. And for example, in this case, that motor is rated for 360 volts at 120 hertz. Yep. When we set up, there was, okay, I was just addressing the gearbox question, but now.
While Matt is going through this, one of the things that I want to make sure everybody is aware of, this number here is actually Lenza's serial number, even though it doesn't say serial number on that. If you have any problems in the field and you need a new motor or whatever, especially if it's a manufacturer's defect, I will need this number along with the Kamau number. Okay? If you can do me that favor, I would appreciate that. He's going to answer your favor.
That S40 numbers are equivalent to our OS number?
Yeah, the TAL, that is referencing the old Kamau legacy dollar sign number. So it used to be $402079. During the SAP conversion, all those old legacy Kamau numbers started with TAL and maintained the old legacy number.
Oh, okay.
So when you, correct, so when you see the old numbers that we had, the 39088, blah, 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 that is, you should see that on the new nameplates.
So if we were to be working on a legacy system, Emerson solution or something, and we just have a part number there, all we'd have to do is tag TAL on it?
Yeah, there's another thing too, which is a shortcut for, this was something nice, because of SAP, TA are Kamau numbers generated by US. So all the TE numbers that you're seeing with the motors, that design, TE is Europe. That's where it was generated. It's kind of a nice.
All right. So how to read that motor nameplate, since we already have it here, it's probably worth to have a look. When we ship the motor nameplate, it doesn't matter where we assemble it. You get here like Southfield, Michigan, USA with a Kamau sign. So it is a 3-phase electric motor. The GKS, that is a Lancet type of gearbox. It's a right angle gearbox. 11, that is the physical lens size. We have like, every manufacturer does it a little bit different. Unfortunately, there's not really a system behind it, at least in this case. I think we try to come up with something more like related to the torque. but we start with a housing size of 3, 4, 5, 6, 7, 8, no, 7, 9, 11, and 14, I believe, something like this. This one, tells us the gearbox size. The next number tells us the number of stages inside the gearbox. Here we have the motor frame size. It is a 132 motor, and 22, that is the number of poles and the stack length. So to make the long story short, not really important for you guys, maybe more for me. What's nice to know is this number here, the 1322. What that means? Those are the numbers for the next 4 pick. When you want to play the lottery, you have to play those numbers. No, that's not the case. That is the production year and the production week. So that motor was built in 2013, the 22nd week. So you can get an idea just by looking at the motor when it was built. Here we have the, like the Lenze motor name again, MF and so on. It also spells out here that the motor has a fan, it has a brake, it has a resolver, the size and so on. Again, not really so important for you. Then one question was the gearbox ratio. Here you will see the physical gearbox ratio, 125.448. And if you would run the motor with 120 Hertz at a rated with a rated load, so the slip would be correct, then you would get so many RPMs on the output shaft. That is oil inside the gearbox. It's not the amount of oil, it is just the type of quality. In addition, that motor has a brake, a BFK 458. That is a type of brake with 16 Newton meters or size 16N. Sorry, that was wrong. It's a physical size 16. That is the voltage. It gets rectified 215 volts DC. 55 watts. And the brake has a rated torque or torque of 100 Newton meters. It also, the RS, it's an indicator that motor has a resolver feedback. Then here, there's only one way to wire the motor, no supercharging. You have to put in 360 volts at 120 Hertz. Because of that, there is no way, period, to run the motor across the mains. So if you want to see if the motor is working or not, you always need a VFD drive. If you hook up that motor right to the phase to the 480, you will burn up the motor. Okay?
Don't just bump in the motor
with 3 phases. Yes, don't do that.
You better tell Autotech in the build shops. Seriously.
Yeah.
Okay.
You better broadcast that.
Okay.
They're doing that right now.
Yeah, they do that all the time.
Open the drives.
Belts.
Huh?
Belts.
Yeah.
But not this one.
This is an elevator.
Yes.
Oh, from that point.
Yes. Yeah, but I mean, it's the good thing. It's just an elevator, so probably everybody is scared. But I mean, we had it that those motors came back to third-party repair houses. They were just, oh, let's hook it up, and then okay, we didn't know how it came in, but now we can tell it is really bad. So. Anyways, 360 volts at 120 Hertz. See the current here. I think that's pretty much it. Then
Where do we use that?
4-column elevator.
No, the gear ratio in the program.
In the program, yes.
Where do we put that value?
There are several spots where you normally use it, but the most important, or the first one where you would enter it is where do we have engine here? Did I close it? Yep, it's already running. Am I blind? it is. Let me just open the file and then show you. In the meantime, I want to prepare something here.
Gentleman in the green shirt.
I forgot.
That's why I moved over here.
Up, awesome. All right, I prepared that. Yeah, I want to open the file for the 4-column elevator, then I can show you the old motor, and I think I already prepared a file for the new 120 Hertz motor. I can show you where to enter the motor parameters and also where to enter the gearbox ratio, and just have to wait until the file is open. Okay, almost there. You can smell it. Yep, there we are. So we go to the 4-column elevator, and for example here I already have a new 4-column 120 Hertz variant, and basically the main way to enter it is here on the main screen. It's right on the main screen. It is a gearbox numerator and the gearbox denumerator. So that's the code 1202 subcode 1 and 1202 subcode 2. Nothing that you really have to memorize, but by looking at it, maybe you ask yourself, hey, what does those numbers mean? Because when you look on this one, it tells you it's a gearbox ratio from 125.448. So let's see what I came up there with when I get the pocket calculator here, and I do 26,344 divided 210. I come up with exactly that number here. And this number I came up with, it's basically the same one as here, but here we always round to the last 3 or to 3 digits after the decimal point. But
you guys over there 124, didn't you?
I what?
Over there you got 124.
Do I got 124? Then I did something wrong. No, 125,447.
Yes.
And that is 10448 because they rounded it up. What I did is, there is a list in the gearbox catalog or like a Word document with the different gearbox sizes. Yep. Sorry. And that is GK. Right now I don't find it, but there is a list with that tells you how many twos the gearbox has, and then I normally put in the number of twos here instead of the physical what is it value. You know what I mean? You also, that's one of the limits. You can't put in here a floating point number. It's only an integer number, so I can't put in 125 points. So I have to put in, let's say, 140,000 divided by 10,000 or something like that.
Yeah, but this way you went backward to get it that 124.44. If I have that 125.448,
You can type it in here right away.
How do I go back to this?
No, you don't. I mean, I don't know what you mean. You can type it. Let's say you have a gearbox ratio of 80. Just
No, let's say we have a gearbox ratio of 124.448.
okay,
How
120.
do you go back to that?
Yeah, if you want to go to, you have two options. You
need
can
to enter this value over here.
you have to enter a value here.
Right.
Yes, I mean at first you don't have to do it because I already did it for you. The only thing you maybe want to double check if somebody sends you a replacement motor who is right, you can check this gearbox ratio, check it with a motor nameplate. If that matches, you're good.
And if it is not good?
Then you order the right motor again. Yeah, but
Hold on. I'm trying to understand, sorry. I'm trying to understand where you're going.
What I'm going is that to go forward and backward, basically, between the nameplate that I have, and I want to enter to this, to that value in these parameters.
Why? Why do you want to do that?
Well, if you remember last time that Bill the Shutter, he had a problem with the gear one, the one that he got for the, I believe, for another application, and then the gearbox ratio, it was wrong, and he had to re-enter that.
So here's the problem that I have. Here's where I'm not following the question. We have a design with a specific motor, nameplate information, and a VFD sizing.
Right.
If you come along from after sales and you replace my motor with a different gear ratio, I'm going to ask you why.
Because I got a different motor?
No, wrong answer. You will not change the motor to a different gear ratio. This is why I don't understand the question.
No, the question is that right now, if I get that one, I need to know how to convert, at least I should be able to how to convert this one to go back to there.
Absolutely. My point is you will not be changing the gear ratio here because the motor will be the right gear ratio.
No, I agree on that.
So you should not be doing what
I
you're
understand, but that's for my own knowledge, that how do I go forward and backward for this?
Okay, when you need to do that, please give us a call. And
I
we
will do that for sure.
We will do that with you. Okay.
all right.
Is that clear? I want to make sure that's clear to everybody because the guys have tested this with everything we have, with the weights, the pitches, everything, the strokes. And I have a very big concern if somebody is putting in a different gear ratio than what we already have. So please communicate this to anybody in the field that if the gear ratio, if you happen to look at this gear ratio and you look at the motor gear ratio and it's different, something's wrong.
Absolutely.
Don't change the software. My point is, don't change the software, please. Okay.
I think I totally agree with that, but one, I think, really useful part of this exercise is how to check the gearbox ratio on your motor with the one on your application. That is, you will see here this number, 125.448. You will see this number here. There is a reason why I put it this way, because here I'm not losing increments. So you have to do the math. You have to do the 26,344 divided by 210. And then you get this number. You can compare this number with that number, and you know that's a perfect match. So that's, for example, when you guys do testing, or one of the reasons is in this way, when I put in the number of twos of the gearbox, I'm not losing resolution of the system. Honestly, when you look in this application, it really doesn't matter, because if we have a 4-column elevator, there is no way to accumulate an error. If I would go up and I would lose there or make an error, I would do the same on the way back in the other direction, so there would be no problem. On the other side, I like to do it this way. If you, for example, have a round table application and you would index it all the time 90 degrees, 90 degrees, 90 degrees, and then I would not type in this number, I would kind of type in this number. It is possible that after a day, the round table doesn't line up perfectly anymore. It is maybe a degree off. And after 2 days, it is 2 degrees off, and so on. So that's, and I started doing it like 13 years ago, and I still keep doing it that way. It kind of, another way would be to let's say, set in here the 140, what do we have, 125, let's do it 0.5, and then divide it by, for example, 10. That would give us now a gearbox ratio of 125.5. That's another way to type in a gearbox ratio. It's maybe, yep. So that's the gearbox ratio. The motor parameters, by the way, gets selected from in the motor tab. You click here on this, and then you have a motor catalog. I mean, again, you normally are not, you shouldn't be in the situation to do something like this, but that's the way how I did it. I go to the Lenze motor catalog, and then the nice thing here on our motor nameplate, we get this C86 number, and the C86 number for that motor is a value of 1597. What does it mean? In the past, our drives had a code 86, and there were all the motor parameters already embedded. Oh, you know what? Guess where? The motor parameters were embedded in the firmware. So that's not, that turned out to be a bad decision, because every time we came up with a new motor, we bought that motor facility in Italy. They had slightly different motor parameters and so on. In this case, we don't really want to update the firmware. So therefore, we came up with this motor catalog, but to basically make it the same, we still keep this C86 number in the Lenze language. In this case, again, the motor is a type 100 or 1596. I just type it in here, 1597, press on find, and then I get here, it's 32-22 18.5 kW motor. When I press here on complete, all the motor parameters, I don't know, inductance, RPM, everything gets automatically transferred to the drive. And there's also no need to auto-tune the drive, by the way. All those drives that you have, and more important on the power roll beds, we haven't done any auto-tuning. You just take the drive off the shelf, slam it on the power roll bed, and do your magic in your PLC, configure it like alternate configuration, Versa roll, and so on, whatever it needs to be done, and then, knock on wood, it's good to go. So.
It's going to grab all the motor data, but it won't have the gear ratio in there, right? Well, it won't have the gear ratio in there, though, right? You still have to manually put
yes, yep, because that, you mean,
just the motor.
That's just the motor, yes.
Just to make sure.
Yes.
What was the question?
Oh, sorry. The question was when I go back in here in this area where I select the motor through the motor catalog, and then when I type in the motor number from the Lenze nameplate, I get all the motor-related numbers, but I do not get the gear ratio. The gear ratio, that would be here in the separate area that I have to enter here, depending on the application. Because you can get the motor with a bazillion other gearboxes. Yep. Yes, I mean, again, I think it's nice to know where to find the gearbox, because it is possible that, who knows, maybe something got shipped wrong, or you want to make sure that what you have here is the same what you have in your program, and that is a way to do it. Who knows, maybe in 2 years down the road we have a MF power roll bed, then I have to modify also the gear ratio here for the high-speed and low-speed power roll beds. And then we have 2 programs, and we have to make sure that what you have is matching. Right. I mean, we were.
You had a presentation, Matt, yesterday that you didn't finish that had the I/O in it.
I think I showed that a little bit in the morning. We went through it.
That was the internal training.
Yes. Yep. We did that a little bit. I did the function block editor like as a free-flowing presentation, and at the end I showed those guys that we also, or basically they will find the same. They will find the same stuff that I did kind of on the fly without any.
Go towards the ends.
No, it's a little bit more up. No, it's not. Up. There it is. There. So we went through that. I mean, I haven't really used this presentation. At the end of my showing the function block editor, I think I showed you guys this one here, and I mentioned if you want to reread it, it's basically everything that I already mentioned, but it's here again in a.
That slide.
Yeah.
On that slide, when we were in Italy, you went through each of those points. Is there any questions on those, or anything you guys want to get into deeper? Did you talk about speed selects?
No, but I think since we're already here, what we just probably want to show is this one here. That's how I came up with this. I didn't make it up myself. We have here this Excel sheet for the different applications. Let's say power roll bed, where L came up with a cross-reference or with a list which bit has which functionality, also for what application. So basically this is like the reference, and I have to follow this reference inside the drive. And also here you find kind of a definition of that bit. I just call it motor running reverse or motor running forward. It really doesn't, in the drive, it doesn't get mentioned what is the level or how I do it. Here you get a little bit more information. And we try to come up, or L tried to come up with similar settings that cover like the same typical applications. That means here a power roll, a Versa roll, a cross transfer, a turntable. Those are all onboard solutions with a ProTech. And then, for example, here on a pop-up, we don't have an in-position bit, so therefore it is not available. The same with a cross transfer. That's kind of how to read it. Yep. Then, so basically this one is the source for, for this one. So basically if you want to know more about the brake override, normally you would like to go to the Excel reference, and there it's explained. And but the other nice thing is normally for the guys who have to integrate it, I mean, again, you don't really have to, I mean, on the one side the function block should be, there should be no need to touch the PLC function block anymore. It is, I think it's really more important if you want to do troubleshooting, that, for example, if you send a signal, drive moving forward. I don't know if you can read it here, you probably can't. Let's go to an elevator. It's easier to see. Here on an elevator we have way less inputs. We have drive enable, fault reset. We can select the high speed. Bit 3, move to position. the PLC is controlling the brake, and then we have the config init bit, and so on. And then you just compare, for example, here's a Versa coder target position, what your guys are sending from your PLC. Do you see the same coming here into the drive? And then from there you can decide your troubleshooting. Right. Since before the class started, Everett and Rich and we were talking a little bit about troubleshooting, about the oscilloscope function that is built into the panel-mounted drives, and the data logger that is built inside the panel-mounted drives and also inside the Protec, the drive unit. What are the differences there and how to use it? The data logger only has access to codes inside the drive. For example, here display codes, the actual motor current, DC bus voltage, and unfortunately the update interval is pretty slow and also really inconsistent. Even if it tells you 100 milliseconds, it's maybe something in this ballpark area, but it's not an equidistant time base. So normally what I would like to use is the oscilloscope function, where you also can use all the different variables in your from your drive. With variables, I mean you can go everything what you see here inside the function block editor, you can monitor with the oscilloscope function, and you can dial that down to a millisecond. That's the good news. Kind of the bad news is that on the 1.5 and 4 kW drives, we don't have the oscilloscope available. That is, I don't want to do it again, but guess what? It's not a part of the firmware. So that's kind of a little bit tricky now when you want to see if a signal is blipping or so. And many times that's what happened. If, for example, the move to position command is blipping, then on a power robot, we mentioned that before, we can get an encoder fault. So how to detect now a really high-speed event in your drive? There's a little bit, a trick. For example, you can just abuse one of the built-in function blocks. When you want to insert a function block, you can click here in the upper right corner, and again, supposedly, or you're not supposed to change the program or modify the program, but sometimes for diagnostic, it is just nice in this case, I would like to know if the move command or the enable command is blipping. So what I would do is I would add another function block. I click on this icon here, then my selection list pops up. Okay, and now I really don't do it, but that is all built in the firmware here. And there is, for example, we have 3 different counters, or 3 counters, or a counter with 3 instances. I think that's the right way to explain it. I insert that function block. Now it pops up in the upper left corner. I can move that a little bit where I would like it. All right. And then what I want to, for example, monitor is, let's say, the drive enable bit. Does it blip or not? So what I do is now I connect this input to the clock up input. I can also move that here. Up. All right. So now every time, because that is a clock up input, every time this signal changes from false to true, the output of the counter will change by 1. And then you can monitor it. Right now it's 20. And then if you turn around and it's 27, that means the enable bit blipped 7 times in between.
So how do you bring it into the oscilloscope?
The question was, when do I get?
How do you bring it to the oscilloscope?
I mean, if you want to use the oscilloscope, at first I have to be online to use the oscilloscope. Then you can select here, you click on it and you can select a variable. that you want to monitor. And
Basically, you select the counter up.
no, I mean, if you want to do the same with the oscilloscope, I wouldn't use the counter. When I would see when I want to monitor bit 3, I would monitor that variable right away.
You type it, you insert it.
Yes, I am not online. Let's see. I think it's the right time to get this one out here. Get that some exercise. Maybe you can hook me up there. The layout.
Is that where it's going to stay right there?
How much cable do you have? Can you put it more in the middle? How much cable you have? No, just tell me how much cable you have. I don't know how much cable you have. That was my question. Then you have to close the laptop. Can you see it? Can you see it? Oh, I'm always in the middle of.
Oh, I thought you were setting up.
I'm done.
Oh, I'm sorry. I thought you were
No.
still setting up.
Oh, I'm quick. I mean, it's all right. So we are using here our mobile 8400 demo to show a couple of things. One thing is, yep. So one thing is how to connect to a not existing drive in the project. This drive or this application doesn't exist in the project. It could be that you come up with an empty project like I do right now, and you want to hook up to an existing line machine. So what you do there, you say upload data from the system. You click on upload data from the system. You can give it a name, I don't know, customer, whatever. I don't really care about this. Here, where you would like to save it, go to there. Yep, I just overwrite whatever I have there. Then the next thing is you have to tell the computer how you want to communicate to the drive. With this drop-down menu, you have a few choices. In our case, I'm using the diagnostic adapter, so I basically, by accident, have already selected the right thing. In addition to that, I can use also the built-in CAN bus. Then I need a USB to CAN bus adapter for my computer, or I can use the Ethernet port and talk here to the Ethernet. LECOM, that is a really old protocol. That means Lensa communication. That's something we don't use anymore. We could piggyback over Profibus and so on, or in this case, we can also piggyback on Profinet or Ethernet IP. That would be normally the two choices you would go. If you have, let's say, an existing line and you just want to use the existing Ethernet infrastructure, you would select this one here. Or if you have the diagnostic adapter and you want to talk direct to the drive, you would use this one here. Then the next thing is, once you figured out how you want to talk to it, you press on Start Search. In this case, that's another nice thing when you have the diagnostic adapter. You don't need to know anything about the Profinet, the Ethernet IP. You just plug it in, press on the Start Search button, and then it comes up here with an 8400 top line. It has identified it. It has a Profinet plugged on top. All right, and then you just press on complete and see what happens next. Then it comes up with this screen, upload data or upload from device. Here kind of you have pretty much no option than pressing on the next button. And now look at that, it is uploading all the, and I can't help it, 8,000 parameters on this level here. So, and that it's it's uploading the parameter. So The other nice thing is the diagnostic interface is way quicker than over the Profinet or Ethernet IP, because there we use the transmission just takes longer. Also the transmission from here to the drive, it's yep.
Through this diagnostic, you will be able to see just one disk drive, not anything.
That's right. Yeah, it's like a point-to-point. When you're connected to this, you just see that. Okay, and now we're the first time after almost 2 days online to a drive. And do you see the difference? For example, here you see something yellow. That means you're connected to the drive, you're live. Also here you get an indicator. It's yellow. That tells you you're connected to it, and yep.
Driving a Jeep Grand Cherokee, park in this corner here.
Is it red?
What's that?
Is it red?
It's black. Nobody? Jeep Cherokee? Yeah.
There are a couple of people missing here. I mean, but. All right, so now that's how it looks like online. Let's do the 2 more exercises. The question, one thing I wanted to show is, for example, how to do troubleshooting. I don't know what's even inside this drive. That's probably something Jonathan was using. But I'm going to add that counter function block I just showed you. Yep, that's a counter function block. One way would be I, for example, can connect it here to the digital input 1. From the digital inputs, input 1, connect to the clock up input. And now I should have here digital input 1. I hope the first one is input 1. Yep. Now,
rotate that counter clockwise forward.
Oops, not good.
That's good. That's not.
So you maybe have to operate that input number 1 when I tell you. Okay, what I want to show you, or where you want to have a look, here input 1 right now is false, that input is false, and the output is 0. Now I want you to toggle it up one time, just up. Okay, now the output here is true, you see this output true, and here the value changes to 1. As easy as that. So, and that's, for example, now, let me just play with it a little bit. For example, if this one is bouncing, in this case, it bounced 6 times. If you have, even if the bit would, this one, if it would blip a millisecond, it would still catch it. So if you have an event from the PLC where, let's say, the enable bit through the PLC gets dropped for a PLC cycle, 20 milliseconds, it's really hard to pick it up here, because here the interval time is it's maybe a second, but this way you can catch it. Another way, if you don't believe me, but you do, let me insert another function block. We have here the system function blocks, what we call the pulse generator. Let me modify it a little bit. That's a function block that creates different pulses. It's like in the PLC. Hey Kevin, what was in the Siemens where you had the timer on your
time pulse?
What?
A time pulse?
Yes, something like that. Exactly. In this case, I just want to create a square wave, and I want to create a signal here that is maybe, what is it? It is, no, I want to do it half a second on and just 1 millisecond off. You can, you read that logic here. The pause part is just 1 millisecond. That means it's blipping for a little bit, and then it's on for half a second, and then it would blip again. Okay, so now when we look at this, here the signal is pretty much for us, it's true, true, true. There was a false, but we know there should be a false like twice a second. And now what I do is I connect it here to the clock up input, and you can see this one goes up like crazy now. So again, that's a nice troubleshooting trick. Sometimes, I think I mentioned that before, this built-in function block stuff inside the firmware has a lot of advantages, but on the other side, if you want to do like more trouble, or sometimes it's nice to have a little bit application background to figure out how to do your application or how to solve your problem. The problem here was how to monitor a blipping signal that blips for a millisecond even without the oscilloscope function. Normally, by looking at it, you wouldn't probably know that it's blipping. But by kind of using the counter, count up, you can even count a millisecond signal. So that is something for you guys that you will build some experience over time. The good thing is you normally don't really need it because the application is already tested and pre-programmed. Chris, me, and other guys. But on the other side, if you, for example, if you run into a situation where you would say, oh man, I would like to monitor that signal, but I don't see any way to do it, then just give one of us guys a call, and we probably come hopefully up with something simple, and we can say, hey, put this one in, then we go from there. And I mean, Al, you maybe remember we put something in for diagnostic just to see if it's blipping or not. That's a trick. Now we go to the oscilloscope, yes, because now we're online. The drive is now, for example, also what you want to do, I want to say drop this. I want to expand here the workplace to make it a little bit bigger. And then I click on this one, double click to insert a variable here. You want to click on this, and then you can insert up to 8 internal variables or 8 variables from the function block editor. Here are the variables, and the funny thing is it's almost the one I would like to see, not really. For example, when you click on this one here, you order it in numerical order. And for example, I would like to see the LS pulse generator. So I have to scroll down. There are a ton of variables inside, as you can see. And yep, there it is. LS pulse generator, we have the square wave. That is basically the same signal I'm using to trigger the counter. What I also want to do is I want to monitor the counter output value by itself. So that is just an L underscore counter. Let's see where that is. Counter 1. And then you can see there are 2 signals. There is a W out and there is an equal. In our case, we don't want to compare it with something. We don't want to have the Boolean. We want to have the unsigned integer. So I click it on here. So I selected my 2 variables I want to monitor. Then the next thing is I have to tell the drive how to trigger it. There are several options here in the trigger menu. Right now it is set to force trigger. That means if I click on this, it automatically starts triggering. That is one thing. Or if you want to change it, you can click on those on that button here, and then you get an option what you want to do. You can have 4 different events. You can do a force trigger. You can have a variable. A system event would be when the drive gets faulty or the drive gets into a warning or so. What I would normally do is with a channel, with one of those channels here. So, for example, now I use channel 1, the square wave. I can select here 1 or 2. In this case, I want to have channel number 1. And it's a digital signal. You can trigger it. In this case, it gets triggered when it's high. The only thing what you also can change is the edge, if you want to have a positive edge or the negative edge. I mean, in the end, it's nothing really rocket science. And then the delay, I mentioned that before, kind of a little bit long time ago. That is a pre-trigger. If you enter here a negative number, you will see what happened before that event. Sometimes, it's nice to know. For example, when you trigger on a fault event, you don't want to really see what happens after the fault. You would like to know what happened before the fault. So therefore, by putting in here a negative number, you capture 20% or 80% before the event. Then the next thing would be the sampling rate and the time-based. They are kind of related to each other. Right now, I can monitor the time base is from here to here. In this case, that would be 20 milliseconds. And then by times 100 or times 10 would be 200 milliseconds. Right now, the maximum time base with the internal memory would be 270.3 milliseconds times 10. That means the maximum recording duration is here just a little bit less than 3 seconds. In our case, I don't even want to wait so long. I set the time base maybe to, no, you know what? Let's do it like this. All right, and then we are ready. We start. Then normally it tells me, because this was a really short moment, normally it tells me basically waiting for trigger. And then when the trigger event occurs, the trigger event we specified here, then it tells us trigger detected. And in the end, when it kind of captures all the data, it tells us the oscilloscope is ready. And as you probably can see now, this is not a live online oscilloscope. It is like based inside the drive. It captures all the information there. And then when it gets it, you can upload it. It means the disadvantage is you can't really watch it from here and see what happens. So that means you always have to upload data. On the other side, if you want to, for example, trigger on a fault, you can set it up to trigger it on a fault. You can walk away, go to Subway, have a sub, have a Coke, come back and see, oh, it loads the oscilloscope, and now I want to load it. Then here we go. We get this diagram that kind of what you can do. You can click here on this automatic scaling, and then you will see this one here. Unfortunately, that was not what I was looking for. Let me just change here something in the function block editor a little bit. I don't really like that. Make it a little bit. Oscilloscope, and do it again.
Matt,
yes.
Based on what we have now, when would I use something like this?
Normally, for example, if when you guys have on the elevator, 2-column, 4-column elevator, when it does something really weird. We had the problem, it was going down and it stopped. Then we were monitoring, or I could determine that it was stopping because the PLC dropped the bit 3 and so on. I mean, we just verified that it was not the drive, it was coming from the PLC.
When I'm doing that, though, wouldn't I be looking in the PLC before I go into the PLC?
There's no histogram in Siemens.
That's
We use this to measure current too on arrays of all around the
Yep.
elevator.
That's, for example, another thing if you do the elevators when those guys do the product testing, because here you get a way better reading. Here you can go down to a millisecond sample rate with the data logger function. If you want to scope the current while raising and while lowering, here you can get a really good reading. With the other one, it is like, I don't know, it's like you're Oh, hot. You know, that's, but that's all you can say. I mean, you don't know what it is. And
you can get true cycle time too off.
yes.
As far as raising and lowering and watch the cycle time and current while you're doing it.
I mean, on the one side, I don't want to, you can spend here really days in it. I think I maybe just want to show that it's there. And I mean, you guys already used it, especially Everett and Rich. Yes, I just want to show it's there. Now the next thing is you can, I mean, it's basically a normal oscilloscope. You can zoom in here and
The
you.
reason I'm asking that is the function block that we have is set. The questions that we have, or some things that may affect us, is really the drivers to the function block. So for the integrators, when they're trying to determine where the fault may be, I'm comfortable that by the time we get to Ford, because of SHAP, the drive program will be more solid, right? So I guess where I'm going is, right now, we are going to repeat the troubleshooting of the interface, the PLC interface AOIs, to the drive. So if I'm trying to troubleshoot if the AOI, I'm validating that AOI, in other words. So if I'm trying to troubleshoot where the problem may be, it's the driver to the AOI and the interface to the VFD, right?
Yep.
So I'm trying to see what tools that you can show us that will help in that troubleshooting.
I mean, again, that is one of the tools. If you want to see if the bit 3 is blipping, then, I mean, that.
Well, and I'm just thinking out loud, because to Rich's point, the first thing is we need to determine if the product is functioning properly, in which case we know that the drive program is somewhat solid. So the mechanical issues within the product is what I'm troubleshooting. And then again there, the tools I would use are the voltages, the amperages, the cycle times, etc. Right?
Yes.
Frequencies and whatnot. And we showed those, we already looked into that, right? This morning, I'm assuming?
I mean, on the Allen Bradley side, I think it's a little bit different than the Siemens side, because on Allen Bradley you guys have better diagnostic or tracing capabilities in the PLC. So a lot of stuff, what I showed here, you also can do in the PLC. So, I mean, this.
I was thinking of just piecemealing because of the fact that for the guys that we have, we're trying to educate them and have them be better troubleshooters of the standard product. This is why we're in this training, right?
Okay.
So, regardless of the PLC type and the capability, the first thing we have to do is look at the product and determine if the product is functioning properly from the VFD on down.
Okay, yes.
Right.
Yep.
So, one of the things we were looking at is the slip faults, because it's comparing the two feedbacks. We talked about the type of encoders.
Yes.
We didn't necessarily, and I don't know that we have to, get into the P&F reader. As far as the I/O is concerned, do we need to talk about what's directly connected to the VFD versus the PLC for troubleshooting? I don't know, I'm thinking out loud to try and.
Well, we could use the oscilloscope to see if PLC's dropping the output 3 drive forward command or the brake release. Something we can't do with Siemens. We can't trend or histogram our signals there. So this would be.
I mean, this is where you go to see if you really turn the brake output on. Right. Or not.
Yeah, you'll be able to monitor your own 5x2.
But I think I think for everybody it should be, it's nice to know it's there, that the oscilloscope is there, but it's really the last line of defense. On the Siemens side, especially since there's nothing like that built into the PLC, on Rockwell it is even less important, since there you guys have more diagnostic function built into the PLC. But again, here it is nice to know it's there. I mean, like Rich and Al and Everett, they probably can use it or would use it. Other people, I mean, in the worst case, then you would call one of those guys. But that would be the last line of defense. The other thing, what I was pointing out, that even in the ProTech, where we don't have an oscilloscope function, we still have some other tools that we can use for similar diagnostic. That would be then call Elmer, call David, call me, and say, hey, I need to monitor that signal because I want to make sure that it's stable. How can I do that? Again, on the Rockwell side, it's easier, but I just wanted to show that it's there. Yes?
Are you able to see the encoders or resolvers things in the oscilloscope as well?
Yes. Mm-hmm. Yeah. You see the resolver, the encoder also. Yeah, I just changed the program because I was under the impression we were done with the oscilloscope function. So I think we have to sit together because I think Daisy wanted to not go too deep into something that we basically never really need for integration. So that
the whole intent is to try and troubleshoot and determine where the problem may be and avoid having to go in that program. So the tools that Matt is showing you is in dire need of troubleshooting that you just can't pinpoint where the problem may be. There is enough diagnostics there is a lot of diagnostics provided by this VFD to the PLC that should help you in that troubleshooting to the point that you should not need to go into the VFD program. Okay, and this is where this is what I would like to make sure that you guys understand, that there is so much more diagnostics that we are providing from this VFD than we have ever done before. And if you cannot troubleshoot it with all that diagnostics, I'm assuming you're probably going to end up calling these experts from GSD at that point, as opposed to trying to go into this program, because you're only going to use it, well, hopefully you will never have to use it. It's our idea, okay? The only, and I'm only talking to you, Baram, because you are after sales.
Yes.
Okay. For the integrators, there's a lot of tools here that they can use because of the fact that sometimes we, GSD, don't test the product. So they may be looking at the currents, they may be looking at cycle times and so forth because they're still integrating the system.
Yes.
Okay. And this is why this training looked at everything involved with the VFD. Now, as far as the software is concerned, is there anything else that anybody can think of that we want to go over?
The homing sequence, I'd like to know.
The homing sequence is particular to the device. It's
Or
not,
worse of
it's to the process. Yeah, what you're asking for it's nothing to do with the Lenza motor itself or any, I mean, the homing process is it's part of the PLC and part of the process from the HMI. If you want to go over that, you're going to have to probably go to the floor to see what that looks like from the Siemens HMI for that particular application.
Synchronization.
Yes.
Yep, same.
Yeah, and that's the same thing regardless of the VFD that you use,
Regardless
whether
of
it's
Siemens.
Rockwell or
Yesterday I went to
Emerson or.
yesterday I went to the Warren truck and basically helped them out with the homing sequence, and but I wanted to see that if there's something that do we do anything in the drive itself, or is it just restricted to the PLC and then we do it from the panel?
Well, you can see that out at Chap when you go there too.
Anyway, they have.
You can move independent motion, you can move with the HMI, move an arm off of the 5 degree, or you can home it again.
If you think about the VFD as just an arm.
Yeah.
And all it is you tell it to go where? Is it forward? Is it reverse? How fast? It goes. So that homing sequence really is, regardless of the product, is dependent on the PLC program.
Nothing has to do with the
Not here.
drive itself. Gotcha.
Well,
The
it's all
feedback-
built into the drive program.
Yeah, I mean.
Are we able, is there any parameters or anything that, let's say,
It's not your
PLC or no
changing
PLC,
that
I
from-
have to set in order to do that synchronization between two drives?
Nothing for the Lenza to do other than you telling what you want the drive to do by pushing a button.
On the HMI.
Yeah, you know what, let's explain from the drive side. When I have to set up the homing mode in the drive, I have to go here to the screen, application parameters, basic function homing. I have to tell the drive where it gets the homing reference mark from. That is digital input 3. Then I have to select the homing mode. That means I'm traveling in one direction until I see it. And then when I see it, for me that is, that would be 0. And then I want to stop at a 5-degree offset.
Then basically we are setting up on the.
Yes, but I don't understand why you need to change something like that.
I don't need to change. I'm saying that where it is located in the VFD.
Ah, okay, yes. Yeah, it is, in this case, basic functions, homing, and then those are the homing parameters. And now what the PLC does, it has to activate the homing mode, and then it has to tell the drive, basically go into homing mode. Then the drive starts moving until it sees bit number 3, input number 3. Then it reverses 5 degrees off, stands still, and tells the PLC homing is done. So.
And the teaching happens on this part, or?
There is no teaching.
There is no teaching.
Teaching would be if you don't have a homing mark. In this case, we have a homing mark, so we home it. When we say teaching, it means we run it in, like the operator runs it to wherever he wants, and if he's fine with that position, he presses on a button and basically confirms that's the position. We use that, for example, on the forks. You run the forks into the middle position. So is that the middle? Yes, it is the middle. And then you say, whoop, I want to teach that now as center position. And the synchronization, I think that's something we can, or we have to talk maybe in 101, because there I have to, or the drive decides who needs to catch up, and then makes a decision who needs to catch up, and then whoever that is tells the leader or the follower to move to the other one, vice versa position. And that's.
As long as you got that properly defined as who's the leader and follower and the right program loaded, you should just be able to go to the HMI and do what you need to do.
Yes.
So that's the ultimate thing, is to make sure your leader and follower is right. If you're replacing drives or whatever, and you're replacing the chip or whatever, to make sure you have the right programs and the right drives, and you should be able to just do everything from the HMI.
So the question is, what was wrong at Warren Truck?
Warren Truck, what happened is that they had no part present in the carrier Versa lifter, and then in the morning at 5:48, whatever happened, they moved the arm, and display did not show anything. It just showed question mark, question mark, question mark. And then finally, they weren't able to do the homing, and what happened is that they had to move the carrier out of, they didn't know that they have to move the carrier out of the station so that they can do the homing. And I told them, I called them and I told them that they have to move the carrier, and then they went over there and released the brake and moved the arm until they got a number on the display.
Mm-hmm.
And then from that point, they started the homing sequence.
Yeah. When they get it off the over travel switch.
Right.
Yeah.
Was this the Ford problem?
No, it was the Chrysler at Warren Truck assembly plant. It was yesterday, morning. And that's basically what it happened. And I thought that if there was anything on the drive itself that we have to do in order to.
And those are, I don't know, new guys who just started working at that plant, or
I'm sorry?
those are new guys, operators,
No,
or?
well, I don't know the guys, but the guy that he
Mhm.
put it back together, he knows what he's doing. Yeah.
Okay,
And,
it doesn't sound like, but,
Okay,
but, yes.
what I would like to do is take a break, if it's okay. And then after the break, I'd like to discuss tomorrow and what we want to get into, so we can make sure we know what to do with the video paparazzi. Okay, be back in 15 minutes, please. Yes, sir.
Let me just prepare something. Give me 5 minutes. I will let you know when you can get ready there. Okay, now I want to show two things. Since I'm connected to the drive, I want to show how it looks like when I go online, see the fault history, see the timers counting up. That's one thing. The other thing is I want to compare two parameter sets. I think what I can do is I move this down a little bit, then you have a better view. So the first thing is, what I did is I went online with that drive and I copied all the stuff into this file here, named it copy. I have both in my project. And as you can see here, that is yellow. That means I'm connected to it. Now when I go to diagnostic, this stuff is also highlighted. For example, when I scroll down here now a little bit, I see the power on timer and the power on meter. And then when I use the logbook function, probably comes up with some information. For example, it had the last event was 2 times. It was a trouble, an under voltage. That means the drive was supplied with 24 volts, but there was no 480. And the timestamp was at, what is it? 3516, so that's the amount of hours. Here we're at 3517. So this event was just like an hour ago. That was probably when I powered it up. At first the drive was getting 24 volts, or maybe when somebody powered it down. That's probably what it was. During the power down process, the DC bus was bleeding out, the drive went to a low voltage. Still kept it long enough alive to put it into the fault history. That's what you see here. Then there is a user fault 1. A user fault 1 means that is an event and now I lost the connection for a moment. User fault 1 is a fault that I can create through my program. Maybe Jonathan, or let's see. The function block editor. That is normally done through the, it's even not here. Somebody cleared that out. What else do we have? That's it's like a free programmable fault. In Sterling Heights and in Toledo, we use the user fault 5, USO 5, or user 5 to indicate a problem with safety configuration. When the S7 safety station address and the address inside the PLC, if they don't match, then the drive creates a user fault 5. And it also creates a user fault 5 if somebody does an e-stop, and after the e-stop time or the safe stop time expired, the drive still detects motion while there is no motion. So we have a couple of user faults in our program, but you rarely see that. What else do we have? We have here a motor. I don't even know what that is. Somebody tried to identify the motor, and it probably got like what you call an auto-tuning, and it got interrupted during the process. Then somebody was messing here and had a couple of clamp faults. Here there was a short circuit, an OC1. Somebody shortened out the motor connections. The timestamp here is 3,320. Now we are at 3,517. So that was more than 200 hours ago. Again, that gives you the idea when that happened. All right, and you can get up to 50 of those entries. If a new one happens, then the last one will disappear. Okay, that's what you needed? Yep. I think it's a useful tool if there's something. If somebody tells you, oh, the drive was tripping last night and what's going on there, that's basically where you want to have a look, especially normally during the startup in the beginning. Let's say all the HMIs, the FIS system and all that stuff probably doesn't work, but here the information gets locked, and that's a place where to look for. All right, the other question was how to compare parameter sets. What I did was I already copied the parameter set from this drive. I copied it here into that. That should be now an exact copy. But you know what, just for the heck, what I'm going to do, I change here, I don't know, I change the maximum current from 6 to 5 amps. All right, and now I go here to the root, new project, and then I always have to look for compare parameter sets. Sorry, there it is. Compare parameter sets in application data. You see it. Then you can select which one you want to, or basically you have parameter set A, you have parameter set B. In this file we have only 2. So
is this an offline function too, Matt?
yes, it's also an offline function. Yep. I mean, I can go offline to the drive. If you send me something, in the worst case, for example, if you just send me one file, what I also can do is I can insert a drive or a program from a referential project. So I can go to my master file and maybe import the master file. Or if you say, hey, I just did service on underbody framing station 13 and there was something weird going on, here is a file, then I can take that file and include it into my file for underbody framing, and then I have both files in, or both data sets in one file, and then I can compare it in, yes, so in this case, again, I click here on application data. I want to, in this case, there's just one parameter set in this type of drives. Compare parameter set with this one to parameter set with the copy, and then press on compare. It goes through the routine. Normally in the end, it asks me if I want to display, oh, it's already done. And here it tells you there are 2 things different. Code 22, in the one drive it is 6 amps, in the other drive it's 5 amps. That's what I changed. And also the device name, that is nothing communication related. That is only basically how the drive shows up here in the project tree. That makes it a little bit easier to identify. I already changed it to _copy, but pretty much that's what it is.
So in port 552, the VFDs came preloaded, and some of the products we tested, and most of the products we haven't tested. And for the guys that are going to be integrating it, for the guys that will be integrating the system, the first thing they need to do is make sure that the program in the drive is the correct version, right?
Think then that's a good question. I mean, not even. I think we have to talk about it, like what revision we want to start with, or basically it comes with, I don't know, maybe software revision 12 or so, when we finalized, or when I provided Glendale Heights with a master file. That was 4 months ago or 5 months ago. In the meantime, we did so many drive tuning or improvements. So there has to be an update in the drive, I think, anyways. I mean, it still runs with what they have right now. They just have to fix the IP address issue. Then it should work. But for example, the weight stuff we just revisited a couple of weeks ago. Sooner or later, we want to also implement that into the Ethernet IP version.
I think some of what Daisy's talking about too will be handled by the application ID. It's because the application ID is hard-coded on our side to verify that whatever product we hooked up to, the application ID comes out of the drive to verify that it's the correct one, which is a very simple way of making sure that it's at least the right program. It may not be the most current program, but it's at least the right program.
Well,
You'll
that
be able
would,
to run with that.
Yeah, you should at least be able to get, manual
Mhm.
moving, things like that with.
because what I was hoping to do as practice is basically, if there's anything in Novi that's powered up, anybody that has a laptop can go in and see if it has the right app ID or the right version
Mhm.
of the software. I just don't know what's powered up.
I mean, they have, in the laser cell, they have the 4 drives, the 2 doors, the pop-up, and the power roll bed powered up, but that is already also programmed. Next to the laser cell, I think laser cell is station 4. Station 3, at least last week, always had a motor, a power roll bed, a full-blown power roll bed there, but it was not wired up. What we could do if we want to do that, we just take a really long 24-volt extension cord and then apply 24 volt to that Protec on the power roll bed. And then we also we can use a diagnostic adapter, or we need Ethernet cable that has on the one side an M12 connector, and then go from there. So, yep, and then we can see what is there inside. It should be a kind of good power roll bed program with a kind of wrong Ethernet IP address. And
Well, with regards to the laser cell, the transfer
yes.
needs to be updated, right? For sure.
Yeah, but I'm sure what they got
It
will run
works.
just fine in auto.
It works. And my point is that the program that is in the VFDs right now for Ford needs to be updated to the latest versions.
Yes.
As far as what version number we want to call it, to me, it's irrelevant for me as long as we know what that reference point is. But the point is, we still have to update that program.
I think what is right now in the Ford project should work with what the guys have in the PLC. It will work if we fix the Ethernet IP address, but in addition to that, we have to update it anyways to bring it to the latest revision. But the question now is then, when do we want to do it? I probably would still wait a little bit to maybe see the first line working, or maybe the first couple of drives, and then, yes, maybe David can go there and, like Andrew did before, and updated everything in one shot. The other nice thing is now, since we don't have safety parameters, that memory cloning device I showed, or Chris showed yesterday, is also a really powerful tool. Once we update one power roll bed, we can clone maybe 20 memory chips and give them to you guys, and you just pop them into 20 power roll beds. You give us the other 20, and so we rotate through. And the only thing what you maybe have to do is adjust the Ethernet IP address by keypad or by diagnostic interface. That some
Do the name too, right? Name and
on now we are talking Allen Bradley Ethernet IP. They don't have a station name. Yep.
What do they have out in the line besides power roll bed?
They have the Versalets over there. They have Versaroll line and they have a power roll bed line. Over
Powered
there.
up?
No.
I think right now there is almost nothing powered up, only the laser cell. That was at least last week. I don't know what happened.
I haven't been there for 2 weeks. But I like the idea of just when we have the program pretty much set, depending on when we actually commission the line. I like the idea of having a lot of chips and just cloning it and then going boom, 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 and that way we don't even need to hook up anything.
And I mean, if we have a handful, if we have 10 or 20, even that works, because then whoever integrates it can do 5, 10, and give us the, I mean, even we can give you guys the cloner, or we can leave the cloner in Novi with some really, I mean, you guys used it in the past. It is what is it? Idiot safe. I mean, really, it's like bulletproof, really. It's the only thing what's kind of bad, you cannot lock the program. For example, if I give you a memory chip and I label it like original power rollback program, unfortunately here is not a overwrite protection. I mean, if you put it in the wrong spot and you press a transfer button, then it's gone. But besides that, it's really bulletproof. So, yes, one thing, Ethernet IP addresses, MAC addresses. I think I showed that before. Do it again. If you have a drive, like this one here, it's like a tree. You have here the Profinet options. You can click inside. And in this case, there's nothing set up. There is no station name, no Ethernet IP. Normally now I can type in here the station name, or sorry, the Ethernet IP address, and so on. And I can type in here my station name. What I also can do, that is what I download to the drive. There is also, when you go to diagnostic, what is right now active inside the drive. For example, there is no station name right now, and right now the drive is not talking. So there are 0 cycles per second. That just means, I mean, there is no PLC. But that's a pretty useful tool for verifying the communication. On the Ethernet IP side, let me show that also. It looks a little bit different, and it really hurt me because yep.
Does Rockwell have a utility that allows them to define the IP address like Siemens does, or no?
No.
So they have to do it from the drive?
Yes. So the question was the Ethernet IP address here in the drive. When you use Siemens Profinet, you have the capability to go to the Siemens PLC or to the Siemens program and assign the Ethernet IP address through the Siemens to this drive. The same as with a Profinet station name. So you can basically bring up the communication without touching the drive by itself. You can do that. You can do that through the Siemens integration software. On the Rockwell and on Bradley side, you cannot do it because Nathan, one of your guys, was even talking to an Alan Bradley guy, and they explained it that way, that it is really difficult for third-party suppliers like Lensa is to get integrated in RS links. That is kind of, compared with Siemens, it is more a closed environment. In Siemens, you just have to import the GSD file, and then basically everything is fine. In Rockwell, I mean, it talks to the drive and everything works, but you can't get the same benefit as you would see from a Rockwell drive. So you can't use RS links and configure the drive through there.
That's if Rockwell lets you play nice on RS.
What about High Discovery or another utility like that? I mean, you were using High Discovery.
Well, High Discovery only does
You can't boot P in?
I don't know. I don't know. You probably could use BootP, but when we were talking about it, we decided to go with a fixed. Let me show you here.
Yeah, with a fixed IP and then using the little remote that you showed us yesterday, right? We could go through and set the
Yes. Here, when you're basically the structure is the same. That's, for example, the laser booth in Novi. We have the 4 drives: the in, out, the high-speed drive, and the 90mm lift. when you click inside, you see the Ethernet IP, and here you have different ways to configure the Ethernet IP. You can use the stored IP, boot P, or DHCP. And Nathan was debating, or he said, I think, or for him, the best way forward would be to use stored IP address. I mean, if there's something else, you know what, at first you guys decide what you want and tell me. I'm not really the Ethernet IP expert. I don't know what Ford likes. So those are just the options.
My question is once I send it to use boot P, after we do that, we then set it up to use the stored IP afterwards.
I think he mentioned something similar like this, but I think it's not possible that basically I set it up like that and then it automatically switches this over. I don't think that's possible. If you still had to go in with the Lenses software, I mean, the other option would be if you use, I mean, there's a way to use explicit messaging, and you would, after you establish the communication with boot P, you write on that code with explicit messaging on code 13,005, and you change now the value from 1 to 0, then that would be possible. And then you also have to save the parameters with code number 2 in the memory card.
Mm-hmm.
But I don't know. I mean, if that works.
Well, a lot of times, what we do now already for the boot for Ethernet IP devices for like Turk and some of those, like the Turk devices come in kind of like what you have set up for the first 3 octet set. Then they have the rotary switches to set the last couple. But there are other devices that we do have to do boot P already, so most people know how to do that. And it'll be a little bit. I mean, you do have to verify the MAC ID versus the boot P that comes up. That's what it comes up with is the MAC ID. So you have to get just a handwritten list usually of where each of your devices are.
Yes.
For MAC ID. So.
Or limit the connection. So
Or you start hooking everything and then hook things up one can at a time. So.
Yep.
Did he show you the radio button?
That's what I'm just going to do.
Yeah.
The hello.
I think I showed you. Yep.
Yeah.
Yep. Sorry for the. Yeah, there is a nice feature if you're connected to a ton of drives. To make sure that you're connected to drive number 11 and not that you're connected to drive number 10 or drive number 12. Let me just get reconnected to this drive here. That takes another 30 seconds or so.
What are we doing here?
We are discussing one discussion was how to assign the communication address, the Ethernet IP address, for the Ford project. There are different options. One option we call boot P. The other option would be to assign a fixed Ethernet IP address inside the drive. And we were just debating about different ways to do it. And now what I want to show, let's say when I have a huge project with a ton of drives and I'm talking to this drive, let's say I have a line with 20 drives. I mean, I know I'm talking to one, but I would like to know which one that physical is. I mean, in this case here, what's also nice to know, if you click on this, it also shows you here the actual communication settings, what you normally would use to communicate to that drive. But yep, here in this case, we are just using the diagnostic adapter. And then if you click on this button here, the optical tracking button, at first you can select how long it will be flashing, because sometimes it maybe takes you a minute to go there. You can say, I want to have it flashing for a minute, and now you see they flash like crazy. On the ProTech, if you have one of those drives, you can do the same with this one. And here it would show you on the display, hello, flashing. So then you know you're talking to the right drive. Or
so if it's in a return loop, you can do it for 5 minutes and then you can walk up and make sure we can
Can you move your pop? Oh, thank you.
oops.
You have electronic data sheets for these drive PDFs?
Yes. The electronic data sheets. Mm-hmm. Perfect. So, yes, communication settings on Profinet. What we have now, we can even compare it. It almost looks the same. Here we can assign the Ethernet IP address. In Profinet, you don't have the options with boot P or something like that. You can do it from here or through the PLC. In Ethernet IP, you have here those three options. Right now, when you get the drive from us, it is set to use stored IP. Then something that really bite me were the communication monitoring settings. In Profinet, let me show you there's a difference. When you go to monitoring, you have here just one setting where you say the response. You can turn it basically on and off, say no response, fault, and so on. And here you enter a monitoring time. In Toledo, we run with 20 milliseconds because the bus runs in an 8 millisecond cycle. So if we miss like 2.5 cycles, the drive will trip with the CI fault. So on the Ethernet side, Ethernet IP, the monitoring looks a little bit different. And when I set it up the first time, I did, because I didn't knew better, I turned on this overall Ethernet communication timeout. And then every time I was talking with my laptop to the drive, I created a communication fault. So I had to talk to a colleague in Germany, and he recommended to read the manual. Yep, and then that was a little bit frustrating. But in the meantime, or while I did this, I found out that in Ethernet IP, we have 4 different methods or options to monitor communication settings. We have here what we call the idle mode, the fault mode. We can monitor explicit messaging timeout, and we can also monitor the communication between the computer and the drive. There the idea is, for example, if you don't have a PLC and you want to control the drive for testing by the computer, you want to make sure that if you need to turn off the drive, but maybe somebody disconnects you, that the drive shuts it off by itself. You get the point there. So therefore, you can enter here, you have this overall Ethernet communication timeout. Here you would set the time frame, and here you would set the response. Unfortunately, I set it to fault, and then we got a lot of communication faults. There was an 8D going to fault, and now everybody is really upset. The solution is just to turn it off, because I didn't know it, now I know it. The communication between PLC and drive is done with this value, or with this setting here, with the fault mode. And then another difference is that in Siemens, I have to define the reaction time in the drive, for example, 20 milliseconds. In Allen Bradley, I don't do that in the drive. The PLC does it for me. Unfortunately, they don't show it here. So what you have to do, you have to dig in a little bit. You have to go to all parameter, and then you go, that was one of your questions. Now you see here, you have the Ethernet IP options. And then when you go to, I think, it's not here. It's not there, Ethernet configuration. Here, Ethernet configuration. No, that's still not there, hold on. There we are. If you click now on this one here, you will see you have here two, you're connected to there's a first connection is active. The PLC sends an interval or a new telegram every 20 milliseconds. And it also, this value also comes from the PLC. It created a 160 millisecond timeout window. That means now when the drive is missing communication for 160 milliseconds, then the drive will trip with an CI fault. Unfortunately, I didn't knew that when I set up the first time the drive. I thought the way to do it was this way, and that really is still causing a lot of problems. Not problems here, more problems in our internal processes with AD systems and so on. But
so let me ask you then, at that point, that file you worked on was sent back to Lenza, and those are the ones programmed coming in, so we have to change that?
I have to look how I set this up. I think I set this one up to 50. The problem is because that's the smallest value I have to use. I can't use here, for example, 20 milliseconds like I use in Siemens. I can only use 500. I know for sure that's what I put in. I mean, when I put that in, there was nothing to test. I don't know if I changed this to no response or not, but when I went maybe six weeks ago or 2 months ago, when I went to Novi and we made the laser cell working, I was playing with this one here, and I thought, okay, overall Ethernet communication timeout, that looks important. So I turned that on, and from there, shit hits the fan. And really, and then I kind of asked my colleague in Germany, and he really said, you know what, you better read the manual. In the meantime, we also had a manual, because in the beginning it was kind of a new product. It was not existing, and I was too lazy to read it. But anyways, I figured this out, and I found out that we don't really need this one here. This one is just to, or the overall intention is to monitor the communication from here to there. So we don't really need it. And all what we need is already here with the fault mode. And the time here is, or the time window for here is generated by the PLC. And we found out that Nathan, or whoever did it, set it up for 160 milliseconds. I also confirmed that. I put a program inside the drive where I sent information from the drive to the PLC and back. I disconnected the Ethernet, and after 160 milliseconds plus a little bit delay, the drive was always tripping, so that was good. I mean, again, that's, for me, this whole Ethernet IP stuff is also like a learning experience. Maybe Mike or one of you guys know this idle mode a little bit more, or there's like a bit from the PLC that you can set, and then the drive or the node goes into an idle mode. I don't know if that's something we can use, or
there's an inhibit mode.
That's probably what, I don't know where the benefit.
We do our own check on it to see if we put it in inhibit mode or see if we have a comm loss.
Mm-hmm.
We set a fault message based on that.
Okay.
So we already have a fault messaging structure based on that.
But
so if you don't have your IP set, let's say, you get a comm fault.
Okay.
Somebody plugs a cable, you get a comm
yes.
fault. The inhibit is, you would actually right click on the drive from the tree that you see inside the processor, and you would tell it to inhibit that module.
Mm-hmm.
So then at that point you would stop talking to it.
Okay.
But it's something that you did yourself.
Yes.
So it's set up as a manual intervention in the forward.
Okay. I think that's what it is, and I don't know if we.
I don't think you need to do anything with it, because I stopped talking to you from my
You
side.
inhibit it as far as scanning.
Yeah, I don't scan it. I don't get any data in
That's
or
the only way
out
it's
of it.
inhibited
Mm-hmm.
is because you don't scan it.
Right, it's inhibited in the processor tree.
Mm-hmm.
So at that point, I just stopped looking for it.
I think with the idle mode, I can I can tell the drive that you don't scan me anymore, and then in that case, that's the impression I got. I don't trip with a fault because you told me like, oh, I won't communicate to you anymore, right. And then I already know it. But
and at that point, I throw a fault on the HMI and the FIS anyway, so I know if somebody put it in inhibit mode.
But I mean, right now, how the drive is set up, this one, the fault mode is active, and the monitoring window is set through the PLC. In this case, in the laser booth, it's 160 milliseconds. I mean, I tested it. It was working fine. I unplugged the cable. The drive, after 160 plus, I tested it 3 times. It was 170, 180, and 185 milliseconds. That's what I internally detected. The drive tripped So, I mean, I think that's.
We could probably test that tomorrow. It wouldn't take but a couple minutes out of their time if you want to just
Okay.
on one of the one that's running, to just right click on it, tell it to inhibit, you could probably hook up and see what it does differently.
Okay. Yes.
See how it reacts.
But,
you can tell them I said it was okay. Don't do it Thursday.
Yeah.
Or Thursday, you're right. Do it Thursday. Don't do it Friday.
So then in diagnostic you will see here if, or in this case, the port number 1, the first port, was connected to the PLC. It's operational. You will see here the MAC address, and if you would click on this one here, probably now up, you get even the data. So also when you change the Ethernet IP address, if you connect, for example, through the diagnostic interface, you would change it now. When you get a new drive, it comes in here 192, because I flipped those two. If you want to fix it, you change it back to 129, and then when you're online, you also, okay, let me show it here, it's a little bit easier. For example, after you change the Ethernet IP address in the drive, oops, that was funny. You have to go back to the root, to the drive, and then you can click on this icon, save parameter set. That is one way to do it. Or let's think online. Here you find it. It basically does the same, save parameter set. Or the third way would be parameter set. If you click on the list, I mean, and that's basically how it's done internally. You have here, when you go to code 2, subcode 11, if you click here, or if you go there, in the end, the GUI goes to code 2, subcode 11, and changes it from 0 to 1. Let me show you here. Now you get this one, and you just saw there was something changing, or here it's working. And now it's done. So that means whatever you just changed in the drive memory, in the RAM, got transferred into the memory chip, into kind of the EEPROM. And also, if you change the communication settings through the lens side, you need to cycle power. So when the drive boots up the next time, it will take the new communication settings from the chip. There are no safety settings in this drive. If you click here, safety options, there is nothing to program. There's nothing there. On the Siemens side, we would have the safety address and the safety parameters. I mean, you guys know that. If one of the other guys ever run into that issue, then let us know. But I think we are more 552 focused. So.
Is there a device to edit the memory chip without a drive?
No.
No. I didn't know if there was like an external thing you could plug into.
How many pins is that on the chip? 16 pin?
I don't know, 10? Hard to tell. I think that is just, it's not, I don't know if you can come up. I mean, for me, it looks like it's a memory chip that goes right into the microcontroller. You know what I mean? It's not a card reader or something like that. Yeah, but that's, I mean, okay, if you want to play around, but I think it's a waste of time. It's really a waste of time. Give that a
You brought up using the diagnostic adapter a couple of times. Did you tell everybody to not plug an Ethernet cable into that port?
Yes, I did it a few times. Yep, the Ethernet this port has 10 pins. A plain Ethernet cable has 8 pins, and it's possible, at least I was told, I've never done it, that you damage the port when you plug it in.
When we talked about it, somebody had mentioned that we might want to put something on there, some note that says, don't get it. But
Usually there's
Yeah.
display
Probably
the
be a good
keypad,
idea.
the keypad is normally above it, and because what we looked at when we were discussing it is the memory card is to the side, so there's no reason why you should need to unplug that card.
But on the ProTech, it's not
Yes.
like that.
Except in cases where somebody just plugged in as a diagnostic adapter and didn't put the interface back on.
Well, we talked about that
Yeah.
because our design in the panel has the keypad, but the spare drive does not have the keypad. So when you replace it, you have to take that keypad from the old and put it in a replacement.
Well,
So
that's a
there's
good
still
point.
that
Yeah,
point
never,
of,
never send a
oops, I
bad drive
forgot to
out
put
with
the
your
keypad on.
interface module on it.
Hence the little warning.
Yeah, that would be a nice
I don't, yeah. I mean, you also have to keep in mind when we did the installation in Toledo, I'm sorry to say this, but one of your guys, for some stupid reason, he took some how you call it, needle noses and pulled out one of those inserts from the ProTech. I don't know what he wanted to do, but I mean, there is just so much protection you can put into the system, but you know what I mean? Oh, yeah. Oh, Andrew told me that from a long time ago, yes. But I don't know why it was not Andrew, but it was, yep. You know, I mean, stuff like this is, I mean, you can put so much protection in, but I don't know. But anyway, I mean, it's a valid point. This one is not an Ethernet cable. And also I got this one email from Daisy, from Bill. You asked for the part numbers for the cable. Yes. And one of this, Rob responded, and he said the one is a generic printer cable. And he said in this mail that is an Ethernet cable. And I almost responded yesterday evening to it and said, no, it's not, but I already had 3 beers, and I was really upset that I screwed this one up, and I got a couple of more emails regarding this 8D NCR stuff that is flying in your company around. So what is it? I was upset enough I didn't respond to that email. But
What I'm looking to do is basically have enough for our guys. We have, 6 software guys on our team? And I want to make sure we have
yes.
what we need for the...
Yeah, here's even Daisy. It's an EWL 0070. It's all there.
EWL
0070. That's pretty much the Lensa part number. I mean, if you order that,
it's a diagnostic cable?
yes.
Well, you gave me one because he took my other one, so
I had one. I was taking mine twice.
I think you better can. When I find it.
Tell me what we're doing.
Okay, I want to show you what we implemented in Toledo for the 2-column elevator, because in the 2-column elevator with a power roll bed, when you drop the power roll bed in station 1 onto a belt, do you guys have something similar in Toledo in 552? Yep.
You got a 2-column that drops off to a belt transfer?
I don't recall that we do.
I don't, I don't see.
But
No, we have
just if it's there, yes. What we, unfortunately, the video is here like 90 degrees monitor. But here the elevator is coming down. I'm sorry for that. And then when you normally position it from 6,000 increments to 200 increments, and you do the normal move, it will slam the power roll bed pretty hard here on the elevator. So what we came up with, we implemented another soft touch, like you know from the Versa lift. So when it goes down and lowers the load, just before it kind of the drop-off position, it slows down and basically drops off the power roll bed kind of smoother on the belt, and then it keeps going to the final position. That's something you can see in this video, and that also needs to get configured in the function block. There you have an input where, I don't know how you guys call it, but you can select between an elevator with this and without it. And then you get this kind of nicer soft touch where it stops a little bit, and then you can see the elevator going down. Okay,
Is
that's...
that a teachable position, or is that hard-coded?
It is hard-coded automatically so many increments for your, before your lower target position. So if you go down, whatever target position you select, before I have to look, let's say 200 counts, it starts slowing down. Mm-hmm.
Okay.
All right, that's all I wanted to show. And
you had a soft touch feature for a pickup as well, right?
no, for a pickup we don't do it, because at a pickup we are already. I don't hear.
The forks, yeah.
Oh, okay. You forks pickups.
That's the forks on station 13.
Station 13.
Underbody frame.